All right, so let's go through this Codecademy course on JavaScript. What is JavaScript? Last year, millions of learners from our community started with JavaScript. Why? JavaScript is primarily known as the language of most modern web browsers, and its early quirks gave it a bit of a bad reputation. However, the language has continued to evolve and improve. JavaScript is a powerful, flexible, and fast programming language now used for increasingly complex web development and beyond. Since JavaScript remains at the core of web development, it's often the first language learned by self-taught coders eager to learn and build. We're excited for what you'll be able to create with the JavaScript foundation you gain here. JavaScript powers the dynamic behavior on most websites, including this one, so including Codecademy. In this lesson, you will learn introductory coding concepts, including data types and built-in objects, essential knowledge for all aspiring developers. Make sure to take notes and pace yourself. This foundation will set you up for understanding the more complex concepts you'll encounter later on. Instructions. Move to the next exercise when you're ready to begin, and there's a concept review and community forum. We'll go to the next exercise. The console is a panel that displays important messages, like errors, for developers. Much of the work the computer does with our code is invisible to us by default. If we want to see things appear on our screen, we can print or log to our console directly. In JavaScript, the console keyword refers to an object, a collection of data and actions that we can use in our code. Keywords are words that are built into the JavaScript language, so the computer will recognize them and treats them specially. One action or method that is built into the console object is the log method. So it's the .log method. When we write console.log, what we put inside the parentheses will get printed or logged to the console. It's going to be very useful for us to print values to the console so we can see the work that we're doing. Console.log 5, this example logs 5 to the console. The semicolon denotes the end of the line or statement. Although in JavaScript, your code will usually run as intended without a semicolon. We recommend learning the habit of ending each statement with a semicolon so you never leave one out in the few instances where they are required. You'll see later on that we can use console.log to print different kinds of data. Use console.log, these are the instructions now. Use the console.log code in the editor to log your age to the console. No problem. Console.log, let's say I'm 99. And then we have to hit run. Run your code when you're ready to see the result. And there I am, 99 years old. Perfect. On the next line, log a number representing the number of weeks you've been programming. All right, console.log. Let's do some quick math. So I'm 99 and I've been programming forever. So we'll do 99 times 52. And there we are. I've been programming since I was born and I'm 99 years old. We got that one all finished. All right, so the next lesson is comments. Programming is often highly collaborative. In addition, our own code can quickly become difficult to understand when we return to it, sometimes only an hour later. For these reasons, it's often useful to leave notes in our code for other developers or ourselves. As we write JavaScript, we can write comments in our code that the computer will ignore as our program runs. These comments exist just for human readers. Comments can explain what the code is doing, leave instructions for developers using the code, or add any other useful annotations. There are two types of code comments in JavaScript. A single line comment will comment out a single line and is denoted by 2 forward slashes preceding it. So 2 slashes prints 5 to the console, console.log 5, and you could also see a single line comment under this. You can actually do the 2 slashes after you console log on the same line. That would be okay too. Now, a multi-line comment will comment out multiple lines as denoted with a /* to begin the comment and a * / to end the comment. Okay, so what we have here is /*, lines and lines of commenting, and then a star, /, and that's all a comment. You can also use this syntax to comment something out in the middle of a line of code. It says console.log, and then ignored is in a comment, and the number 5 isn't, so the number 5 gets printed. Let's practice adding some code comments. To the right, we provided you with the beginning of the book Catch-22 by Joseph Heller. On line 1, write a single line comment that says opening line. And then we'll run. That seemed to have work. Single line comments are great for adding context to your code. Multi-line comments are often best suited to prevent a block of code from running. However, both types of comments can be used for either purpose. Use a multi-line comment so that the bottom 6 console.log statements are all commented out. Okay, 1, 2, 3, 4, 5. My bad. 5, 6. Okay, so it's going to start from here, / and our asterisk, and then we need to end it with our asterisk / and run that. All right, we're done with that lesson. We'll move to the next one. Data types. Data types are classifications we give to the different kinds of data that we use in programming. In JavaScript, there are 7 fundamental data types. Number. Any number, including numbers with decimals. String. Any group of characters on your keyboard, letter, number, spaces, symbols, etc., surrounded by single quotes or double quotes. Though we prefer single quotes, some people like to think of string as a fancy word for text. Boolean. This data type only has 2 possible values, either true or false without quotes. It's helpful to think of Booleans as on and off switches, or the answers yes or no. Null. The data type represents the intentional absence of a value and is represented by the keyword null without quotes. Undefined. This data type denotes the keyword undefined without quotes. It also represents the absence of a value through it and has a different use than null. Symbol. A newer feature to the language. Symbols are unique identifiers useful in more complex coding. No need to worry about these for now. And object. Collections of related data. The first 6 of those types are considered primitive data types. They are the most basic data types in the language. Objects are more complex, and you'll learn much more about them as you progress through JavaScript. At first, 7 types might not seem like that many, but soon you'll observe the world opens with possibilities once you start leveraging each one. As you learn more about objects, you'll be able to create complex collections of data. But before we do that, let's get comfortable with strings and numbers. Console.log, in quotes, location of Codecademy headquarters, 575 Broadway, New York City, console.log 40. In the example above, we printed a string. Our string isn't just a single word. It includes both capital and lowercase letters, spaces, and punctuation. Next, we printed the number 40, and notice we did not use quotes. On line 1, log the string JavaScript. So console.log, and they want JavaScript with a capital J and a capital S. Great. On line 2, log the number 2011. So console.log 2011, and we'll run that. That seems to work too. On line 3, print woohoo, I love to code, #Codecademy. Let's do that. That was a string saying woohoo, I love to code. And exclamation point, #Codecademy. And let's run that. That worked as well. On line 4, print the number 20.49 to the console. Okay. 20.49. Looks like we were successful with that. Let's move on to the next one. Arithmetic operators. Basic arithmetic often comes in handy when programming. An operator is a character that performs a task in our code. JavaScript has several built-in arithmetic operators. I think that's a typo. JavaScript has several built-in arithmetic operators that allow us to perform mathematical complications on numbers. These include the following operators and their corresponding symbols: add plus sign, subtract dash, multiply asterisk, divide forward slash, remainder percent sign. I think the percent sign has another name too. It's not coming to me right now. The first four work how you might guess. And it just shows a bunch of examples of adding, subtracting, multiplying, and dividing, which are all very plain, just console.log, and in the parentheses, 3 plus 4, 5 minus 1, 5 times 2, and so on. Note that when we console.log, the computer will evaluate the expression inside the parentheses and print the result to the console. If we wanted to print the characters 3 plus 4, we could wrap them in quotes and print them as a string. Console.log, now they're showing the remainder operator. So that's the one that's the percentage sign. And there's the name for it, the modulo. The remainder operator, sometimes called modulo, returns the number that remains after the right-hand number divides into the left-hand number as many times as it evenly can. 11, remainder operator 3 equals 2 because 3 fits into 11 3 times, leaving 2 as its remainder. Inside of a console.log, add 3.5 to your age. Okay. Console.log, my age is 99 plus 3.5. Let's run that. 102.5. Perfect. On a new line, write console.log. Console.log and subtract, take the current year, that's 2020, subtract 1969, that's 51. So this is how many years it's been since the 1969 moon landing, 51. Create another console.log inside the parentheses, divide 65 by 240. 65 wants to be divided by 240. Run that. Create one last console.log. Inside the parentheses, multiply 0.2708 by 100. .2708 times 100. That's the percent of the sun that is made up of helium. Assuming we could stand on the sun, we'd all
sound like chipmunks.
27.08% of the sun is helium. String concatenation. Operators aren't just for numbers. When a plus operator is used on two strings, it appends the right string to the left string. And they have a few examples of that. This process of appending one string to another is called concatenation. Notice in the third example we had to make sure it included a space at the end of the first string. The computer will join the strings exactly, so we needed to make sure to include the space we wanted between the two strings. Just like with regular math, we can combine or chain our operators to get a final result. So you can add more than one thing together. Inside of a console.log, inside of the console.log statement, concatenate the two strings hello and world. Note, you should concatenate the two strings exactly without introducing any additional characters. So no space here, just hello, make sure it's capital, plus, and world, the capital W, and we'll run that. And that worked. We left off the space this time. Create a second console.log statement in which you concatenate hello and world, but this time make sure to also include a space between the two words. So from what I saw, there's two ways to do that seem passable for what they're asking. So that, I get one more plus. That should work because we're adding a space right here in the middle, and it should also work just by putting a space right here. So let's try the space in the middle first. See if that's what they want. That's what they want. Great. Properties. When you introduce a new piece of data into a JavaScript program, the browser saves it as an instance of the data type. Every string instance has a property called length that stores the number of characters in that string. You can retrieve property information by appending the string with a period and the property name. The example is console.log hello.length. And it prints 5 because that's how many letters are in hello. The dot is another operator. We call it the dot operator. In the example above, the value saved to the length property is retrieved from the instance of the string. Hello, the program prints 5 to the console because hello has 5 characters in it. Use the dot length property to log the number of characters in the following string to the console. So console.log. And I think I'm just going to copy it, so I don't want to get a letter wrong here. We have that, and then we wanted to do the length of this, so dot length. Let's run that. Perfect. And that's this whole lesson. Okay, to the next one. Methods. Remember that methods are actions we can perform. JavaScript provides a number of string methods. We call or use these methods by appending an instance with a period, the dot operator, the name of the method, opening and closing parentheses. Example string in a string dot method name as a function. Does that syntax look a little familiar? When we use console.log, we are calling the .log method on the console object. Let's see console.log and some real string methods in action. And they have some examples where they are doing 2 uppercase and starts with uppercase H. Okay, one of them 2 uppercase is going to make the string preceding it have an uppercase letters, all of them, and starts with an uppercase H is going to print back a true or false statement, it looks like. Let's look at each of these lines above. On the first line, the uppercase method, toUppercase method is called on the string instance hello. The result is logged to the console. This method returns a string in all capital letters saying hello. On the second line, the dot starts with method is called on the string instance hey. This method also accepts the character H as an input or argument. Between the parentheses, since the string hey does start with the letter H, the method returns a Boolean true. And that's just about what we said. You could find a list of built-in string methods in this JavaScript documentation. Great. So use the .toUppercase method to log the string Codecademy. Okay, so that first one, .toUppercase and function. Let's run that. Oh, something broke. Oh, I put that in the wrong spot. Let's grab that real quick. Try that again. All right, that works, that's right. In the second console.log statement in app.js, we have a string remove whitespace, which has spaces before and after the words remove whitespace. If we browse the JavaScript string documentation, we find several built-in string methods that each accomplish a different goal. The one method that seems ideal for us is trim. Use this method to remove the white space at the beginning and end of the string in the second console.log argument. So right here, dot trim as a function, and let's run it. And that's what they want. Great. Let's move over to the next lesson. Built-in objects. In addition to console, there are other objects built into JavaScript. Down the line, you'll build your own objects, but for now, these built-in objects are full of useful functionality. For example, if you wanted to perform more complex mathematical operations than arithmetic, JavaScript has the built-in math object. The great thing about objects is that they have methods. Let's call the .random method from the built-in math object. Console.log, and then math.random, and it prints a number between 0 and 1. In the example above, we call the .random method by appending the object name with the dot operator, the name of the method, and opening and closing the parentheses. This method returns a random number between 0 inclusive and 1 exclusive. So it can be a 0, but it cannot be a 1. To generate a random number between 0 and 50, we could multiply the results by 50, like so, and they just did math.rand times 50. The example above will likely evaluate to a decimal to ensure the answer is a whole number. We can take advantage of another useful math method called math.floor. It takes a decimal number and rounds down to the nearest whole number. You can use math.floor to round down a random number like this. Math.floor, and then in there math.random multiplied by 50. In this case, math.random generates a random number between 0 and 1. Then we multiply that number by 50. So now we have a number between 0 and 50. Then math.floor rounds the number down to the nearest whole number. If you wanted to see the number printed to the terminal, you would still need to use a console.log statement. And they have the console.log statement set here with the math.floor, math.random. To see all the properties and methods on the math object, you could take a look at the documentation. Instructions. Inside of a console.log, create a random number with math.random, then multiply it by 100. Okay, console.log, and they said random number with math.random as a function. And then we'll multiply that by 50. Oh, they said 100. Multiply that by 100. Sounds good to me. Let's run that. And it did work. Now we use math.floor to make the output a whole number. So inside the console.log, you wrote in the last step, put the existing math.random times 100 code inside the parentheses of math.floor. So what we'd want to do, I'll get a little space, math dot and floor like that. And we want all of this within math.floor, but we also want console log to finish outside of math.floor. So this is actually console log is your last one, then math.floor, and then you have your random. So let's run that and see if that works. It does, and we got my age, 99, perfect. Find the method on the JavaScript math object that returns the smallest integer greater than or equal to a decimal number. Use this method with the number 53.8, log the answer to the console. So I'm looking for the JavaScript math object that returns the smallest integer greater than or equal to a decimal number. So we could take a look at the math object and see if we could find that. I think they're looking for math.ceil here. Let's take a look at that. 43.8. So we'll console.log math.ceil, and there we'll put in the 43.8 and run it. Oh, I did ceil wrong. There we go, just a little typo. That's what they were looking for, math.ceil. Use the JavaScript documentation to find a method on the built-in number object that checks if the number is an integer. Put the number 2017 in the parentheses of the method and use console.log to print the results. Okay, let's take a look at that. And what I find here in the static methods, we have number.isInteger, and we could use that. Let's try that out. So we'll console log number.isInteger, and then we need to pass in 2017. See what happens there. And it comes back as true. So let's go to the next one. Review. Let's take one more glance at the concepts we just learned. Data is printed or logged to the console, a panel that displays messages with console.log. We can write single line comments with 2 forward slashes and multi-line comments with *****. There are 7 fundamental data types in JavaScript: strings, numbers, booleans, null, undefined, symbol, and object. Numbers are any number without quotes, 23.8879 as an example. Strings are characters wrapped in a single or double quotes. Sample string wrapped in a single quotes is the example. The built-in arithmetic operators include plus, minus, multiply, divide, and the modulo. Objects, including instances of data types, can have properties, stored information. The properties are denoted with a dot, the period, after the name of the object. For example, hello.length, and the hello is a string. Objects, including instances of data types, can have methods which perform actions. Methods are called by appending the object or instance with a period, the method name, and parentheses. For example, hello as a string, dot to uppercase, and then the parentheses making hello uppercase. We can access properties and methods by using the dot operator. Built-in objects, including math, are collections of methods and properties that JavaScript provides. All right, so we got through this one. Let's continue this. We'll go on and try to finish all of JavaScript. Let's make our way through variables. So variables. In programming, a variable is a container for a value. You can think of variables as little containers for information that live in a computer's memory. Information stored in variables such as username, account info, or even personalized greeting can be found in memory. Variables also provide a way of labeling data with a descriptive name, so our programs can be understood more clearly by the reader and ourselves. In short, variables label and store data in memory. There are only a few things you can do with variables. Create a variable with a descriptive name. Store or update information stored in a variable. Get information, and that's get with quotes, information stored in a variable. It is important to distinguish that variables are not values, they contain values, and represent them with a name. Observe the diagram with the colored boxes. Each box represents variables. The values are represented by the content, and the name is represented with the label. In this lesson, we will cover how to use the var, let, and const keywords to create variables. Instructions: when you're ready to start, click the next. Okay, so we're moving on to the next exercise. Create a variable var. There were a lot of changes introduced in the ES6 version of JavaScript in 2015. One of the biggest changes was 2 new keywords, let and const, to create or declare variables. Prior to ES6, programmers could only use the var keyword to declare variables. Var myname equals arraya, console log myname, output arraya. Let's consider the example above. Var, short for variable, is a JavaScript keyword that creates or declares a new variable. myname is a variable's name. Capitalizing in this way is a standard convention in JavaScript called camel casing. In camel casing, you group words into one. The first word is lowercase, then every word that follows will have the first letter uppercased. Camel casing. Equals is the assignment operator. it assigns the value araya to the variable myname. Araya or aria, I'm not sure how this is said, is the value assigned equal to the variable myname. You can also say that the myname variable is initialized with the value aria or araya. After the variable is declared, the string value aria is printed to the console by referencing the variable's name console log myname. There are a few different rules for naming variables. Variable names cannot start with numbers. Variable names are case sensitive, so my name and my name, one has one uppercase N, the other one doesn't, would be different variables. It is bad practice to create two variables that have the same name using different cases. Variable names cannot be the same as keywords. For a comprehensive list of keywords, check out the MDN's keyword documentation. Note, in the next exercise, we will learn why ES6, let, and const are the preferred variable keywords by many programmers. Because there is still a ton of code written prior to ES6, it is helpful to be familiar with the pre-ES6 var keyword. If you want to learn more about var and the quirks associated with it, check out the MDN var documentation. Declare a variable, this is the instructions now, declare a variable named favorite food using the var keyword and assign it to the string pizza. Okay, so we were going to say var and type in favorite food, and food's going to be capital F because we're camel casing, and then we're going to assign it to a string named pizza and run it. Looks like that worked. Let's declare a variable called num of slices. So var num and of slices, camel case, and equals 8. Let's run that. And that works. Great. Under the num of slices variable, use console.log to print the value saved to favorite food. On the following line, use console.log to print the value saved by num of slices. Okay, so we will console.log favorite food, and then we'll just do it again. Num of slices. And let's run that. And that's the end of this lesson. Let's move over to the next one. Create a variable let. As mentioned in the previous exercise, the let keyword was introduced in ES6. The let keyword signals that the variable can be reassigned a different value. Take a look at the example. Let meal equals a string called enchiladas. If you console log that meal, the output will be enchiladas. Now, if you just write meal equals a string called burrito and you console log after that, it's going to give you an output of burrito, so the value of meal has changed. Another concept that we should be aware of when using let and even var is that we can declare a variable without assigning the variable a value. In such a case, the variable will automatically initialize with a value of undefined. So let price, console log price, output is undefined. Price equals 350, console log price, output will be 350. Notice in the example above, if we don't assign a value to a variable declared using the let keyword, it automatically has a value of undefined. We can reassign the value of the variable. Create a let variable called changeMe and set it equal to the Boolean true. Let changeMe equal true. And we'll run that. Great. On the next line, after changeMe is declared, set the value of changeMe to the Boolean false. To check if changeMe was reassigned, log the value saved to changeMe to the console. Okay, changeMe equals false, console.log changeMe, and run. And it is false. Let's go to the next lesson. Create a variable, const. The const keyword was also introduced in ES6 and is short for the word constant. Just like with var and let, you can store any value in the const variable. The way you declare a const variable and assign a value to it follows the same structure as let and var. Take a look at the following example. Const my name equals Gilberto. console.log my name, output Gilberto. However, a const variable cannot be reassigned because it's a constant. If you try to reassign a const variable, you'll get a type error. Constant variables must be assigned a value when declared. If you try to declare a const variable without a value, you'll get a syntax error. If you're trying to decide between which keyword to use, let or const, think about whether you'll need to reassign the variable later on. If you do need to reassign the variable, use let. Otherwise, use const. Create a constant variable named entry and set it equal to the string enchiladas. So const equals string, capital E, enchiladas. And we'll run that. You probably caught this while I was doing it. Entry equals enchiladas. Perfect. Just to check that you saved the value of enchiladas to entry, log the value of entries to the console. So console.log entry. And we could see enchiladas comes to the console. Great, let's see what happens if you try to reassign a constant variable. Paste the following code to the bottom of the program, okay? This code throws the following error when you run your code. Type error, assignment to constant variable. After you clear this checkpoint, if you want to see another quirk of const in action, open the hint. Okay, so first we want to entry tacos and run that. That's done, and take a look at the hint. Since our program stops running after encountering an error, we need to delete the line of code from the previous step. Okay. Now let's test what happens when you try to declare a const variable without a value. Paste the following code into your program. Const testing. You should see a different error this time. I do see a different error this time related to syntax error. Great, let's go to the next one. Mathematical assignment operators. Let's consider how we can use variables and math operators to calculate new values and assign them to a variable. Check out the example below. Let w equal 4. W equals w plus 1. Console.log w output 5. In the example above, we created the variable w with the number 4 assigned to it. The following line, w equals w plus 1, increases the value of w from 4 to 5. Another way we could have reassigned w after performing some mathematical operation on it is to use built-in mathematical assignment operators. We could rewrite the code above to be let w equal 4, w plus equals 1, console.log w, output will also be 5. In the second example, we use the plus equals assignment operator to reassign w. We're performing the mathematical operation of the first operator plus using the number to the right, then assigning w to the computed value. We also have access to other mathematical assignment operators. Minus equals, multiply equals, and divide equals, which work in a similar fashion. There are examples of each one of those. Let's practice using these mathematical assignment operators. Instructions. Use the plus equals mathematical assignment operator to increase the value stored in level up by 5. So level up needs to go up by 5, and here's where we're supposed to do our assignments in the space below. So level up will plus equal 5. That should do it. Let's take a look. Oh, let me get up spelled correctly. That did work. Use the minus equals mathematical assignment operator to decrease the value stored in power level by 100. Okay. Power level, and that was minus equals, and we want to take away 100. And run that. Perfect. Use the multiply equals mathematical assignment operator to multiply the value stored in multiply me by 11. multiply me is, so multiply equal 11, and we'll run that. Perfect. Use the divide equals mathematical assignment operator to divide the value stored in quarter me by 4. So quarter me, let's divide equal 4, run. Perfect, that all worked. Let's go on to the next one. The increment and decrement operator. Other mathematical assignment operators include the increment operator plus plus and the decrement operator minus minus. The increment operator will increase the value of the variable by 1. The decrement operator will decrease the value of the variable by 1. For example, if a equals 10, a plus plus will equal 11. If b equals 20, b minus minus will equal 19. Just like the previous mathematical assignment operators, plus equals, minus equals, multiply equals, divide equals, the variable's value is updated and assigned as a new value of that variable. Using the increment operator, increase the value of gained dollar. Okay, so gained dollar, and we're going to do the plus plus and run. That is correct. The decrement operator. Okay, so lost dollar needs to have a minus minus after it. Lost dollar minus minus. And let's run that. Great, let's go to the next section. String concatenation with variables. In previous exercises, we assigned strings to variables. Now let's go over how to connect or concatenate strings to variables. The plus operator can be used to combine two strings values even if those values are being stored in variables. Let my pet equal armadillo. Console.log, I own a pet, and that's a string, plus my pet plus a string that's period on it will print out I own a pet armadillo. In the example above, we assigned the value armadillo to the myPet variable. On the second line, the plus operator is used to combine three strings. I own a pet, the value saved in myPet, and period. We log the result of this concatenation to the console as I own a pet armadillo, period. Create a variable named favorite animal and set it equal to your favorite animal. Okay, so we're going to do let favorite animal, and we'll set it equal to human. Let's see what happens there. Great. Use console.log to print my favorite animal to the console. Use string concatenation so that animal is replaced with the value of your favorite animal variable. Okay, so console.log. It'll be my, capital, my favorite animal. And then after that, we want a space. I think we could do it like that. Plus, and then favorite animal. That looks good to me. Let's take a look. That did work. My favorite animal is a human. String interpolation, or interpolation, however you might say it. In the ES6 version of JavaScript, we can insert or interpolate variables into strings using template literals. Check out the following example where a template literal is used to log strings together. Const myPet equals armadillo. Console.log with backticks in front of it instead of single quotes. I own a pet, $, open up brackets, my pet, period after the brackets close, and a closing tick instead of a quote. Notice that a template literal is wrapped in backticks. This key is usually located on the top of the keyboard to the left of the 1 key. Inside the template literal, you'll see a placeholder, myPet. The value of myPet is inserted into the template literal. When we interpolate I own a pet, myPet, the output we print is a string I own a pet, armadillo. One of the biggest benefits to using template literals is the readability of the code. Using template literals, you can more easily tell what the new string will be. You also don't have to worry about escaping double quotes or single quotes. Create a variable called myname and assign it to your name. Const myname is, and then it's going to be a string, I imagine. Anthony Santo. Let's run that. Great. Create a variable called myCity and assign it to your favorite city's name. Well, that's a tough one for me. I've lived in a lot of places. Const myCity. I just got back from Penang, which was really, really nice. So I'm going to do Penang, run that. Using a single template literal to interpolate your variables into the sentence below. Use console.log to print your sentence to the console in the following format. My name is capitalized name. My favorite city is capitalized city. Replace name and city in the string above by interpolating the values saved to my name and my city. So we're going to console.log. We're going to put in backticks. Right, my name is $, bracket, and then the variable my name, close the bracket. We'll need a period after the closed bracket, a space. My favorite city is $, open bracket, and my city, close bracket. Let's run that. My name is Anthony Santo. My favorite city is Penang, and I didn't put a period at the end. That's how these things get you. And the period didn't work either, and oh, right here it is. My name is. Let's run that. Great, let's go on to the next one. Variables. Type of operator. While writing code, it can be useful to keep track of the data types of the variables in your program. If you need to check the data type of a variable's value, you can use the type of operator. The type of operator checks the value to its right and returns or passes back a string of the data type. Const unknown equals a string foo. Console.log type of unknown will output string, and so on with number and boolean. Let's break down the first example. Since the value unknown1 is foo, a string, type of unknown1 will return string. Use console.log to print the type of new variable. Console.log, then it was type of, and then new variable, string. Great. Now let's check what happens if we reassign the variable. Below the console.log statement, reassign a variable to 1. Console.log statement. New variable equals 1. And we'll run that. It still says string. Since you assigned this new value to a new variable, it has a new type. On the line below your reassignment, use console.log to print the type of new variable again. Okay, I'll just grab it and paste it. Let's run that. String and then number after we reassigned it. Great, one more here. It's the review on variables. Nice work. This lesson introduced you to variables, a powerful concept you will use in all your future programming endeavors. Let's review what we learned. Variables hold reusable data in a program and associate it with a name. Variables are stored in memory. The var keyword is used in pre-ES6 versions of JavaScript. Let is the preferred way to declare a variable when it can be reassigned, and const is the preferred way to declare a variable with a constant value. Variables that have not been initialized store the primitive data type undefined. Mathematical assignment operators make it easy to calculate a new value and assign it to the same variable. The plus operator is used to concatenate strings, including strings values held in variables. In ES6, template literals use backticks and the open close braces to interpolate values into a string. The type of keyword returns the data type as a string of a value. Great, we got through this one. Let's move on to yet another one. Conditional statements. What are conditional statements? In life, we make decisions based on circumstances. Think of an everyday decision as mundane as falling asleep. If we are tired, we go to bed. Otherwise, we wake up and start our day. These if-else decisions can be modeled in code by creating conditional statements. A conditional statement checks a specific condition and performs a task based on that condition. In this lesson, we will explore how programs make decisions by evaluating conditions and introduce logic into our code. We will be covering the following concepts: if, else if, and else statements, comparison operators, logical operators, truthy versus falsy values, ternary operators, and switch statement. So if you're ready to learn these concepts, go to the next lesson. Oh, here we go. The if statement. We often perform a task based on a condition. For example, if the weather is nice today, then we will go outside. If the alarm clock rings, then we will shut it off. If we're tired, then we'll go to sleep. In programming, we can also perform a task based on a condition using an if statement. If true, console log, this message will print. Notice in the example above, we have an if statement. The if statement is composed of the if keyword followed by a set of parentheses, which is followed by a code block or code statement indicated by a set of curly braces. Inside the parentheses, a condition is provided that evaluates to true or false. If the condition evaluates to true, the code inside the curly braces runs or executes. If the condition evaluates to false, the block won't execute. Let's make an if statement. Instructions. Using the let keyword, declare a variable named sale. Assign the value true to it. Let sale equal true. And we'll run that. That worked. Let's move on. Now create an if statement. Provide the if statement a condition of sale. Okay, so it was if, open up, sale, and brackets. Inside the code block of the if statement, console.log the string time to buy. Console.log time to buy. And exclamation point. Don't miss any of those. Great. Notice that the code inside the if statement ran, since time to buy was logged to the console. Below the sale variable declaration, but before the if statement, reassign sale to false. Run your code and observe what happens. We'll be changing this behavior in the next exercise. They wanted a reassignment, I'm pretty sure. And that is true. All right, let's move on to the next one. See, nothing printed to the screen. That's the point of this. This is false now instead of true. If-else statements. In the previous exercise, we used an if statement that checked a condition to decide whether or not to run a block of code. In many cases, we'll have code we want to run if our condition evaluates to false. If we wanted to add some default behavior to the if statement, we can add an else statement to run a block of code when the condition evaluates to false. Take a look at the inclusion of an else statement. An else statement must be paired with an if statement, and together they are referred to as an if-else statement. In the example above, the else statement uses the else keyword following the code block of an if statement, has a code block that is wrapped by a set of curly braces. The code inside the else statement code block will execute when the if statement's condition evaluates to false. If-else statements allow us to automate solutions to yes or no questions, also known as binary decisions. Instructions. Add an else statement to the existing if statement. Inside the code block of the else statement, console.log the string time to wait for a sale. So right here, we'll write time to wait for a sale and a period after that. So we have an if-else here. It was set to true first, and then it was set to false. So this will come as if sale, and that's to false. It should go to our else and print this. Let's run it. That's what happened. Let's go over to our next lesson. Comparison operators. When writing conditional statements, sometimes we need to use different types of operators to compare values. These operators are called comparison operators. Here is a list of some handy comparison operators and their syntax. Less than, greater than, less than or equal to, and that's a less than sign before the equal to, greater than or equal to, is equal to, that's 3 equals, is not equal to, is exclamation point 2 equals. Comparison operators compare the value on the left with the value on the right. For instance, is 10 less than 12? That should evaluate to true. It can be helpful to think of comparison statements as questions. When the answer is yes, the statement evaluates to true. When the answer is no, the statement evaluates to false. The code above would be asking, is 10 less than 12? Yes. So 10 less than 12 evaluates to true. We can also use comparison operators on different data types like strings. Apples triple equals to oranges. That would be false. In the example above, we're using the identity operator, which is triple equals, to check if the string apples is the same as the string oranges. Since the two strings are not the same, the comparison statement evaluates to false. All comparison statements evaluate to either true or false and are made up of two values that will be compared. An operator that separates the values and compares them accordingly. Let's practice using these comparison operators. Using let, create a variable named hunger level and set it equal to 7. Let hunger level equal 7. And we'll run that. Hunger level, oops, I wrote lever. Hunger lever. All right, let's run that. That does work. Write an if-else statement using a comparison operator. The condition should check if hunger level is greater than 7. If so, the conditional statement should log time to eat. Otherwise, it should log we can eat later. After you press run, play around with the condition by tweaking the comparison of hunger level by using different operators, such as the other operators that are available to us. Let's go ahead and make this statement. So this is an if-else statement. So if, and it wants us to compare the condition, so to check hunger level. Hunger level is, I wrote lever again, is greater than 7. The condition is time, well, this isn't the condition, but what happens is time to eat. And then after that, we need to do an else statement, and we can eat later. A lot of exclamation points. And before we run, let's do what it said and console.log each of these. Great, that should work. And it did. We can move on to the next lesson. Logical operators. Working with conditionals means that we will be using booleans, true or false values. In JavaScript, there are operators that work with boolean values known as logical operators. We can use logical operators to add more sophisticated logic to our conditionals. There are 3 logical operators: the AND operator, which are 2 ampersands, the OR operator, which are 2 straight lines down, the NOT operator, otherwise known as the BANG operator, which is the exclamation point, when we use the AND operator. We are checking that 2 things are true. If stoplight triple equals green and pedestrians triple equals 0. When using the AND operator, both conditions must evaluate to true for the entire condition to evaluate to true and execute. Otherwise, if either condition is false, the AND condition will evaluate to false and the else block will execute. If we only care about either condition being true, we can use the OR operator. If day is triple equal to Saturday, or day is triple equal to Sunday. When using the OR operator, only one of the conditions must evaluate to true for the overall statement to evaluate to true. In the code example above, if either day triple equals Saturday or day triple equals Sunday evaluates to true, the ifs condition will evaluate to true, and its code block will execute. If the first condition in an OR statement evaluates to true, the second condition won't even be checked. Only if day triple equal to Saturday evaluates to false will day triple equal to Sunday be evaluated. The code in the else statement above will execute only if both comparisons evaluate to false. The NOT operator reverses or negates the value of a boolean. Let excited equal true. Console.log the NOT operator in front of excited. That should print false. Essentially, the NOT operator will either take a true value and pass back false, or take a false value and pass back true. Logical operators are often used in conditional statements to add another layer of logic to our code, instructions. In main.js, there are 2 variables, mood and tiredness level. Let's create an if-else statement that checks if mood is sleepy and tiredness level is greater than 8. If both conditions evaluate to true, then console.log the string time to sleep. Otherwise, we should console.log not bedtime yet. Let's go through this. We need an if statement. It needs to check mood, and it needs to check tiredness level. Okay, so checks if mood is triple equal to sleepy, and tiredness level, and that was an end, so let's do our double ampersand. Tiredness level is greater than 8. Console, so if this evaluates to true, we need to console.log. It's under case time to sleep, no punctuation. Else, we're going to console.log not bedtime yet. And we can run that. That worked perfectly. Now it says to go ahead and try a few more of these operators and so on, and we'll just do one more just to show how this works. So we see that this is true and this is false. So let's do an OR statement here. So what if we do an OR right here? So we'll have one true and one false. This won't even be evaluated because it already has its true, and it should print time to sleep. Let's run that. It did. Now, let's try this. I'm going to throw that bang operator in there. So this would be mood not equal to sleepy and tiredness level greater than, or tiredness level greater than 8. This should give us the else statement here because the mood is equal to sleepy. And it did. Great, let's move on. Truthy and falsy. Let's consider how non-Boolean data types like strings or numbers are evaluated when checked inside a condition. Sometimes you'll want to check if a variable exists and you won't necessarily want it to equal a specific value. You'll only check to see if the variable has been assigned a value. Here's an example. Let my variable equal I exist. If my variable, console.log my variable, else console.log the variable does not exist. The code block in the if statement will run because my variable has a truthy value. Even though the value of my variable is not explicitly the value true, when used in a Boolean or conditional context, it evaluates to true because it has been assigned a non-falsy value. So which values are falsy or evaluate to false when checked as a condition? The list of falsy values includes 0, empty string, null, which represent when there is no value at all, undefined, which represent when a declared variable lacks a value, nan, or not a number. Here's an example with numbers. The condition evaluates to false because the value of number of apples is 0. Since 0 is a falsy value, the code block in the else statement will run. Instructions. Change the value of word count so that it is truthy. This value should still be a number. After you make this change and run your code, great, you started your work, should log to the console. So we need to change the value of word count so that it's truthy. So word count is 0, which is a falsy value that we saw that right up here. These are your falsy values. I'm just going to make it 1. And let's run that. Change the value of favorite phrase so that it is still a string but falsy. After you make this change and run your code, this string is definitely empty, should log inside the console. That's this one here, and if favorite string. So where's favorite string? So we know that an empty string evaluates to false. Let's run this code. And we're good. We'll move on to the next lesson. Truthy and falsy assignment. Truthy and falsy evaluations open a world of shorthand possibilities. Say you have a website and want to take a user's username and make a personalized greeting. Sometimes the user does not have an account, making the username variable falsy. The code below checks if username is defined and assigns a default string if it is not. If you combine your knowledge of logical operators, you can use a shorthand for the code above. In a Boolean condition, JavaScript assigns the truthy value to a variable if you use the OR operator in your assignment. Let default name equal username or stranger. So if there's no username, stranger would be default name's value. So if username is falsy, default name will be stranger, otherwise it'll be username. Because OR statements check the left-hand condition first, the variable default name will be assigned the actual value of username if is truthy. That seems like a typo. Will be assigned the actual value of username if username is truthy, and it will be assigned the value of stranger if username is falsy. The concept is also referred to as short-circuit evaluation. Let's use short-circuit evaluation to assign a value to writing utensil. Do not edit tool yet. We'll return to tool in the next step. All right, so writing utensil. Assign to writing utensil the value of tool, and if tool is falsy, assign the default value of pen. So writing utensil equals tool or pen, and let's run that. The pen is mightier than the sword. That worked. Let's go to the next one. Notice that the text, the pen is mightier than the sword, logged to the console, which means the value of writing utensil is pen. What if we reassign the value of tool to marker? Let's see what happens to the value of writing utensil. Okay, we need to make this marker all lowercase and just run that. The marker is mightier than the sword. Let's move on. Ternary operator. In the spirit of using shorthand syntax, we can use a ternary operator to simplify an if-else statement. Take a look at the if-else statement example. Let nighttime equal true, and they show us a normal if statement. If nighttime, console log something, and else, console log something else. We can use a ternary operator to perform the same functionality. In the example above, the condition is nighttime is provided before the question mark. Two expressions follow the question mark, and they are separated by a colon. If the condition evaluates to true, the first expression executes. If the condition evaluates to false, the second expression executes. Like if-else statements, ternary operators can be used for conditions which evaluate to true or false. Instructions. Refactor or edit the first if-else block to use a ternary operator. So refactor and edit mean the same thing. So this is the if-else. So what we'd want to say is locked question mark. So is locked true or false? The first thing will be the console. Actually, let's paste this stuff. The first thing will be this console log and the colon, and then the second console log. This is where the else goes. Let's see if we can make this a little prettier. Okay, so this is reading is locked question mark, and that means true or false. If it's locked, do this one. If not, do this one. So this is our OR operator at this point. Cool, let's get rid of this and run it. That worked. Refactor the second if-else block to use a ternary operator. Okay, this as well. So we have let is correct true. So we'll do is correct question mark, and then the first console.log. Well, let's go to the next line. We'll do the colon for or, and then we'll do another console.log, which is right here saying incorrect. And run that. Oh, nope, don't run that yet. Get rid of the statement first. Now run that. Refactor the third if-else block to use a ternary operator. Okay. If favorite phrase triple equal to love that. Okay, so this is different. This is not just true false inside of the ternary operator. We need to see that favorite phrase is exactly love that with an exclamation point after it. So we'll say favorite phrase triple equal to, and then we'll write love, make sure it's capital love, capital that, and an exclamation point. And then after that comes your question mark. You know what? Let's do this on different lines. We'll say question mark, and then we'll do the first part. I love that. And then the next line, we'll do the or, and we'll do the second one. I don't love that. Get rid of this. And run. All right, we've made it through that one. Let's go to the next one. Else-if statements. We can add more conditions to our if-else with an else-if statement. The else-if statement allows for more than two possible outcomes. You can add as many else-if statements as you'd like to make more complex conditionals. The else-if statement always comes after the if statement and before the else statement. The else-if statement also takes a condition. Let's take a look at its syntax. So we'll have an if statement, and that will have some sort of condition in it. The else if will always have a condition, and the else will not. The else if statements allow you to have multiple possible outcomes. If, else statements are read from top to bottom. So the first condition that evaluates to true from the top to the bottom is the block that gets executed. In the example above, let me get that in the picture. Since stoplight triple equals red evaluates to false and stoplight triple equals yellow evaluates to true, the code inside the first else if statement is executed. The rest of the conditions are not evaluated. If none of the conditions evaluated to true, then the code in the else statement would have executed. Instructions. Let's create a program that keeps track of the way the environment changes with the seasons. Write a conditional statement that will make this happen. In main.js, there is already an if-else statement in place. Let's add an else-if statement that checks if season is equal to winter. Okay, so let's get started on that part of it. So here's our if statement. It ends right here. So in front of our else statement, we'll move that down. We'll write else if. We'll open up some parentheses, and in there we're going to write season and triple equal winter. We'll open up our brackets and read a little more. Inside the code block of the else if statement, add a console.log that prints the string, it's winter, everything is covered in snow. Okay, so console.log, and I'm going to copy this in. You can see it has an escape character in it. So an escape character, that's this one right here, that stops it from thinking that this is a quote. Oh, that this here is a quote. So instead of closing the quote here and closing the string, it keeps going. So we did that, let's run it. Invalid season, and that's because it is summer, it's not spring or winter. Great. Add another else if statement that checks if season is equal to fall. Okay, let's do it right after this one. Else if season triple equal fall. Inside the code block of the else if statement you just created, add a console.log that prints the string, it's fall, leaves are falling. All right, well, console.log. And inside there, I'm going to paste this. Another escape character in here. Run. Still invalid season because it's still summer. Add a final else if statement that checks if season is equal to summer. Okay, one more. Else if season summer. Console.log, let's see what they want us to say then. Inside the code block of the else if statement you just created, add a console.log that prints the string, it's sunny and warm because it's summer. 2 escape characters in this one. Let's run that. It's sunny and warm because it's summer. Let's go to the next. The switch keyword. Else if statements are a great tool if we need to check multiple conditions. In programming, we often find ourselves needing to check multiple values and handling each of them differently. For example, let grocery item equal papaya, and then if grocery item triple equals tomato, console log something, just like we did in the last lesson. In the code above, we have a series of conditions checking for a value that matches a grocery item variable. Our code works fine, but imagine if we needed to check 100 different values. Having to write that many else-if statements sounds like a pain. It does. A switch statement provides an alternative syntax that is easier to read and write. A switch statement looks like this. Let grocery item equal papaya and switch over grocery item, with the cases being different types of foods here. Okay, let's take a look. The switch keyword initiates the statement and is followed by parentheses with something inside of it, which contains the value that each case will compare. In the example, the value or expression of the switch statement is grocery item. Inside the block, there are multiple cases. The case keyword checks if the expression matches the specified value that comes after it. The value following the first case is tomato. If the value of grocery item equal tomato, that case's console.log would run. The value of grocery item is papaya, so the third case runs. Papayas are 129, is logged to the console. The break keyword tells the computer to exit the block and not execute any more code or check any other cases inside the code block. Note, without break keywords, the first matching case will run, but so will every subsequent case regardless of whether or not it matches, including the default. This behavior is different from if-else, conditional statements that execute only one block of code. At the end of each switch statement, there is a default statement. If none of the cases are true, then the code in the default statement will run. Instructions. Let's write a switch statement to decide what medal to award an athlete. We have athlete position up here. So athlete final position is already defined at the top of main.js. So start writing a switch statement with the athlete final position as the expression. Okay, so switch, and then let me copy this. Athlete final position. And then they had cases, correct? Yep, cool. I don't think we should write the cases yet. Let's see what happens. That was right, okay. Inside the switch statement, add 3 cases. The first case checks for the value first place. So we'll say case first place, and then in there, we were going to console.log the string you get the gold medal. And that is capital U, get the gold medal, and exclamation point. Great. And let's look at the context here. We see we're going to have to wrap we just need to put that break in there as well. Let's use our break. Okay, we got our first one done. In the second case, it'll check for second place. So let's take this guy. Second place. And I imagine it's silver medal. It is. You get the silver medal, perfect. And we're going to do third place. So after the break, let's do another one. Third place, is it bronze medal? Let's see. Yes, perfect. And that's all 3. We need to also, let's not finish this. If we get ahead of them, they won't count it. So let's run this. You get the gold medal. We still need to do that default case. So now add a default statement at the end of the switch that uses console.log to print no medal awarded. If athlete position does not equal any value of our cases, then the string no medal awarded is logged to the console. Remember to add the break keyword at the end of the default case. So default console.log no medal awarded. And then after that, we're going to write break. Let's see if we got it. Nope, I didn't put the period after no medal awarded. Got it. All right, next lesson is the review. So let's read through the review. Way to go. Here are some of the major concepts for conditionals. An if statement checks a conditional and will execute a task if that conditional evaluates to true. If-else statements make binary decisions and execute different code blocks based on a provided condition. We can add more conditions using else-if statements. Comparison operators, including all the comparison operators, can compare 2 values. The logical AND operator, double ampersand, checks if both provided expressions are truthy. The logical OR operator checks if either provided expression is truthy. The bang operator, exclamation point, switches the truthiness and falsiness of a value. The ternary operator is shorthand to simplify concise if-else statements. A switch statement can be used to simplify the process of writing multiple else-if statements. The break keyword stops the remaining cases from being checked and executed in a switch statement. Great job. All right, everything went well there. Let's go to the next lesson. Functions. What are functions? When first learning how to calculate the area of a rectangle, there's a sequence of steps to calculate the correct answer. Measure the width of the rectangle, measure the height of the rectangle, multiply the width and height of the rectangle. With practice, you can calculate the area of the rectangle without being instructed with these 3 steps every time. We can calculate the area of one rectangle with the following code. Const width equals 10, const height equals 6, const area equals width times height, console.log area, and the output will be 60. Imagine being asked to calculate the area of 3 different rectangles. And there is 3 different rectangles being calculated here. In programming, we often use code to perform a specific task multiple times. Instead of rewriting the same code, we can group a block of code together and associate it with one task. Then we can reuse that block of code whenever we need to perform that task again. We achieve this by creating a function. A function is a reusable block of code that groups together a sequence of statements to perform a specific task. In this lesson, you will learn how to create and use functions, and how they can be used to create clearer and more concise code. Instructions. Take a look at the provided GIF. It shows a function named addOneSide, adding an additional side to different shape inputs. Notice how there is only one function, represented by the box. That is used to transform individual shapes inputs into new shapes outputs. Let's move on to the next lesson. Function declarations. In JavaScript, there are many ways to create a function. One way to create a function is by using a function declaration. Just like how a variable declaration binds a variable to a variable name, a function declaration binds a function to a name or identifier. Take a look at the anatomy of a function declaration below. Function, the keyword, greet world is the identifier of the function. Then we have our brackets holding a console.log, hello world, and that's the function body. A function declaration consists of the function keyword, the name of the function or its identifier followed by parentheses, a function body or the block of statements required to perform a specific task enclosed in the function's curly brackets. A function declaration is a function that is bound to an identifier or name. In the next exercise, we'll go over how to run the code inside the function body. We should also be aware of the hoisting feature in JavaScript, which allows access to function declarations before they're defined. Take a look at an example of hosting. That must be a typo. Console.log greet world, output hello world. Function greet world console.log hello world. So the console.log is above the function, and that's what the hoisting is the example of. Notice how hoisting allowed greet world to be called before the greet world function was defined. Since hoisting isn't considered good practice, we simply want you to be aware of this feature. If you'd like to read more about hoisting, check out this documentation. Instructions. Let's create a function that prints a reminder to the console. Using a function declaration, create a function called getReminder. So it was function getReminder, and then the block. And if you're doing this, you want to check anything, just head back up here, look at a function, or look at this exercise here. You have your function, you have your word, your parentheses, and then we open up our code block. Let's run that. And that worked. In the function body of getReminder, log the following reminder to the console. What are the plans? So we'll console.log. Is that anything capital? What are the plans? And a period after that, and run it. That worked well too. Let's create another function that prints a useful Spanish travel phrase to the console. Using a function declaration, create a function called greet in Spanish. So we'll do that again. Function greet in Spanish, that's camel case. Run that. Add code to the function body of greet in Spanish. In the function body, console.log the following Spanish phrase to the console. Buenos tardes. So, buenos tardes. Period. And let's run that. Yep, I must have not spelt it right. Oh, no, I didn't console log it. There we go. There we go. We'll move on from there. Calling a function. As we saw in previous exercises, a function declaration binds a function to an identifier. However, a function declaration does not ask the code inside the function body to run. It just declares the existence of the function. The code inside the function body runs, or executes, only when the function is called. To call a function in your code, you type the function name followed by parentheses. Identifier, greeting world, parentheses is their example. This function call executes the function body, or all of the statements between the curly braces and the function declaration. We can call the same function as many times as needed. Let's practice calling functions in our code. Instructions. Imagine that you manage an online store. When a customer places an order, you send them a thank you note. Let's create a function to complete this task. Define a function called sayThanks as a function declaration. Function sayThanks. And in there, what are we going to do? In the function body of sayThanks, add code such that the function writes the following thank you message to the console when called. Thank you for your purchase. We appreciate your business. I'm going to copy that because it's a lot of words and a lot of places to make a typo. And let's run that. Great. Call thank you to view the thank you message in the console. So let's just say thanks parentheses. And let's run it. And it did go to the console. Functions can be called as many times as you need them. Imagine that 3 customers placed an order and you wanted to send each of them a thank you message. Update your code to call sayThanks 3 times. Okay, so it says it once. I'm just going to copy and paste it 2 more. We probably should end each one of these and run it. There we are. We have 3 thank yous. Let's move on. Parameters and arguments. So far, the functions we've created execute a task without an input. However, some functions can take inputs and use the inputs to perform a task. When declaring a function, we can specify its parameters. Parameters allow functions to accept inputs and perform a task using the inputs. We use parameters as placeholders for information that will be passed to the function when it is called. Let's observe how to specify parameters in our function declaration. In the diagram above, calculate area computes the area of a rectangle based on 2 inputs, width and height. The parameters are specified between the parentheses as width and height, and inside the function body, they act just like regular variables. Width and height act as placeholders for values that will be multiplied together. When calling a function that has parameters, we specify the values in the parentheses that follow the function name. The values that are passed to the function when it is called are called arguments. Arguments can be passed to the function as values or variables. In the function call above, the number 10 is passed as the width and 6 is passed as the height. Notice that the order in which the arguments are passed and assigned follows the order that the parameters are declared. The variables rect_width and rect_height are initialized with the values for the height and width of a rectangle before being used in the function call. By using parameters, calculate area can be reused to compute the area of any rectangle. Functions are a very powerful tool in computer programming, so let's practice creating and calling functions with parameters. The sayThanks function works well, but let's add the customer's name to the message. So what we'll do is add a parameter that says name to the function declaration for sayThanks. Okay, so just run that. With name as a parameter, it can be used as a variable in the function body of sayThanks. Using name and string concatenation, change the thank you message into the following. Thank you for your purchase plus name plus exclamation point. We appreciate your business. I would copy and oh, it says to copy and paste it. Great. Thank you for your purchase. So we'll take it right here and paste. Let's take a look at that. Great. A customer named Cole just purchased something from your online store. Call say thanks and pass Cole as an argument to send Cole a personalized thank you message. Okay. Say thanks and pass in Cole and run that. And we can see thank you for your purchase, Cole. Let's go to the next lesson. Default parameters. One of the features added in ES6 is the ability to use default parameters. Default parameters allow parameters to have a predetermined value in case there is no argument passed into the function or if the argument is undefined when called. Take a look at the code snippet below that uses a default parameter. And the function greeting has name, but it also has name equals stranger, which is in quotes a string of stranger. In the example above, we use the equals operator to assign the parameter name a default value of stranger. This is useful to have in case we ever want to include a non-personalized default greeting. When the code calls greeting Nick, the value of the argument passed in and Nick will override the default parameter of stranger to console log hello. This is written really poorly. Okay. When the code calls greeting Nick, the value of the argument passed in, which is Nick, will override the default parameter, which was stranger, and it will console.log hello Nick. So that's what it's saying. When there isn't an argument passed into greeting, the default value of stranger is used, and hello stranger is logged to the console. By using a default parameter, we account for situations when an argument isn't passed into a function that is expecting an argument. Let's practice creating functions that use default parameters. Instructions. The function makeShoppingList creates a shopping list based on the items that are passed to the function as an argument. Imagine you always purchase milk, bread, and eggs every time you go shopping for groceries. To make creating a grocery list easier, let's assign default values to the parameters in makeShoppingList. Change the parameters of makeShoppingList into default parameters. Assign milk as the default value of item 1. So item 1 equals, and milk all undercase. Bread is item 2. All undercase, and item 3, it says eggs. All right, let's see if that worked for us. Oh, it didn't. No, it did. Okay, great. Let's move on to the next one. Return. When a function is called, the computer will run through the function's code and evaluate the result of calling the function. By default, the resulting value is undefined. Function, rectangle area, width, height as the arguments. Let area equal width times height. Console.log, rectangle area, 5, 7 prints undefined. In the code above, we define our function to calculate the area of a width and height parameter. Then rectangle area is invoked with the arguments 5 and 7, but when we print the results, we got undefined. Did we write our function wrong? No. In fact, the function worked fine, and the computer did calculate the area as 35, but we didn't capture it. So how can we do that? With the keyword return. To pass back information from the function call, we use a return statement. To create a return statement, we use the return keyword followed by the value that we wish to return. Like we saw above, if the value is omitted, undefined is returned instead. When a return statement is used in a function body, the execution of the function is stopped and the code that follows will not be executed. Look at the example below. If an argument for width or height is less than 0, then rectangle area will return you need positive integers to calculate area. The second return statement, with height, will not run. The return keyword is powerful because it allows functions to produce an output. We can then save the output to a variable for later use. Instructions. Imagine if we needed to order monitors for everyone in an office, and this office is conveniently arranged in a grid shape. We could use a function to help us calculate the number of monitors needed. Declare a function, monitor count, that has two parameters. The first parameter is rows, the second parameter is columns. Function, monitor count, and it wants rows, comma, columns. And make that body and run it. Let's compute the number of monitors by multiplying rows and columns and then returning the value. In the function body of the function you just wrote, use the return keyword to return rows times values. So rows star values. So return rows, then the asterisk, then values. Let's run that. Oh, I wrote values. I should have wrote columns. Values is nowhere here. Columns, and we're returning a value. That's right. Now that the function is defined, we can compute the number of monitors needed. Let's say that the office has 5 rows and 4 columns. Declare a variable num of monitors using the const keyword and assign num of monitors to the value of invoking monitor count with the argument 5 and 4. So we're going to declare a const variable called num of monitors, and it's going to be equal to monitor count, and we will pass in 5 and 4. Let's try that out. Great, that worked. And one more. To check that the function worked properly, log num of monitors to the console. So after that, let's just console.log num of monitors and run. 20. We need 20 monitors. All right, let's move on to the next one. Helper functions. We can also use the return value of a function inside another function. These functions being called within another function are often referred to as helper functions. Since each function is carrying out a specific task, it makes our code easier to read and debug if necessary. If we wanted to define a function that converts the temperature from Celsius to Fahrenheit, we can write two functions like, then they have two functions that do that definition. In the example above, get Fahrenheit is called and 15 is passed in as the argument. The code block inside of get Fahrenheit calls multiply by 9/5 and passes 15 as the argument. Multiply by 9/5 takes the argument of 15 for the number parameter. The code block inside of multiply by 9/5 function multiplies 15 by 9/5, which evaluates to 27. 27 is returned back to the function call in get Fahrenheit. Get Fahrenheit continues to execute. It adds 32 to 27, which evaluates to 59. Finally, 59 is returned back to the function call, get Fahrenheit 15. We can use functions to section off small bits of logic or tasks, then use them when we need to. Writing helper functions can help take large and difficult tasks and break them into smaller, more manageable tasks. Instructions. In the previous exercise, we created a function to find the number of monitors to order for an office. Now let's write another function that uses the monitor count function to figure out the price. Below monitor count, create a function declaration named cost of monitors. That has two parameters. The first parameter is rows, the second parameter is columns. Leave the function body empty for now. So function, and what was the name? Cost of monitors. And it takes two parameters, rows, just like the other one, columns. And we'll leave the function body empty for now. Let's run that. Time to add some code to the function body of cost of monitors to calculate the total cost. Add a return statement that returns the value of calling monitor count rows columns multiplied by 200. So we want to return and then monitor count rows asterisk columns. Oh, not asterisks. That's what the other function is doing. My fault. Columns. So we pass that in, rows and columns, and what we want to do is multiply what we get back by 200. All right, let's see if that's what they're looking for. It is. Great. We should save the cost to a variable. Declare a variable named total cost using the const keyword. Assign to total cost the value of calling cost of monitors with the arguments 5 and 4 respectively. So const total cost, and that will equal calling cost of monitors and passing in 5 and 4. And let's run that. That worked. To check that the function worked properly, console.log total cost. Okay, console.log total cost. And let's run that. $4,000 of monitors. Great, let's go to the next one. Function expressions. Another way to define a function is to use a function expression. To define a function inside an expression, we can use the function keyword. In the function expression, the function name is usually omitted. A function with no name is called an anonymous function. A function expression is often stored in a variable in order to refer to it. Consider the following function expression. It has an identifier, keyword, and parameters. To declare a function expression, declare a variable to make the variable's name be the name or identifier of your function. Since the release of ES6, it is common practice to use the const as the keyword to declare a variable. Assign as that variable's value an anonymous function created by using the function keyword followed by a set of parentheses with possible parameters, then a set of curly braces that contain the function body. To invoke a function expression, write the name of the variable in which the function is stored, followed by parentheses, enclosing any arguments being passed into the function. Variable name, argument, argument. Unlike function declarations, function expressions are not hoisted, so they cannot be called before they are defined. Let's define a new function using the function expression. Let's say we have a plant that we need to water once a week on Wednesdays. We could define a function expression to help us check the day of the week and the plant needs to be watered. That's a typo. So the day of the week that the plant needs to be watered and the day of the week that it is what they're saying. Create a variable named plant needs water using the const variable keyword. Assign an anonymous function that takes a parameter of day to plant needs water. Okay, so we're doing const plant needs water, and that will equal a function, and inside of there, it takes day. And let's see that. Perfect. Now we need to add some code to the function body of plant needs water. In the function body, add an if conditional that checks day triple equal to Wednesday. If the conditional is truthy, inside the if code block, use the return keyword to return true. So if day triple equals capital Wednesday, return true. And let's run that. Oh, I have a typo in Wednesday. There's an @ sign in the middle of it. Let's run it again. That works. On days that aren't Wednesday, plant needs water should return false. Add an else statement after the if statement. Inside the else statement, use the return keyword to return false. So after if, else, return false. Call the plants need water and pass in Tuesday as an argument. Plant needs water, and we'll pass in Tuesday. Let's run that. Great. Let's check that plant needs water returned the expected value. Log plant needs water Tuesday to the console. If it worked correctly, you should see false logged to the console. So we'll just console.log all of this and run it. False. Perfect. Let's move on. Arrow functions. ES6 introduced arrow function syntax, a shorter way to write functions by using the special fat arrow notation. Arrow functions remove the need to type out the keyword function every time you need to create a function. Arrow functions. ES6 introduced arrow function syntax, a shorter way to write functions by using the special fat arrow notation. Arrow functions remove the need to type out the keyword function every time you need to create a function. Instead, you first include the parameters inside the parentheses and then add an arrow that points to the function body surrounded in curly braces like this. It is important to be familiar with the multiple ways of writing functions because you will come across each of these when reading other JavaScript code. Instructions. Change plant needs water to use arrow function syntax. Okay, so this is what it looks like. Const plant needs water equals, and in here we'll pass in a day, and then we'll do our arrow and open up our function, and everything here stays the way it is. Get rid of this. And I think that's what they wanted. Let's run it. That did work. Perfect. Let's move on. Concise body arrow functions. JavaScript also provides several ways to refactor arrow function syntax. The most condensed form of the function is known as concise body. We'll explore a few of these techniques below. Functions that take only a single parameter do not need the parameter to be enclosed in the parentheses. However, if a function takes 0 or multiple parameters, parentheses are required. A function body composed of a single line block does not need curly braces. Without the curly braces, whatever that line evaluates will be automatically returned. The contents of the block should immediately follow the arrow, and the return keyword can be removed. This is referred to as implicit return. So if we have a function, const square num, that takes num and returns num times num, we could have const square num that takes num without any parentheses, arrow function num times num. Notice the following changes. The parentheses around num have been removed since it has a single parameter. The curly braces have been removed since the function consists of a single line block. The return keyword has been removed since the function consists of a single line block. Instructions. Let's refactor plant needs water to be a concise body. Notice that we've already converted the if-else statement to a ternary operator to make the code fit on one line. So what we want to do is get rid of day and get rid of all of this. And that should do it. Let's just put it on one line. Do they allow that? Yes. And that should do it. Let's run that. Oh, that's wrong because I kept the return in. That's why it's wrong. That works perfect. So that's what it looks like. The mistake there was I left a return, which would have been fine if we had the curly braces, but we don't. So we have an implicit return, and that's the big difference. Next. Review functions. Give yourself a pat on the back. You just navigated through functions. In this lesson, we covered some important concepts about functions. A function is a reusable block of code that groups together a sequence of statements to perform a specific task. A function declaration has a function keyword, an identifier, and a function body. A parameter is a named variable inside a functions block which will be assigned the value of the argument passed in when the function is invoked. To call a function in your code, and it shows how to do that, it would be the function's name and parentheses. ES6 introduces new ways of handling arbitrary parameters through default parameters, which allow us to assign a default value to a parameter in case no argument is passed into the function. To return a value from a function, we use the return statement. To define a function using function expressions, use an identifier, a function keyword, a parameter, parameters, and your function body. To define a function using an arrow function notation, you have your identifier, your parameters, the arrow, and then the function body. Function definition can be made concise using concise arrow notation, which in a single block would have const sum numbers equals number without parentheses, arrow, fat arrow, and then number plus number, and multi-line will need a return statement inside of it, and it will need curly braces amongst the body of the function. It's good to be aware of the differences between function expressions, arrow functions, and function declarations as you program more in JavaScript. You'll see a wide variety of how these function types are used. And let's see what's up next. Scope. An important idea in programming is scope. Scope defines where variables can be accessed or referenced. While some variables can be accessed from anywhere within a program, other variables may only be available in a specific context. You could think of scope like a view of the night sky from your window. Everyone who lives on the planet Earth is in the global scope of the stars. The stars are accessible globally. Meanwhile, if you live in a city, you may see the city skyline or the river. The skyline and the river are only accessible locally in your city, but you can still see the stars that are available globally. Over the next few exercises, we'll explore how scope relates to variables and learn best practices for variable declarations. Let's head to the next lesson. Blocks and scope. Before we talk more about scope, we first need to talk about blocks. We've seen blocks used before in functions and if statements. A block is the code found inside a set of curly braces. Blocks help us group one or more statements together and serve as an important structural marker for our code. A block of code could function like this. Const log sky color equals parentheses arrow function block let color equal blue console.log color. Notice that the function body is actually a block of code. Observe the block in an if statement. If dusk curly braces let color equal pink console.log color. In the next few exercises, we'll see how blocks define the scope of variables. Instructions. At the top of main.js, declare a const variable named city set equal to New York City. This variable will exist outside your block. Const city equals string capital New York City and run it. Below the city variable, write a function named log city skyline. Do they want us to do it with the const variable? I'm going to do it with the const, and we'll see what they say. So I put a fat arrow function there with the log city skyline variable. Let's take a look. That works for them. Inside of the body of log city skyline, write another variable using let named skyscraper and set it equal to Empire State Building. Let skyscraper all undercase equal Empire State Building. And we'll run that. Inside the function, include a return statement like this. So return the stars over the plus, and then skyscraper. And you can see there's a space after the. I made a mistake with that. Make that space. Plus, we're going to have in and a space plus city. And that's that. It wants it like so. And run. Let's see what it is I did wrong here. Oh, I see. Okay, they need a space before in as well. That's where this stuff gets a little gotcha. That works. Beneath the log city skyline function, use console.log to log the value of log city skyline to the console. Okay, console.log log city skyline, the function. Oh, that's a G at the end. So I'd line and run that. That works perfectly. Let's move on to the next lesson. Global scope. Scope is the context in which our variables are declared. We think about scope in relation to blocks because variables can exist either outside of or within these blocks. In global scope, variables are declared outside of blocks. These variables are called global variables. Because global variables are not bound inside a block, they can be accessed by any code in the program, including code in blocks. Let's take a look at an example of global scope. Const color equals blue, const return sky color, return color inside the brackets should return blue. Even though the color variable is defined outside of the block and can be accessed in the function block, giving it global scope. In turn, color can be accessed within the return sky color function block. Let's work with global variables to see how data can be accessible from any place within a program. Instructions. At the top of main.js, write 3 global variables. Name the first variable satellite and set it equal to the moon. So let's say const satellite equals the moon. Const galaxy equals the Milky Way. And yes, there are 3 of these. We're just copying them down. Const stars equals North Star. And let's run that. That worked. Below the variables created in the previous step, write a function named callMyNightSky. Inside the function, include a return statement like this. We're going to copy it this time because there are quite a bit of spaces and so on here. So we want to write a function, const callMyNightSky. I'm doing a lot of fat arrow functions, I know. I prefer them. And we want to return all of this. Let's try that out. That works. Beneath the callMyNightSky function, use console.log to log the value of callMyNightSky to the console. you'll notice that the function block for callMyNightSky is able to access the global variables freely since the variables are available in all lines of code in the file. Console.log callMyNightSky and as a function, and run that. And we can see right there, it is taking all the variables and making this a nice sentence I can print out. Let's go to the next one. Block scope. The next context we'll cover is called block scope. When a variable is defined inside a block, it is only accessible to the code within the curly braces. We say that variable has block scope because it is only accessible to the lines of code within that block. Variables that are declared with block scope are known as local variables because they are only available to the code that is part of the same block. Block scope works like this. Const log sky color is a function. Inside its block, it says let color equal blue. Console log color will equal blue. If you try to console log color outside of the function, you'll get a reference error. You'll notice we define a function log sky color. Within the function, the color variable is only available within the curly braces of the function. If we try to log the same variable outside the function, throws a reference error. The function throws a reference error is what they're trying to say right there. Instructions. In main.js, define a function. So const log visible light waves. And as a function, run that. Let's make sure I didn't have a typo in there. That works, must have been a typo. Within the log visible light waves function, using const, create a variable light waves and set it equal to moonlight. Const light waves equals moonlight, and run that. Within the log visible light waves function, beneath the light waves variable, add a console.log statement that will log the value of the light waves variable when the function runs. So console.log light waves, and then we'll run that. Call the log visible light waves function from outside the function. Console.log. I mean, we could just call it. I think they might mean just to call it. So it would be, let's copy it. So that's just calling it without the console. I think that's what they're asking. That is what they're asking. Beneath the function call, log the value of light waves to the console from outside the function. You'll notice that it logs a reference error since the variable is tied to the block scope of the function. So console.log, and it was light waves. And light waves is right up here, light waves. And yeah, there we go. I can't find it because it's within this block and it has a block scope. Let's go to the next one. Scope pollution. It may seem like a great idea to always make your variables accessible, but having too many global variables can cause problems in a program. When you declare global variables, they go to the global namespace. The global namespace allows these variables to be accessible from anywhere in the program. These variables remain there until the program finishes, which means our global namespace can fill up really quickly. Scope pollution is when we have too many global variables that exist in the global namespace, or when we reuse variables across different scopes. Scope pollution makes it difficult to keep track of our different variables and sets us up for potential accidents. For example, global scoped variables can collide with other variables that are more locally scoped. causing unexpected behavior in our code. Let's look at an example of scope pollution in practice so we know how to avoid it. You'll notice we have a variable num. Inside the function body of lognum, we want to declare a new variable but forgot to use the let keyword. When we call lognum, num gets reassigned to 100. The reassignment inside lognum affects the global variable num. Even though the reassignment is allowed and we won't get an error, if we decide to use num later, we'll unknowingly use the new value of num. While it's important to know what global scope is, it's best practice to not define variables in the global scope. Instructions. Let's see what happens if we create a variable that overwrites a global variable. Inside the callMyNightSky function, on the very first line of the function body, assign the variable stars to Sirius as such. Stars equals Sirius. And there we are with stars equals Sirius, and we'll run that. Night sky, the moon, Sirius, the Milky Way. Outside the function, under the current console.log statement, add another console.log statement to log stars to the console. Okay. Console.log stars. You'll notice that the global variable stars was reassigned to Sirius. In other words, we changed the value of the global stars variable, but it's not easy to read what exactly happened. This is bad practice in code maintainability and could impact our program in ways we do not intend. Let's run that. And we see that stars is now Sirius even though it was North Star in the global scope. Let's move on to the next one. Practice good scoping. Given the challenges with global variables and scope pollution, we should follow best practices for scoping our variables as tightly as possible using block scope. Tightly scoping your variables will greatly improve your code in several ways. It will make your code more legible since the blocks will organize your code into discrete sections. It makes your code more understandable since it clarifies which variables are associated with different parts of the program rather than having to keep track of them line after line. It's easier to maintain your code since your code will be modular. It will save memory in your code because it will cease to exist after the code block finishes running. Here's another example of how to use block scope, as defined with an if block. Here you'll notice we create a variable dusk inside the log_skyColor function. After the if statement, we define a new code block with the curly braces. Here we assign a new value to the variable color if the if statement is truthy. Within the if block, the color variable holds the value pink, though outside the if block, in the function body, the color variable holds the value blue. While we use block scope, we still pollute our namespace by reusing the same variable name twice. A better practice would be to rename the variable inside the block. Block scope is a powerful tool in JavaScript, since it allows us to define variables with precision and not pollute the global namespace. If a variable does not need to exist outside a block, it shouldn't. Instructions. Inside the function body of log visible light waves beneath the region variable and before the provided console.log statement, create an if statement that checks if the region is the Arctic. Okay, add if statement here. If region triple equals the Arctic, and I'm not sure if it wants us to put the console.log in there or not. Let's try it without first. No, so let's put the console.log inside of there. Actually, that is right. The Arctic make a few extra typos when I'm talking and typing. There we go, that works. Inside the if block, define a new let variable, light waves, and set it equal to northern lights. So inside the if variable, we're going to let light waves equal northern lights. This should interfere with this. Let's take a look at what happens there. This changes the light waves from moonlight to northern lights. Beneath the variable in the if block, use console.log to log the value of the block variable inside the if block. The block variable inside the if block is going to be light waves. So let's console.log light waves. Okay. Beneath the variable in the if block, this is inside the if block. Run your code and notice the output. Inside the if block, console.log light waves logs the value northern lights. Outside, it does want it outside. Let's move you outside. I was going to say, both were doing the same thing. Run that. There you go. Northern lights, and outside it's moonlight. Run your code and notice the output. Inside the if block, console.log light waves logs the value northern lights to the console. Outside the if block, but still within the function, the same statement logs moonlight to the console. I see what they're saying. So outside of the if block, which is here, but still in the same function, is what they were trying to say. I gotcha. Okay, let's move to the next one. Review scope. In this lesson, you learned about scope and how it impacts the accessibility of different variables. Let's review the following terms. Scope is the idea in programming that some variables are accessible, inaccessible from other parts of the program. Blocks are statements that exist within curly braces. Global scope refers to the context within which variables are accessible to every part of the program. Global variables are variables that exist within the global scope. Block scope refers to the context within which variables that are accessible only within the block they are defined. Local variables are variables that exist within block scope. Global namespace is the space in our code that contains globally scoped information. Scope pollution is when too many variables exist in a namespace or variable names are reused. As you continue your coding journey, remember to use best practices when declaring variables. Scoping your variables tightly will ensure that your code has clean, organized, and modular logic. And that is that lesson. What is up next? We will be going over arrays. Arrays. Organizing and storing data is a foundational concept of programming. One way we organize data in real life is by making lists. Let's make one here. New Year's resolutions, and it's an enumerated list with 1, 2, 3, and 4 with keep a journal, take a falconry class, and learn to juggle. Let's now write this list in JavaScript as an array. Let New Year's resolutions equal, then it opens an array and puts in those three things: keep a journal, take a falconry class, and learn to juggle. Arrays are JavaScript ways of making lists. Arrays can store any data types, including strings, numbers, and booleans. Like lists, arrays are ordered, meaning each item has a numbered position. Here's an array of the concepts we'll cover. Let concepts equal, it opens an array, and the strings are create arrays, array structures, and array manipulation. By the end of this lesson, you'll have another tool under your belt that helps you manage a chunk of data. Run the code, see what's logged to the console. We'll run that. And we see what's logged to the console is everything inside of New Year's resolutions here. And next. Create an array. One way we can create an array is to use an array literal. An array literal creates an array by wrapping items in square brackets. Remember from the previous exercise, arrays can store any data type. We can have an array that holds all the same types of data or an array that holds different types of data. And it shows an array with different types of data in it. Let's take a closer look at the syntax in the array example. Go above. The array is represented by the square brackets and the content inside. Each content item inside the array is called an element. There are 3 different elements inside the array. Each element inside the array is a different data type. We can also save an array to a variable. You may have noticed we did this in the previous exercise. Let New Year's resolutions, and we saw that in the previous exercise. Let's practice by making an array of our own. Instructions. Declare a variable using const named hobbies. Const hobbies. Set it equal to an array with 3 strings inside of it. TV, make sure these are different strings. So the first hobby will be TV and coding, and running will be the third one. And let's run that. Use console.log to print hobbies to the console. Let's do that. Console.log hobbies and run. Let's move on to the next lesson. Accessing elements. Each item in an array has a numbered position known as its index. We can access individual items using their index, which is similar to referencing an item in a list based on the item's position. Arrays in JavaScript are 0 indexed, meaning the positions start counting from 0 rather than 1. Therefore, the first item in an array will be at position 0. Let's see how we would access an element in an array. In the code snippet above, cities is an array that has 3 elements. We're using bracket notation, with the index after the name of the array to access the element. Cities at index 0 will access the element at index 0 in the cities array. You can think of cities at 0 as accessing the space in memory that holds the string New York. You can also access individual characters in a string using bracket notation and the index. For instance, you can write const hello equals hello world as a string, and console.log hello at 6 would be the letter capital W. The console will display capital W since it is the character that is at index 6. Instructions. Individual elements in arrays can also be stored to variables. Create a variable named listItem and set it equal to the first item in the famous sayings array using square bracket notation. We're going to make a const called listItem set equal to a bracket. Okay, so it wants us to get the first item from famous sayings, which would be at 0 index, and store it in listItem, and then it says, then use console.log to print listItem, to print the listItem variable to the console. So console.log, and in there we're going to write listItem, and let's see. And you can see fortune favors the brave, which is the first thing in the list at index 0. Now, console.log the third element in the famous sayings array using bracket notation to access the element. Do not save the element to a new variable before you log it. So we're just going to console.log and famous sayings. And after that, we need the third element. So 0 is 1, meaning 2 is 3, and we'll run that. That worked. Awesome. You can access each element in an array using the index. But what happens if you try to access an index that is beyond the last element? Try to log the item at index 3 of famous sayings to the console. What is logged to the console? So we have this at 2 already. Let's do it at 3. And run. undefined. It's logged to the console, and we could go to the next lesson. Update elements. In the previous exercise, you learned how to access elements inside an array or a string using an index. Once you have access to an element in an array, you can update its value. In the example above, the seasons array contained the names of the 4 seasons. However, we decided that we preferred to say autumn instead of fall. The line season 3 equals autumn as a string tells our program to change the item at index 3 of the seasons array to be autumn instead of what is already there. Change the second element of the array grocery list to avocados. So in order to do that, we're going to type grocery list again, and then we're going to type what we want to access, and they want us to access the second element, which is 1, and make that equal to a string that says avocados, all undercase. And run it. That worked. And let's go to the next lesson. Arrays with let and const. You may recall that you can declare variables with both let and const keywords. Variables declared with let can be reassigned. Variables declared with the const keyword cannot be reassigned. However, elements in an array declared with const remain mutable, meaning that we can change the contents of a const array but cannot reassign a new array or a different value. The instructions below will illustrate this concept more clearly. Pay close attention to the similarities and differences between the condiments array and the utensils array as you complete the steps. Instructions. Below the 2 existing arrays, reassign the element in index 0 of condiments to mayo. Log the updated array condiments to the console. So we have condiments, and it said the index of 0. And that is going to now equal mayo, capital M, and then console.log all of the condiments. So console.log, and then just condiments. Let's see if we did that right. Perfect. Below your code from step 1, reassign condiments to be a new array that contains a single string that says mayo. Log the results to the console. Notice that you can reassign elements in an array and reassign an entire new array to a variable declared using the let keyword. All right, so below our code from step 1, we're going to reassign condiments. So condiments equals, and then just an array with just mayo in it, capital. And then you know what, I'm just going to copy and paste because we're going to console.log condiments again. And I'll run that. And that works. Below your code from step 2, reassign the last item from the utensils array to spoon. Log the updated array to the console. So we want the utensils and it was the last item of the array of utensils. So it's spork, so this is 0, 1, 2, and there you go on 3. Utensils 3 is going to be capital spoon as a string, and we'll run that. Oh, no, hold on. Log the updated array to the console. Console.log utensils, and then we'll run it. And that works for us. We'll move on to the next lesson. The .length property. One of an array's built-in properties is length, and it returns the number of items in the array. We access the .length property just like we do with strings. Check the example below. Const New Year's resolution equals 2 strings within an array, and console.log New Year's resolutions.length, the output is 2. In the example above, we log New Year's resolutions.length to the console using the following steps. We use dot notation, chaining a period with a property name to the array to access the length property of the New Year's resolutions array. Then we log the length of New Year's resolution to the console. Since New Year's resolution has 2 elements, 2 would be logged to the console. When we want to know how many elements are in an array, we can access the .length property. Instructions. Find the length of the objectives array and log it to the console. Console.log objectives.length. And let's run that. 3. And that's right. Let's move on to the next lesson. The .push method. Let's learn about some built-in JavaScript methods that make working with arrays easier. These methods are specifically called on arrays to make common tasks like adding and removing elements more straightforward. One method, .push, allows us to add items to the end of an array. Here is an example of how this is used. Const item tracker, it has 3 items in the array. Item tracker.push will push item 3. It starts at 0, so even though it has 3, it has item 0, item 1, item 2. Item tracker.push is pushing item 3, item 4 into that array, and when we console log, we see that there are 5 items in the array, including item 3 and item 4. They're both at the back of the array, at the end of it. So how does push work? We can access the push method by using dot notation, connecting push to item tracker with a period. Then we call it like a function. That's because .push is a function and one that JavaScript allows us to use right on an array. .push can take a single argument or multiple arguments separated by commas. In this case, we're adding 2 elements, item 3 and item 4 to item tracker. Notice that .push changes or mutates item tracker. You might also see .push referred to as a destructive array method since it changes the initial array. If you're looking for a method that will mutate an array by adding elements to it, then .push is the method for you. Instructions. Add 2 elements to the chores array using .push. We have wash dishes, do laundry, take out trash. Then we'll say chores .push. And in there, we will push, and I think it was just 2 different things, not an array, correct? Yes, it's just 2 different things, just like this. So it's comma separated, and then 2 items to push to it. So what 2 items will we push? The chores are wash dishes, do laundry, take out the trash, eat too much, and what else do I have to do? Watch a lot of TV. And let's add that, see what happens. That did work. Use console.log to print your chores array to make sure your items were added. Okay, console.log and chores. Let's run that. Looks like we have everything. We're going to eat too much and watch a lot of TV as well. The .pop method. Another array method, .pop, removes the last item of an array. In the example above, calling .pop on the new item tracker array removed item 2 from the end. .pop does not take any arguments, it simply removes the last item of new item tracker. .pop returns the value of the last element. In the example, we store the returned value in a variable removed to be used for later. .pop is a method that mutates the initial array. When you need to mutate an array by removing the last element, use .pop. Use the pop method to remove the last element from chores. So chores.pop, and that should do it. And it did. In the line after you called chores.pop, log chores to the console and make sure it worked. Console.log chores, and we're looking for mop floor to be gone. And that's true. Cook dinner is the last thing there. Let's move on to the next lesson. More array methods. There are many more array methods than just push and pop. You can read about all the array methods that exist on the Mozilla Developer Network, the MDM array documentation. .pop and .push mutate the array on which they're called. However, there are times that we don't want to mutate the original array, and we can use non-mutating array methods. Be sure to check MDN to understand the behavior of the method you are using. Some array methods that are available to JavaScript developers include join, slice, splice, shift, unshift, and concat, amongst many others. Using these built-in methods make it easier to do some common tests when working with arrays. Below, we will explore some methods that we have not learned yet. We will use these methods to edit a grocery list. As you complete the steps, you can consult the MDN documentation to learn what each method does. Use the .shift method to remove the first item from the array grocery list. So we know that .shift removes the first item from grocery list. .shift. And you shouldn't have to call anything. It just says to then console.log grocery list. And we'll run that. And there we are. We see that orange juice is gone. Great. Next, under the code added in step 1, use the unshift method to add a string of popcorn to the beginning of the groceries list. After calling unshift on the groceries list, log grocery list to the console. You may wish to delete the console.log statement from the previous step. We're just going to use it. We'll just keep it there since we have to log it. And we will say grocery list dot unshift. And what we want to put in there is some popcorn. Let's run that. That worked perfectly. And one more, oh no, a couple more, a few more. Number 3, you're in a hurry, so you decide to ask a friend to help you out with grocery shopping. You want him to pick up the bananas, coffee beans, and brown rice. Under the code you added for step 2, use .slice to provide your friend with a list of these 3 things. Log this part of the list to the console. Unlike the 2 previous checkpoints, you should do both of these steps in one line. Read about .slice and MDN's slice documentation. Let's bring that up quick. Okay, so slice. This says, here's your animals array. It's going to slice at 2 and console log it. And the output is an array, a new array that starts at camel. So it starts at the point, so this would be 0, 1. It starts at whatever you put in there and goes to the end. Now, here's one with 2 points. Console.log, animals.slice, 2, 4. So this would include the camel, which is at 2, the duck, which is at 3, but not the elephant at 4. So the first argument is inclusive, and the second argument is going to be exclusive, and we could remember that as we head back. So the console log, one more here, it's animals.slice 1 through 5. It's going to have at 1 is bison, so that works there, and at 5 would be nothing. So it stops at elephant, so yeah, it is exclusive. Let's head back and look at .slice here and see what we need to do. So this is going to be a console.log. It wants us to do this all in one line. And then grocery list .slice. And in there, they want bananas, which are 0, 1, it's inclusive. And then it needs to stop after brown rice. So 0, 1, 2, this is 3, and we need to put 4 for the exclusive number. And let's see if that worked. That worked perfectly. Let's go down to number 4 here. After calling slice on the grocery list, log the grocery list to the console one more time. Notice that the grocery list array still contains the same items it had in step 2. That means .slice is not mutating. You can confirm this in the link in the previous step. It looks like it just wants us to console log this one more time, just the grocery list. Let's check that. Let's run that. And we can see there it is. and it's saying at the beginning it was the same as at the end. Oh, so it's saying a dot slice did not mutate this list itself. What it did is return a new array that we logged. It didn't mutate the original array. That's what it was saying there. Let's go to number 5. Let's find the index of a particular element in grocery list using index of. Call index of on grocery list to find the index of the element pasta and save the return value to a const variable named pasta index. There's a lot in there, so we're going to start right now just with pasta index. So const pasta index is going to equal grocery list dot index of. Okay. Then log pasta index to the console. You may remove other console.log statements to declutter the terminal. That's probably a good idea. I'm going to get rid of at least these two. Now here we're doing the index of, so let's do pasta, and this should show us where the index of pasta is after we console.log pasta index. And let's run that. And that worked great. All right, we went through a few of these, shift, unshift, and index of. That worked great. Let's move on. Arrays and functions. Throughout the lesson, we went over arrays being mutable or changeable. Well, what happens if we try to change an array inside a function? Does the array keep the change after the function call, or is it scoped to inside the function? Take a look at the following example where we call .push on an array inside a function. Recall the .push method mutates or changes an array. Let's go over what happened in the example. The flowers array that has 3 elements. The function addFlower has a parameter of ARR, uses .push to add a lily element into ARR. We call addFlower with an argument of flowers, which will execute the code inside addFlower. We checked the value of flowers, and it now includes the lily element. The array was mutated. So when you pass an array into a function, if the array is mutated inside the function, that change will be maintained outside the function as well. You might also see this concept explained as pass by reference, since what we're actually passing the function is a reference to where the variable memory is stored and changing the memory. Instructions. In main.js, there is an array concept. There is also a function change array that will assign the element to index 3 of the array to mutated. The function change ARR was called with an argument of concept. Underneath the function call, log concept to the console to check if this reassignment mutated the array. Okay, console.log concept. And run that. So what we have going on here is arrays can be mutated, and that's all undercase, and we have a function that changes the array, and what we do is we give it an array, it takes the array at index 3 and change the array at index 3 to capital mutated, and that's what was printed onto the screen right there. Great. Let's double check what happens if we mutate an array using a built-in method inside a function. Under the console.log statement, define another function named removeElement that takes a parameter of new ARR. Inside the function body call .pop on new ARR. So we're going to get ourselves a function. I'm going to do the fat arrow style. So const remove element equals, and it's going to take in new ARR, a capital, little fat arrow function, and inside there it's going to get the new ARR dot pop, and let's try that out. Run. That works perfectly. Call remove element with an argument of concept. So we want to say remove element, and we are going to give it concept and run that. After calling remove element concept, check the value of concept by logging it to the console. Notice that in both cases, the changes to the array was maintained outside of the function. Console.log concept. And there we go. We've now popped off that last piece. Mutator is gone, and that worked perfectly. Let's go to the next one. Nested arrays. Earlier, we mentioned that arrays can store other arrays. When an array contains another array, it is known as a nested array. Examine the example below. Const nested array equals an array with an array of 1 in it, comma, with an array with 2, 3 inside that array, and then the closing array. To access the nested arrays, we can use bracket notation with the index value, just like we did to access any other element. Notice that nested R1 will grab the element in index 1, which is the array 2, 3. Then if we wanted to access the elements within the nested array, we can chain or add on more bracket notation with index values. In the second console.log statement, we have 2 bracket notations chained to nested R. We know that nested R1 is the array 2, 3. Then to grab the first element from the array, we use nested R1, 0, and we get the value of 2. Instructions. Let's make a nested array. Create a variable number clusters. Assign as its value an array with 3 array elements. The first array element should hold the elements 1 and 2 in that order. Okay, so let's do this with const number cluster, and we have an array now. And there's going to be 3 array elements. The first array element should hold elements 1 and 2 in that order. Okay, so 1, 2, and then we'll comma between, we'll open another array, and this is going to be 3, 4, comma between, open one more array for 5, 6, and now we have an array of 3 arrays. That's what they're looking for, I think. We'll find out right now. No. Did you create number clusters with an S? No, I didn't. I left off the S. That works. Great. Awesome, you made a nested array. Now declare a variable named target using the const keyword and assign to access the element 6 inside number clusters. Okay, so they want us to const target equals, and then we'll have number clusters, and they want the number 6, which is at the end. So there are 3 array elements, 0, 1, and 2. So we want to get to 2. And then within 2, we want to get to 6. So we have 0 and 1. So we just put 1 there. And that should give us the number 6 and const target. Let's run that. That is what happened. Great. That worked perfectly. Let's move on. Review arrays. Nice work. In this lesson, we learned these concepts regarding arrays. Arrays are lists that store data in JavaScript. Arrays are created with brackets. Each item inside an array is at a number position or index starting at 0. We can access one item in an array using its index, with syntax like myArray, square brackets, 0. We can also change an item in an array using its index with syntax like myArray at 0 equals new string. Arrays have a length property, which allows you to see how many items are in an array. Arrays have their own methods, including push and pop, which add and remove items from an array respectively. Arrays have many methods that perform different tasks, such as .slice and .shift. You can find documentation at Mozilla Developer Network website. Some built-in methods are mutating, meaning the method will change the array, while others are not mutating. You can always check the documentation. Variables that contain arrays can be declared with let or const. Even when declared with const, arrays are still mutable. However, a variable declared with const cannot be reassigned. Arrays mutated inside of a function will keep that change even outside the function. Arrays can be nested inside other arrays. To access elements in nested arrays, chain indices using bracket notation. Learning how to work with and manipulate arrays will help you work with chunks of data. Instructions, if you're looking for more practice, it looks like we finished this off. We'll see what's up next and get started on it. Loops. A loop is a programming tool that repeats a set of instructions until a specified condition, called a stopping condition, is reached. As a programmer, you'll find that you rely on loops all the time. You'll hear the generic term iterate when referring to loops. Iterate simply means repeat. When we need to reuse a task in our code, we often bundle that action in a function. Similarly, when we see that a process has to repeat multiple times in a row, we write a loop. Loops allow us to create efficient code that automates processes to make scalable, manageable programs. As illustrated in the diagram, loops iterate or repeat an action until a specific condition is met. When the condition is met, the loop stops and the computer moves on to the next part of the program. Check out the diagram and you can take a look at that diagram there. We'll move on to the next lesson. Repeating tasks manually. Before we write our own loops, let's take a moment to develop an appreciation for loops. The best way to do that is by showing you how cumbersome it would be if a repeated task required you to type out the same code every single time. Create a variable, vacation spots, and assign its value to an array of 3 strings naming places you'd like to visit. Okay, let's say a vacation spots. And we can make an array of 3 places. Let's say a Bali could be fun. I haven't done anything in South America, so anything in South America would be great. And how about Florida? That's where my parents live. Florida. Those are the vacation spots. And we could run that. Next, console.log each item in vacation spots. Since we don't know loops yet, we have to console.log each element in the array separately. So that would be something like this, console.log vacation spots at 0. And then we're going to need to do this 3 times, so 2 more, and 2 more, and 1, and 2, and now we'll run that. That worked. Nice work. Now imagine that the vacation list had 100 places on it. Logging each array element to the console by hand would be a tedious task. In the next exercise, we will learn how to make things more efficient with for loops. Okay, it doesn't say to do anything here. We just press run again. Okay, that's it. We'll go to the next. The for loop. Instead of writing out the same code over and over, loops allow us to tell computers to repeat a given block of code on its own. One way to give computers these instructions is with a for loop. The typical for loop includes an iterator variable that usually appears in all 3 expressions. The iterator variable is initialized, checked against the stopping condition, and assigned a new value on each loop iteration. Iterator variables can have any name, but it's best practice to use a descriptive variable name. A for loop contains 3 expressions separated by a semicolon inside the parentheses. 1. An initialization starts the loop and can also be used to declare the iterator variable. 2. A stopping condition is the condition that the iterator variable is evaluated against. If the condition evaluates to true, the code block will run, and if it evaluates to false, the code will stop. 3. An iteration system is used to update the iterator variable on each loop. The for loop syntax looks like this. For parentheses, let counter equal 0, semicolon, counter less than 4, semicolon, counter plus plus, close parentheses, open brackets, console.log counter. In this example, the output would be the following 0, 1, 2, 3. Let's break down the example. The initialization is let counter equal 0, so the loop will start counting at 0. The stopping condition is counter less than 4, meaning the loop will run as long as the iterator variable counter is less than 4. The iteration statement is counter plus plus. This means after each loop, the value of counter will increase by 1. For the first iteration, counter will equal 0. For the second, counter will equal 1, and so on. The code block inside of the curly braces, console.log counter, will execute until the condition evaluates to false. The condition will be false when counter is greater than or equal to 4. The point that the condition becomes false is sometimes called the stop condition. This for loop makes it possible to write 0, 1, 2, and 3 programmatically. Instructions. Now make your own. Create a program that loops from 5 to 10 and logs each number to the console. All right, so let's do one of these for loops. For, let's let I be the iterator or the index and equal to, what did, oh no, it said 5. Okay, and that's a semicolon. So I is less than, we'll say 11, or maybe less than or and equal to 10. Let's check this out. We could always do this again. And then I plus plus, and then we're going to console.log I. Let's try that out. That worked perfectly. All right, we'll move on to the next lesson. Looping in reverse. What if we want the for loop to log 3, 2, 1, and then 0? With simple modifications to the expressions, we can make our loop run backward. To run a backward for loop, we must set the iterator variable to the highest desired value in the initialization expression. Set the stopping condition for when the iterator variable is less than the desired amount. The iterator should decrease in intervals after each iteration. Instructions. Make a for loop that loops backwards, printing 3 to 0 to the console. Use the greater than equal to comparison operator in your stopping condition and the minus minus operator in your iteration statement. It says right up here, the loop below loops from 0 to 3. Edit it to loop backwards from 3 to 0. Okay, so we need to turn this around. So greater than or equal to, the number will be 0, and the counter will start at 3. And the counter is going to need to minus minus, and let's see what happens there. That does it. Let's move on to the next lesson. Looping through arrays. For loops are very handy for iterating over data structures. For example, we can use a for loop to perform the same operation on each element of an array. Arrays hold lists of data like customer names or product information. Imagine we owned a store and wanted to increase the price of every product in our catalog. That could be a lot of repeating code, but by using a for loop to iterate through the array, we could accomplish this task easily. To loop through each element of an array, a for loop should use the array's .length property in its condition. Check out the example below to see how for loops iterate on arrays. Const animals has 1, 2, 3 things within its array. The for loop says for, and the conditions are let I equal 0, I is less than animals.length, I plus plus, console.log animals. This example would give you the following output: grizzly bear, sloth, sea lion. In the loop above, we've named our iterator variable I. This is a variable naming convention you'll see in a lot of loops. When we use I to iterate through arrays, we can think of it as being shorthand for the word index. Notice how our stopping condition checks the I is less than animals.length. Remember that arrays are zero indexed. The index of the last element of an array is equivalent to the length of that array minus 1. If we try to access an element at index of animals.length, we will have gone too far. With for loops, it's easier for us to work with elements in an array. Instructions. Write a for loop that iterates through our vacation spots array using I as the iterator variable. Inside the block of the for loop, use console.log to log each element in the vacation spots array after the string I would love to visit. For example, the first round of the loop should print I would love to visit Bali to the console. Write your code below. So we're going to do a for loop. Let I, say wanted I to be the iterator, and I will equal 0. The next will be is I greater than vacation spots dot length I plus plus, and then we're going to console.log and use your backticks for this because they want us to say I would love to visit $, open up your curly braces, and we're going to put in vacation spots, and after vacation spots, open up square brackets and put I inside of there. And let's see if that works for us. Let's run that. Nope, we did this wrong. Did you use I? Oh, I'm sorry. I reversed this from the last exercise when it had to be greater than. That was the mistake. So the mistake there, just in case that seemed weird to you. On the last one, we reversed it. We had to go from the top to the bottom, so I did it that way again. This is saying while I is less than vacation spots dot length, I plus plus, add to I. If you did the opposite and we start at 0, it would say while I is greater than vacation spots dot length, I plus plus. And I is never greater than vacation spots dot length because it starts at 0 and this won't run. The iterator won't run. That's what's happening there. Let's move on to the next lesson. Nested loops. When we have a loop running inside another loop, we call that a nested loop. One use for a nested for loop is to compare the elements in two arrays. For each round of the outer for loop, the inner for loop will run completely. Let's look at an example of a nested for loop. Now they're showing a nested for loop. These are for loops within each other. It's a lot to read. If you want to look it over, you're going to see you have a for loop, and within that for loop, you also have a for loop. And for every I in the first for loop, let I equal 0. While I equals 0, J will run in the second for loop from 0 to your array.length before iterating I to 1. And then it will run J again until iterator.length, and then I will go to 2, and so on. Let's think about what's happening in the nested loop in our example. For each element in the outer loop array, my array, the inner loop will run in its entirety comparing the current element from the outer array, my array I, to each element of the inner array, your array, J. When it finds a match, it prints a string to the console. Now it's your turn to write a nested loop. Imagine you're a bigwig programmer for a social media platform. You have been tasked with building a prototype for a mutual followers program. You'll need 2 arrays of friends from 2 mock users so that you can extract the names of the followers who exist in both lists. Make a variable called Bob's followers, and set it equal to an array with 4 strings representing the names of Bob's friends. Okay, so we will have a const Bob's followers is equal to an array of Bob's friends. We'll say Bob has a friend named Bob. Bob has a friend named Has. And Bob has a friend named No. And one named Friends. Bob has no friends. Those are all his followers. And let's run that. Make a variable called Tina's followers and set it equal to an array with 3 strings representing the names of Tina's friends. Make exactly 2 of these the same as 2 of the friends in the Bob's followers array. So const Tina's followers equals, and there's an array, Tina. So that doesn't match. I'm going to make these capital too. Tina has many friends. So we should match on has, and we should match on friends. Those are the 2, right? It said 2. Oh, no, there's only supposed to be 3 in this array. So we'll just say Tina has friends. There's 3 in the array now, and let's run that. That works. Create a third variable named mutual followers and set it to an empty array. So const mutual followers equals empty array. Let's run that. Create a nested loop that iterates through Bob's followers as the array for the outer loop and Tina's followers as the array for the inner loop. If the current element from the outer loop is the same as the current element from the inner loop, push that element into the mutual followers array. Okay, so here comes our nested for loop. So for, oh, I did for already. Let I equal 0. I is less than, it was Bob's first, right? Bob's followers dot length I plus plus. Inside there we'll have for let j equal 0. J is less than Tina's followers dot length j plus plus. And inside there we are going to compare, we'll do an if statement. If Bob's followers at I triple equals Tina's followers at j, we will mutual followers dot push, and we could take either of them there. Let's take it from Tina. Tina's followers at j. That should work. Let's take a look. Oh, looks like I made a mess. You likely made a syntax error. I wrote Tina followers. That's Tina's followers. Let's see. Perfect. And that's that. Let's move on to the next lesson. The while loop. You're doing great. We're going to teach you about a different type of loop, the while loop. To start, let's convert a for loop into a while loop. So they show a for loop, and we've seen for loops be for. This one lets counter 1 equal 1. When counter 1 is less than 4, counter 1 plus plus. Then we console.log counter 1. Let counter 2 equal 1. While counter 2 is less than 4, console.log counter 2, and then counter 2 plus plus. So it's doing its iteration after it console.logs in the while loop there. Let's leave this in if we can. Okay. Let's break down what's happening with our while loop syntax. The counter2 variable is declared before the loop. We can access it inside our while loop since it's in the global scope. We start our loop with the keyword while followed by our stopping condition, or test condition. This will be evaluated before each round of the loop. While the condition evaluates to true, the block will continue to run. Once it evaluates to false, the loop will stop. Next, we have our loop's code block, which prints counter2 to the console and increments counter2. What would happen if we didn't increment counter2 inside our block? If we didn't include this, counter2 would always have its initial value 1. That would mean the testing condition counter2 less than 4 would always evaluate to true, and our loop would never stop running. This is called an infinite loop, and it's something we always try to avoid. Infinite loops can take up all of your computer's processing power, potentially freezing your computer. So you may be wondering when to use a while loop. The syntax of a for loop is ideal when we know how many times the loop should run, but we don't always know this in advance. Think of eating like a while loop. When you start taking bites, you don't know the exact number you'll need to become full. Rather, you'll eat while you're hungry. In situations when we want a loop to execute an undetermined number of times, while loops are the best choice. Instructions. Below the cards array, declare a variable, current card, with the let keyword, but don't assign the value. Okay, let current card and run. Great. Create a while loop with a condition that checks if the current card does not have the value spade. Inside the block of your while loop, add the following line of code. Okay, so let's do the while loop first. While current card is not equal to, and that was spade all undercase. We pasted that in. Math.floor, math.random times 4 will give us a random number from 0 to 3. We'll use this number to index the cards array and assign the value of current card to a random element from the array. Let's run that. That worked. Awesome, your loop is running, but you can't tell because it doesn't output anything. Let's add a console.log statement to our while loop. Inside the block, after you assign current card a value, log current card to the console. For fun, you can run your code a few times and see if the output changes. In here, console.log current card, and let's run it. First one we came up with was a spade, so let's do one more. There you go, you had a heart first, then a club, then a spade. Perfect. Next. Do while statements. In some cases, you want a piece of code to run at least once and then loop based on a specific condition after its initial run. This is where the do while statement comes in. A do while statement says to do a task once and then keep doing it until a specified condition is no longer met. The syntax for a do while statement looks like this. Let countString equal empty string. Let I equal 0. Do, and it opens up curly braces, countString equals countString plus I plus plus, close curly braces, while I is less than 5. Console.log countString. In this example, the code block makes changes to the countString variable by appending the string form of the I variable to it. First, the code block after the do keyword is executed once. Then the condition is evaluated. If the condition evaluates to true, the block will execute again. The looping stops when the condition evaluates to false. Note that the while and do while loops are different. Unlike the while loop, do while will run at least once whether or not the condition evaluates to true. Instructions. We'd like a program to simulate part of the cake baking process. Depending on the recipe, a different number of cups of sugar is required. Create a variable cups of sugar needed and assign it to a number value of your choosing. The cups of sugar must be added to the batter one at a time. Declare the variable cups added and assign it 0. Okay, so we need a const that says cups of sugar needed, and camel case all of that. And let's say it needs 4 cups of sugar for the cake. Then we need another const called cups added, and we're going to assign that to 0. All right, run that. That worked. We have a sweet tooth, so we want to add at least 1 cup of sugar to the batter, even if the value of cups of sugar needed is 0. Create a do-while loop which increments cups added by 1 while cups added is less than cups of sugar needed. All right, let's look at that context again. All right, so it looks like we have a do, we open up curly braces, and then while comes after that, and takes parentheses. Let's figure this out here. Create a do-while loop which increments cups added by 1 while cups added is less than cups of sugar needed. Do. Okay, so in our do, we want cups added plus plus while cups added is less than cups of sugar needed. Let's see if that works for us. We'll run that. Oh, we shouldn't be able to iterate this one. Let's let cups added. That probably will help. That was the mistake. Const can't be reassigned. Let can be reassigned. When I read this here, I thought they wanted both const. I didn't see a let. But yeah, we figured that one out. Let's move on to the next one. The break keyword. Imagine we're looking to adopt a dog. We plan to go to the shelter every day for a year and then give up. But what if we meet our dream dog on day 65? We don't want to keep going to the shelter for the next 300 days just because our original plan was to go for a whole year. In our code, when we want to stop a loop from continuing to execute even though the original stopping condition we wrote for our loop hasn't been met, we can use the keyword break. The break keyword allows programs to break out of the loop from within the loop's block. Let's check out the syntax of the break keyword. We have a for loop, and after the okay, let's actually read it through. So for, and in there is let I equal 0, I is less than 99, I plus plus. Inside of the body of that for loop, it says if I is greater than 2, break. And then console.log banana. Console.log, aren't you glad I broke out of the loop? The output of the above code is banana, 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 aren't you glad I broke out of the loop? Break statements can be especially helpful when you're looping through large data structures. With breaks, you can add test conditions besides the stopping conditions and exit the loop when they're met. Instructions. Log each element from wrapper array in a for loop with the iterator variable I. Okay, so we'll do for let I equal 0. Got a little period there. I is less than wrapper array dot length, and then I plus plus console.log wrapper array at I. Let's run that. There we are with Little Kim, Jay-Z, Notorious B.I.G., and Tupac. After the for loop, log the string, and if you don't know, now you know, to the console. Note, since there's a single quote character in our string, we can use double quotes around the string to make sure the character prints. Okay, we can do that. So this says after the for loop, we want to log this. So here's our for loop, and then after that, we're going to console.log. Get that double quotes up, and I'm just going to paste this in. Run. And that worked. Add a break inside your loop block that breaks out of the loop if the element at the current index in the wrapper array is notorious BIG. Okay, so we will console.log all of that, and then after that we'll make an if statement, and the if will be if wrapper array, let's put our I, sorry about that, brackets I, and then triple equals, and make sure you got this exactly how they have it. And G, and then what we'll do is break. Let's run that. That worked perfectly. Let's go to the next lesson. Review. Great job. In this lesson, we learned how to write cleaner code with loops. You now know loops perform repetitive actions so that we don't have to code that process manually every time. How to write for loops with an iterator variable that increments or decrements. How to use a for loop to iterate through an array. A nested for loop is a loop inside another loop. While loops allow for different types of stopping conditions. Stopping conditions are crucial for avoiding infinite loops. Do-while loops run code at least once, only checking the stopping condition after the first execution. The break keyword allows programs to leave a loop during the execution of its block. And let's see what's up next. Higher order functions. Higher order functions. Introduction. We are often unaware of the number of assumptions we make when we communicate with other people in our native languages. If we told you to count to 3, we would expect you to say or think the numbers 1, 2, and 3. We assumed you would know to start with 1 and end with 3. With programming, we're faced with needing to be more explicit with our directions to the computer. Here's how we might tell the computer to count to 3. For, and this is a for statement with let I equal 1, I is less than or equal to 3, I++, and in the body, console.log I. When we speak to other humans, we share a vocabulary that gives us quick ways to communicate complicated concepts. When we say bake, it calls to mind a familiar subroutine, preheating an oven, putting something into an oven for a set amount of time, and finally, removing it. This allows us to abstract away a lot of the details and communicate key concepts more concisely. Instead of listing all those details, we can say, we baked a cake, and still impart all that meaning to you. In programming, we can accomplish abstraction by writing functions. In addition to allowing us to reuse our code, functions help to make clear, readable programs. If you encountered count to 3 in a program, you might be able to quickly guess what the function did without having to stop and read the function's body. We're also going to learn about another way to add a level of abstraction to our programming: higher order functions. Higher order functions are functions that accept other functions as arguments and/or return functions as output. This enables us to build abstractions on their abstractions, just like we hosted a birthday party is an abstraction that may build on the abstraction we made a cake. In summary, using more abstraction in our code allows us to write more modular code, which is easier to read and debug. And we'll move on to the next lesson. Functions as data. JavaScript functions behave like any other data type in the language. We can assign functions to variables, and we can reassign them to new variables. Below, we have an annoyingly long function name that hurts the readability of any code in which it's used. Let's pretend this function does important work and needs to be called repeatedly. It's a const that's read, announce that I am doing important work. What if we wanted to rename this function without sacrificing the source code? We can reassign the function to a variable with a suitably short name. Const busy equals announce that I am doing important work. Busy as a function, this function call barely takes any space. Busy is a variable that holds a reference to our original function. If we could look up the address in memory of busy and the address in memory of announce that I am doing important work, they would point to the same place. Our new busy function can be invoked with parentheses as if it was the name we originally gave our function. Notice how we assign announce that I am doing important work without parentheses as the value to the busy variable. We want to assign the value of the function itself, not the value it returns when invoked. In JavaScript, functions are first-class objects. This means, like other objects you've encountered, JavaScript functions can have properties and methods. Since functions are a type of object, they have properties such as .length and .name and methods such as toString. You can see more about the methods and properties of functions in the documentation. Functions are special because we can invoke them, but we can still treat them like any other type of data. Let's get some practice doing that. Instructions. We've defined a function with a very long name. Check that 2 plus 2 equals 4 a million times. This function takes a long time to execute. It checks whether 2 plus 2 equals 4, but it does it a million times, just to be really sure. Create a shorter named variable is2p2 that will be easier to work with and assign check that 2 plus 2 equals 4 a million times as its value. So right down here, we will const, and they want it to be called is2p2 is going to be equal to this right here. I'm going to copy and paste that, and we'll run it. Invoke your is2p2 function. Okay, so right under this, is2p2 as a function, and let's see how that works. If we forgot the original name of our function, is there a way we could figure it out? Use is2p2 to console.log the name property of the function we assigned to is2p2. Check out the documentation if you need a hint. So we're going to console.log is2p2.name. Run that. Oh, I wrote p2. And that works right there. It reveals the name. Check that 2 plus 2 equals 4 a million times. To the next lesson. Functions as a parameter. Since functions can behave like any other type of data in JavaScript, it might not surprise you to learn that we can also pass functions into other functions as a parameter. A higher order function is a function that either accepts functions as a parameter, returns a function, or both. We call the functions that get passed in as parameters and invoke callback functions because they get called during the execution of the higher order function. When we pass a function in as an argument to another function, we don't invoke it. Invoking the function would evaluate to the return value of that function call. With callbacks, we pass in the function itself by typing the function name without parentheses. That would evaluate to the result of calling the function. We wrote a higher order function, timefuncRuntime. It takes in a function as an argument, saves a starting time, invokes the callback function, records the time after the function was called, and returns the time the function took to run by subtracting the starting time from the ending time. This higher order function could be used with any callback function, which makes it a potentially powerful piece of code. We then invoke time_func_runtime first with the add1to1 function. Note how we passed in add1to1 and did not invoke it. In this example, we invoke time_func_runtime with an anonymous function that counts backwards from 10. Anonymous functions can be arguments too. Let's get some practice using functions and writing higher order functions. Save a variable time2p2. Assign as its value the result of invoking the time_func_runtime function with the check that 2 plus 2 equals 4 a million times function. Let's save a variable. So const time2p2 is going to equal time_func_runtime. And we're going to invoke it. And while invoking it, we're going to pass it another function, and that's going to be this function right here that checks that 2 plus 2 is 4 a million times. And we're going to invoke that as well. If I've read this all right, let's give it a shot. Oh, I see what they want. Okay, they don't want this one invoked like they were saying before. It shouldn't be invoked here because we don't want to pass the value. They just invoked it themselves here, so that made it a little confusing. So let's go ahead and run that. That works. Okay. Write a higher order function, check consistent output. This function should have two parameters, a function and a value. It should call the argument function with the value 2 times. If the callback function produces the same result twice, it should return the result of the function call. Otherwise, it should return the string. This function returned inconsistent results. We're going to write a higher order function. So const, it's going to be called check consistent. You know what? I'm going to paste this in because they really don't like when you miss anything. Check consistent output. This function should have two parameters, a function and a value. So we'll say func and val. And we'll just we'll make it a fat arrow function. It should call the argument function with the value 2 times. If the callback function produces the same result twice, it should return the result of the function call. Otherwise, it should return the string, this function returned inconsistent results. All right, let's take a look at how to do that. So we're going to run this function twice with the same value. So let's, I think we need to hold the variables. Let's see, const run 1. Let's do that with let. Let run 1 and let run 2. Now what I want to do, it's going to be equal to the function with the value. And we're doing this twice, so we'll do the same thing again. Func with the value. Then after that, if run 1 triple equals run 2, it should return the result of the function. Okay, so then we could just return run 1 would be just fine. And we'll do an else, and there we're going to do our, was it a console log? No, it needs to return a string. So return a string that says, let's copy it. It'll say, this function returned inconsistent results. Let's try this out and see if it works. That did work, great. 3. Invoke your check consistent output with the add2 function we wrote and a number as arguments. Okay, so now we're going to invoke the function that we just made. So we'll say check consistent. I'm going to copy these a little bit more because that seems to be what gives us the most errors, is small typos here. Invoke your check consistent output, and that's invoked with the add2. That's the function that we're going to pass it. And we're also going to take in a number, and it could be, I guess, any number. Let's say 5. That sounds good to me. Let's run that. That works. All right, great. Let's move on to the next lesson. Review. Great job. By thinking about functions as data and learning about higher order functions, you've taken important steps in being able to write clean, modular code and take advantage of JavaScript's flexibility. Let's review what we learned in this lesson. Abstraction allows us to write complicated code in a way that's easy to reuse, debug, and understand for human readers. We can work with functions the same way we would any other type of data, including reassigning them to new variables. JavaScript functions are first-class objects, so they have properties and methods like any object. Functions can be passed into other functions as parameters. A higher-order function is a function that either accepts functions as a parameter, returns a function, or both. Let's see what's up next. And next we have iterators. Introduction to iterators. Imagine you had a grocery list and you wanted to know what each item on the list was. You'd have to scan through each row and check for the item. This common task is similar to what we have to do when we want to iterate over or loop through an array. One tool at our disposal is the for loop. However, we also have access to built-in array methods which make looping easier. The built-in JavaScript array methods that help us iterate are called iteration methods. At times referred to as iterators, iterators are methods called on arrays to manipulate elements and return values. In this lesson, you will learn the syntax for these methods, their return values, how to use the documentation to understand them, and how to choose the right iterator method for a given task. Instructions. Inspect the code in main.js. Notice the different methods being called on the arrays: for each, map, and filter. Run the code to see the output. We have a for each, map, and filter. Let's run them. And we can see that for each is going to take in an artist, so that'll be the element. And then we can console.log the element with the string attached to it, and that's what happens. So for each, I guess, artist in the artists array, console.log artist plus the name. Let's look at const numbers as an array again. Const squared numbers equals numbers.map. And map is a function that's going to take in number, and number is going to be part of a function here and return number times number. So whichever number gets passed in is going to get squared and returned. And that looks to be what happened here, as the square root of 1 is 1, of 2 is 4, of 3 is 9, of 4 is 16, and of 5 is 25. Let's look at this one. This is const thing, and it is yet another array, and this is a mixed array with numbers. It has strings. Const only numbers, things.filter. Thing, and that's the element, the first element in the array, and it'll be the second, third, fourth, fifth. It'll be every element in the array, this thing right here. Return type of thing triple equal to number. So what it's saying is filter through the things array right here and check if it's type of number. So if the thing is equal to number, type of number, and return only the numbers. And you'll see only numbers are returned here, 5, 3.14, and 100. Let's move on. The for each method. The first iteration method that we're going to learn is .for each. Aptly named, for each will execute the same code for each element of an array. Let me keep this code in. The code above will log a nicely formatted list of the groceries to the console. Let's explore the syntax of invoking .for each. Groceries.for each calls the for each method on the groceries array. .for each takes an argument of callback function. Remember, a callback function is a function passed as an argument into another function. For each loops through the array and executes the callback function for each element. During each execution, the current element is passed as an argument to the callback function. The return value for each will always be undefined. Another way to pass a callback for each is to use arrow function syntax. Groceries.for each, grocery item, arrow function, console.log, that grocery item. So that would console.log each grocery item. We can also define a function beforehand to be used as the callback function. Function print groceries takes in an element and console.logs that element. Groceries.for each is going to take in that function, which is called print groceries. The above example uses a function declaration, but you can also use a function expression or arrow function as well. All three code snippets do the same thing. In each array iteration method, we can use any of the three examples to supply a callback function as an argument to the iterator. It's good to be aware of the different ways to pass in callback functions as arguments in iterators, because developers have different stylistic preferences. Nonetheless, due to the strong adoption of ES6, we will be using arrow function syntax in later exercises. Instructions. Iterate over the fruits array to log I want to eat a plus the name of each fruit to the console. For example, I want to eat a mango. You may use any form of callback function. So we are going to do a for each, and let's do it like this. That's how they say they're going to do it later in the course. So let's say fruits dot for each, and it'll take in fruit. We'll just call it a single fruit. Now this doesn't matter. This could be anything. This could be EL for element. This could be I. This could be item. It does not matter what you put here. We're just going to call it this now, and we're going to iterate it with this name. Fruit is now each one of the values. So mango is fruit, papaya is fruit, pineapple is fruit, and apple is fruit. So what does it want us to console log here? Iterate over the fruits array and log I want to eat. So we'll do that in console.log. Do your backticks. I want to eat. And then they want the name of the fruit. So $ open curly braces. And we just have to type in fruit because that's what we called it right here. Let's see if that works out for us. Oh, I'm sorry. I want to eat a, and then the fruit. There we go. Let's go on to the next one. The .map method. The second iterator we're going to cover is .map. When .map is called on an array, it takes an argument of a callback function and returns a new array. Take a look at an example of calling .map. Const numbers is an array of numbers 1, 2, 3, 4, and 5. The big numbers equals numbers.map, and then a function that takes number and returns number times 10. .map works in a similar manner to for each. The major difference is that .map returns a new array. We'll keep this in here. In the example above, numbers is an array of numbers. Big numbers will store the return value of calling .map on numbers. Numbers.map will iterate through each element in the numbers array and pass the element into the callback function. Return number times 10 is the code we wish to execute upon each element in the array. This will save each value from the numbers array multiplied by 10 to a new array. If we take a look at numbers and big numbers, console.log numbers would be an output of an array 1, 2, 3, 4, and 5, and console.log big numbers would be an output of an array of 10, 20, 30, 40, 50. Notice that the elements in numbers were not altered, and big numbers is a new array. Instructions. Add your code under the animals array and before the line console.log secret message.join. Use .map to create a new array that contains the first character of each string in the animals array. Save the new array to a const variable named secret message. So this is going to be before secret message. So here we want to use the .map to create a new array of animals. So animals.map. And we'll create a new array. We can call it animal, or you know what, let's call it element, so we can kind of just show what it's doing here. We'll call .map to make a new array that contains the first character of each string in the animals array. Okay, so it'll be element, and then what it should do is return element 0. So element at 0 will be the first letter, and we need to hold this somewhere. So let's hold it in const. Did they give us a name? Yes, it's called secret message. So it's this one right here. So const secret message equals animals.map element and return element at 0. Let's run that. Oh, I see. We can't just do this in one line. We need to close these in. Let's see if that works. That does work, and it prints out hello world. Okay, so use .map to divide all the numbers in big numbers by 100. Save the returned values to a variable declared with const called small numbers. So let's do const small numbers, and that is going to equal big numbers dot map, and inside of map we'll take an element, and remember we need these curly braces here, so we'll put those curly braces up, and every element will be divided by 100 and return that. That should do it. Let's run that. Great, let's move on to the next lesson. The filter method. Another useful iterator method is filter. Like map, filter returns a new array. However, filter returns an array of elements after filtering out certain elements from the original array. The callback function for the filter method should return true or false depending on the element that is passed into it. The elements that cause the callback function to return true are added to the new array. Take a look at the following example. Const words is an array with chair, music, pillow, brick, pen, and door. Const short words is equal to words.filter, then word, fat hour function, will return word.length less than 6. Words is an array that contains string elements. Const short words equals declares a new variable that will store the returned array from invoking .filter. The callback function is an arrow function, has a single parameter, word. Each element in the words array will be passed to this function as an argument. Word.length less than 6 is the condition in the callback function. Any word from the words array that has fewer than 6 characters will be added to the short words array. Let's also check the values of words and short words. Console.log words, the output will be chair, music, pillow, brick, pen, and door. Console.log short words, the output will be chair, music, brick, pen, and door, because pillow has too many letters. Observe how words was not mutated, i.e. changed, and short words is a new array. Instructions. Call the .filter method on random numbers to return values that are less than 250. Save them to a new array called small numbers declared with a const. All right, so we have random numbers up here, and we're going to do our filter over here. So we're going to const small numbers. That's going to equal random numbers dot filter. We'll open that up. We will give it an element, which is one of the numbers. We'll open up our brackets here, and inside of here we'll do our code. And it needs to return values that are less than 250. So return elements that are less than 250. Let's see how that works. That works great. Now let's work with an array of strings. Invoke .filter on the favorite words array to return elements that have more than 7 characters. Save the returned array to a const variable named long favorite words. So const long favorite words is going to equal favorite words dot, and we're using filter again. Filter. We'll take an element, we'll open a function, and now we need to return elements that have more than 7 characters. So what we can do here is we'll do an if statement. I think that's the best way to do it. If element.length is greater than or equal to 7, we will return element. Otherwise, we'll just do nothing. Let's run that. Did you call filter on favorite words and save the return to, oh, no, I didn't. I called it log. That should be long. Run that. Oh, it doesn't say greater than or equal to. It has to be greater than 7. So just get rid of that equal to. I misread that. Great. We got it right now. So let's read this again since I made a mistake on it. We have a const long favorite words, and it's equal to favorite words dot filter. It's going to take each element from long favorite words, and if the element dot length is greater than 7, we're going to return that element as a new array into a new array that's being held into long favorite words. That's where the array is being held. So that's what happened there. Let's move on. The find index method. We sometimes want to find the location of an element in an array. That's where the find index method comes in. Calling find index on an array will return the index of the first element that evaluates to true in the callback function. Const jumbled nums equals an array with 123, 25, 78, 5, and 9. Const less than 10 equals jumbled nums dot find index. Num is passed in, and we have a function that returns num is less than 10. Jumbled nums is an array that contains elements that are numbers. Const less than 10 declares a new variable that stores the returned index number from invoking find index. The callback function is an arrow function that has a single parameter, num. Each element in the jumbled nums array will be passed to this function as an argument. Num is less than 10 is a condition that elements are checked against. .find index will return the index of the first element which evaluates to true for that condition. Let's take a look at what less than 10 evaluates to. Console.log less than 10. The output is 3. Let's take a look and just make sure that's right. Less than 10. Yeah, the number is 5 here, and its index would be 0, 1, 2, 3. If we check what element has index of 3, console.log jumble nums at index 3, the output would be 5. Great, the element in index 3 is the number 5. This makes sense since 5 is the first element that is less than 10. If there isn't a single element in the array that satisfies the condition in the callback, then .findIndex will return -1. Const greater than 1,000 jumbled nums.findIndex with the num, and it's going to return numbers that are greater than 1,000. The output of that will be -1 because there are no numbers greater than 1,000. Invoke.findIndex on the animals array to find the index of the element that has the value elephant, and save the returned value to a const variable named foundAnimal. So let's make a const foundAnimal, and what are we doing? We're invoking findIndex on animals, so animals.findIndex, and we'll invoke it. And we have to find elephant. So we want to find index, and we want to take all the animals. We'll take all the animals. We'll have our function here. And now we just want to return the elephant. So we want to say return element == elephant. That does sound weird there, doesn't it? All right, let's run that, see if it works. And it did work. Great. Now, number 2. Let's see if we can find the index of the first animal that starts with the letter S. Call findIndex on the animals array, return the index of the first element that starts with the letter S. Assign the return value to a const variable named starts with S. So we'll make a const right down here, and we'll call it starts with S. And that will equal animals.findIndex. It will take in an element, and we have our function right here. We'll say if el, and we'll say 0, because that'll be, now this is a little confusing. So if element at 0, we're talking about a string now. At 0 is going to be the first letter. So that's what we're saying. If element at 0 is =, and the letter was S, we're going to return the element. And otherwise we'll get a -1. Let's try that out. Perfect. Let's move on. The reduce method. Another widely used iteration method is reduce. The reduce method returns a single value after iterating through the elements of an array, thereby reducing the array. Take a look at the example below. Const numbers equals an array of 1, 2, 4, and 10. Const summed numbers equals numbers.reduce with an accumulator, comma, current value. Arrow function is going to return accumulator plus current value. And when it console.logs summed numbers, the output is 17, and that is the sum of 10, 4, 2, and 1. Here are the values of accumulator and current value as we iterate through the numbers array. Iteration first, accumulator 1, current value 2, return value 3. Iteration second, accumulator 3, current value 4, return value 7. Iteration third, accumulator 7, current value 10, return value 17. Now, let's go over the use of reduce from the example above. Numbers is an array that contains numbers. Summed numbers is a variable that stores the returned value of invoking .reduce on numbers. Numbers.reduce calls the reduce method on the numbers array and takes a callback function as argument. Should be as an argument. The callback function has two parameters, accumulator and current value. The value of accumulator starts off as the value of the first element in the array, and the current value starts as the second element. To see the value of accumulator and current value change, review the chart above. As reduce iterates through the array, the return value of the callback function becomes the accumulator value for the next iteration. Current value takes on the value of the current element in the looping process. The .reduce method can also take an optional second parameter to set an initial value for accumulator. Remember, the first argument is the callback function. For instance, const numbers is an array of 1, 2, 4, and 10. Const summed numbers is equal to numbers.reduce. It passes in accumulator and current value. We set our function to return accumulator plus current value, and after the function closes, we have a comma for a second argument. The second argument is 100. So that's where the accumulator is supposed to start. So we will console.log summed numbers, and the output would be 117 in this case. Here's an updated chart that accounts for the second argument of 100. Iteration, first, accumulator 100, current value 1, return value 101. Iteration second, accumulator 101, current value 2, return value 103. Iteration third, accumulator 103, current value 4, return value 107. Iteration fourth, accumulator 107, current value 10, return value 117. Instructions. Let's practice calling .reduce and using console.log to check the values as .reduce iterates through the array. In main.js, there is an array of numbers, new numbers. To start, declare a new variable named newSum using the const keyword. Let's do that right away. Const newSum. Using the const keyword. Assign to newSum the value of calling .reduce on numbers equals .reduce. So we need, does it say numbers or new numbers? New numbers. .reduce as a function. You don't need to provide any arguments to .reduce yet. You'll also see a type error, undefined is not a function, but we will fix that after we add our callback function in the next step. So that's all they wanted us to do, it seems like. Let's run it. And yes, that's what they wanted. Provide .reduce with an argument of a callback function. The callback function has two parameters. The first parameter is current value. Use either a function expression or an arrow function. All right, so in here, we will do an anonymous arrow function. So here is where we will put our, what do they call them? Argument parameters. We'll put our parameters right up here. Accumulator, current value. And that's all they asked to do, so let's run that. To check the value being used as we iterate through the array, add 3 statements to the function body of the callback. Console.log, a string, the value of accumulator, and then comma to accumulator. So let's do that. I'm going to copy these. And we have another console.log here, and this is going to be the current value. Let's take a look there. And a return statement that adds accumulator to current value. So return let's just paste it there. Accumulator plus current value. Let's run that. And we see what we're getting. We have our accumulator current value, accumulator current value, and the current value always adds to the accumulator, and that's how this is summed. Log the value of new sum to the console to see the return value of calling .reduce on new numbers. Console.log new sum. And we'll run that. 16 is the answer. While we have this code set up, let's also check what happens if you add a second argument to reduce. The second argument acts as an initial value for the accumulator. Add a second argument of 10 to reduce. So in reduce, at the end of it, seems to be right here. Yes, so at the end of reduce, we want to comma here and add in 10. I think that's the right spot to run it. And that worked perfectly. And now you could see the answer is 26 because we started on the number 10 and we added all of these, which sum to 16, which means the answer altogether would be 26. Let's go to the next one. Iterator documentation. There are many additional built-in array methods, a complete list of which is on the MDN array iteration methods page. The documentation for each method contains several sections. 1. A short definition. 2. A block with the correct syntax for using the method. 3. A list of parameters the method accepts or requires. 4. The return value of the function. 5. An extended description. 6. Examples of the method's use. 7. Other additional information. In the instructions below, there are some errors in the code. Use the documentation for a given method to determine the error or fill in a blank to make the code run correctly. Instructions. In the code editor, there is an array called words. We want to create a new array of interesting words. The first thing we want to do is check if there are words that are fewer than 6 characters long. There is something missing in the words.sum method call. Fix this method so that true is printed to the console. For more information, browse MDM's documentation on .sum. Let's take a look at what it looks like first so we know what we're working with. We have console.log words.sum. It's taking in nothing here, and it's making this variable up out of nowhere. I'm just guessing we have to put word in here, and we could check the documentation as well just so we can learn more, but this seems to be the issue. Let's take a look. Okay, and that's it. We had to have word here in order for word to be here. This is word referring to each element of the array. So without that, this is actually undefined, and undefined.length is impossible. Number 2, the sum method returned true, which means there are some words in the array that are shorter than 6 characters. Use the .filter method to save any words longer than 5 characters to a new variable called interesting words, declared with the const. Let's do that first. Const interesting words. We've used filter in previous exercise, but for more information, browse MDN's documentation on .filter. So what we want to do here now is use the .filter method to save any words longer than 5 characters to a new variable. So now we want to say words.filter, and in there we'll take an element, we'll make our fat arrow function, and we want to return, let's do an if and then the return, if element.length is greater than 5 characters, and return element. Let's try that out. And that worked. 3. In the last line of main.js, there is this code, console.log, and it takes in interesting words.every word, and then the function does not finish. Complete the code between the parentheses to check if every element has more than 5 characters. Make sure to uncomment the last line of the program before you run the code. For more information, browse MDN's documentation on every. So this is every. I imagine it's not like sum and will only return something like true if every number is greater than 5. Now let's check that documentation and get this right. The every method. Okay. Const is below threshold equals current value less than 40. Okay. Console.log array1.every is below threshold. So we're going to pass in, there's no return here. Okay. There's no return. Let's read a little bit more. Let's see if we have another. Okay, here's an arrow function one. Every x is, okay. So we just have to give it a specification and not return anything from it. It's just going to return true or false. That's the big mistake that was made here. So we will look at their arrow function. So it'll say every, we'll pass in x, or what did we pass in? I think we passed in word. So we'll pass in word. We'll do our arrow. And if word is greater than the number was 5 or 6. So that's how we should be doing it. So there should be no return, and we don't really need an if statement. Kind of just need this right here. Where are you attached to? Nothing. Okay, let's run that and see what we get. All right, let's check if just putting it on the same line will work. That does work. So our function works this way. Okay, so we learned a little bit about every. And we are now finished with that. Great, let's move on to the next one. Iterators. Choose the right iterator. There are many iteration methods you can choose. In addition to learning the correct syntax for the use of iteration methods, it is also important to learn how to choose the correct method for different scenarios. The exercises below will give you the opportunity to do just that. You'll see errors pop up in the terminal as you work through the exercise, but by the end the errors will be gone. Instructions. Replace the word method in the first method call with a method that will do something to each of the values in the array and return undefined. So we did have a method that did something to each thing in the array, but didn't return a new array. So I think that was for each. So let's go ahead and head over to cities.method and for each, try that out. That worked. In the second method call, replace the word method with a method that will return a new array with only those elements longer than 7 characters. All right, so the new array was the filter. So we'll use the filter method, and the filter will take in each city, and city.length, it'll return city.length that is greater than 7. Okay, great. Let's see if that works. That did work. In the third method call, replace the word method with a method that takes an array that contains multiple values and returns a single value. So in the third method call, that's you right here. And we are going to take an array that contains multiple values and return a single value. We just did that one. That was reduce. Let's run that. Great. In the fourth method call, replace the word method with a method that will return a new array of numbers returned from the function. A new array this time. That was the map method that was returning a new array. Let's see where this is. Map. In the fifth method call, replace the word method with a method that will return a Boolean value. We had 2 of those. We had sum and every, and we just used every. So let's try sum and run that. And we got it. Let's move on to the next lesson. Review. Awesome job on clearing the iterators lesson. You have learned a number of useful methods in this lesson, as well as how to use the JavaScript documentation from the Mozilla Developer Network to discover and understand additional methods. Let's review. For each is used to execute the same code on every element in an array, but does not change the array and returns undefined. Map executes the same code on every element in an array and returns a new array with the updated elements. Filter checks every element in an array to see if it meets certain criteria and returns a new array with the elements that return truthy for the criteria. FindIndex returns the index of the first element of an array which satisfies a condition in the callback function. It returns -1 if none of the elements in the array satisfies the condition. Reduce iterates through an array and takes the values of the elements and returns a single value. All iterator methods takes a callback function that can be predefined or a function expression or an arrow function. You can visit the Mozilla Developer Network to learn more about iterator methods and all other parts of JavaScript and instructions if you want to challenge yourself, and here are some more things that we can do, but let's move on to the next lesson. Objects. Introduction to objects. It's time to learn more about the basic structure that permeates nearly every aspect of JavaScript programming. Objects. You're probably already more comfortable with objects than you think, because JavaScript loves objects. Many components of the language are actually objects under the hood, and even the parts that aren't, like strings or numbers, can still act like objects in some instances. There are only 7 fundamental data types in JavaScript, and 6 of those are primitive data types: string, number, boolean, null, undefined, and symbol. With the 7th type, objects, we open our code to more complex possibilities. We can use JavaScript objects to model real-world things, like a basketball, or we can use objects to build the data structures that make the web possible. At their core, JavaScript objects are containers storing related data and functionality. But that deceptively simple task is extremely powerful in practice. You've been using the power of objects all along, but now it's time to understand the mechanics of objects and start making your own. Let's go to the next lesson. Creating object literals. Objects can be assigned to variables just like any JavaScript type. We use curly braces to designate an object literal. Let spaceship equal curly braces. Spaceship is an empty object. We fill an object with unordered data. This data is organized into key-value pairs. A key is like a variable name that points to a location in memory that holds the value. A key's value can be any data type in the language, including functions or other objects. We make a key-value pair by writing the key's name or identifier, followed by a colon and then the value. We separate each key-value pair in an object literal with a comma. Keys are strings, but when we have a key that does not have any special characters in it, JavaScript allows us to omit the quotation marks. Let spaceship equal, and then it opens an object and it has fuel type as a string and diesel as a string, and then color as not a string, and silver. So you can do the string name without putting the quotation marks around it. An object literal with 2 key value pairs, let spaceship equal fuel type diesel, color silver. The spaceship object has 2 properties, fuel type and color. Fuel type has quotation marks because it contains a space character. Let's make some objects. Instructions. The spaceship we have so far looks good, but unfortunately, is not very fast at hyperspace travel due to having an inferior fuel source. Make a new spaceship object named Faster Ship with the same color as spaceship, but with a fuel type equal to turbo fuel. So it needs to be the same as the one they gave us. So here we are. Now, let's write it out with a let, I guess. And this was Faster Ship. And that will equal those open curly braces. And we have to do quotes around fuel type because there is a space between fuel and type. That's what makes that necessary. And it has to have the same color, but needs turbo fuel. Okay, so the fuel type will be turbo fuel. And we comment to the next part, which is color. So that's the next property. And the color will be the same color, which was silver. All right, let's run that. And we did it. We can move on to the next lesson. Accessing properties. There are two ways we can access an object's property. Let's explore the first way, dot notation. You've used dot notation to access the properties and methods of built-in objects and data instances. Hello.length returns 5, hello being a string, of course. With property dot notation, we write the object's name followed by the dot operator and then the property name or key. Let spaceship equal an object with home planet Earth and color silver. Spaceship.homeplanet would return Earth. Spaceship.color would return silver. If we try to access a property that does not exist on that object, undefined will be returned. Spaceship.favoriteicecream returns undefined. Let's get some more practice using dot notation on an object. Instructions. Let's use the dot operator to access the value of numCrew from the spaceship object in the code editor. Create a variable crew count and assign the spaceship's numCrew property to it. All right, let's create our variable. I'll just call it const crew. It was crew count. There it is. Const crew count was from here. It's the variable we're making. We want to set it equal to the numCrew property of spaceship. Okay, so the numCrew property of spaceship. So you want to say spaceship dot numCrew. And let's try that out. And that worked. Again, using the dot operator, create a variable planet array and assign the spaceship's flight path property to it. Okay, so const planet array will equal spaceship dot flight path. And we'll run that. Great, that's working properly. Let's move on to the next lesson. Bracket notation. The second way to access a key's value is by using bracket notation, and those are square brackets. You've used bracket notation when indexing an array. An array holding strings A, B, C at 0 would return the first value of that array, which was A. To use bracket notation to access an object's properties, we pass in the property name key as a string. Object spaceship, and then the property name in square brackets, fuel type, as a string. We must use bracket notation when accessing keys that have numbers, spaces, or special characters in them. Without bracket notation in these situations, our code would throw an error. They let spaceship and has a fuel type, which is two different words, active duty, two different words, then home planet and crew. And when they say spaceship, they open up their square brackets and put in active duty as a string. It returns true, fuel type returns turbo, numCrew returns 5, and this one, which is just exclamation points, is going to return undefined because spaceship does not have an exclamation points property. With bracket notation, you can also use the variables inside the brackets to select the keys of an object. This can be especially helpful when working with functions. Let return any prop equal, and it takes in object name and prop name, and then we have our fat arrow function. It says object name and prop name is in square brackets, and it returns any prop with spaceship and home planet, and it should return Earth in our case. If we tried to write our return any prop function with dot notation, object name dot prop name, the computer would look for the key of prop name as a string in our object and not the value of the prop name parameter. Let's get some practice using bracket notation to access properties. Instructions. Let's use bracket notation to access the value of active mission from the spaceship object in the code editor. Create a variable isActive and assign the spaceship's active mission property in it. So we want a const isActive, and that's going to equal spaceship and then square brackets, quotes, active mission. Let's try that out. Great. 2. Using bracket notation and the prop name variable provided, console.log the value of the active mission property. Okay, console.log spaceship active mission, and gotta be a space. Let's try that out. I think that's what they're asking. That is it. Great. Let's move on to the next lesson. Property assignment. Once we've defined an object, we're not stuck with all the properties we wrote. Objects are mutable, meaning we can update them after we create them. We can use either dot notation or bracket notation and the assignment operator, the equal sign, to add new key value pairs to an object or change an existing property. The object, spaceship, the property name would be fuel type or color. Then you have the assignment operator, the equal sign, and the value that you're going to assign to it, where they have the fuel type being vegetable oil as a string and the color being gold as a string. One of two things can happen with property assignment. If the property already exists on the object, whatever value it held before will be replaced with the newly assigned value. If there was no property with that name, a new property will be added to the object. It's important to know that although we can't reassign an object declared with const, we can still mutate it, meaning we can add new properties and change the properties that are there. Const spaceship equals an object with a type of shuttle. Spaceship equals type alien. Well, that will give you a type error assignment to a constant variable. Spaceship dot type equals alien changes the value of the type property. Spaceship dot speed equals Mach 5 creates a new key of speed with a value of Mach 5 as a string. You can delete a property from an object with the delete operator. Const spaceship equals, and then it opens up an object with a fuel type turbo fuel, home planet Earth, mission explore the universe. Delete spaceship.mission. That removes the mission property. Instructions. Reassign the color property of the spaceship object to have the value of glorious gold. Okay, so we saw how to do that. We have to type in spaceship, and we could either go with the dot operator, and that's what I'm going to use here because we don't need a space like we would right here or right here. So I'm going to use the dot operator to go to color, and then I'm going to assign to spaceship.color glorious gold. And let me run that. That worked. Without changing lines 1 through 6, add a numEngines property with a numeric value between 1 and 10 to the spaceship object. All right, let's do that. We're just going to make a new property here because we don't have a numEngines here. So spaceship dot numEngines, that is going to equal 10. I want the maximum amount of engines, and I don't see if they wanted the, oh no, they said numeric value, so we won't do a string, and let's run that. 3. Use the delete operator to remove the secret mission property from the spaceship object. Okay, so that was pretty straightforward. It was delete and then what you wanted to delete. So spaceship dot mission they wanted, secret mission. Oh, no dots. So we'll have to open up our square brackets because we have a space in secret mission. Secret space mission. That's funny, this is a secret space mission. And we'll run that. Great, we can move on to the next lesson. Methods. When the data stored on an object is a function, we call that a method. A property is what an object has, while a method is what an object does. Do object methods seem familiar? That's because you've been using them all along. For example, console is a global JavaScript object and .log is a method on that object. Math is also a global JavaScript object and .floor is a method on it. We can include methods in our object literals by creating ordinary, comma-separated key-value pairs. The key serves as our method's name, while the value is an anonymous function expression. Const alien ship equals, and then we have an object open, and we have a property called invade, which is a function, and it console logs, hello, we have come to dominate your planet. Instead of Earth, it shall be called new Exelon. With the new method syntax introduced in ES6, we can omit the colon in the function keyword. Const alien ship. Okay, so just invade, you won't have to have invade colon then function. You can have an invade function just like that. Okay, that is good to know. Object methods are invoked by appending the object's name with the dot operator followed by the method name and the parentheses. So alienship.invade and then invoke that function will print out the console log that was held inside of alienship in the function invade. Instructions. Below the retreat message variable in the code editor, create an alienship object. It should contain a method.retreat, which will console.log the retreat message. Let's create our alien ship. So const alien ship equals, this is going to be an object. That's the curly braces. That's what we want to put in there. And inside of there, we need a .retreat, which will console log the retreat message. So the way they did it, you could just type in retreat like so, and then do that. Let's make sure we're doing this right. See, we have invade, then we invoke, and then we open our function. And we could do our work inside of here, and it wants us to console.log the retreat message, which is up here. So I think that's what it's asking us to do, and we're going to run it and give it a shot. Yes, that's it. Add another method to your object literal. This method .takeoff should console.log the string spim borp glix blastoff. That's the sounds of the alien ship, I imagine. So let's do takeoff. And that will console.log, and I'm definitely copying and pasting this. All right, let's try that out. Oh, I did something wrong. Oh, I didn't comma between. So that's it, and then comma between. That's what was wrong there. So we need to put commas between each piece of this. So if we're kind of seeing what's going on here, we have retreat, that ends, there's a comma. We have takeoff, that ends. There's nothing after it, so we don't need a comma there, but we would comma to the next thing as well. Invoke your two methods, first retreat, and then takeoff. Okay, so we need to invoke them. So we'll just say alien ship dot retreat, and we invoke that, and then alien ship dot takeoff, and we'll invoke that. Let's try that out. Looks great. Let's move on to the next lesson. Nested objects. In application code, objects are often nested. An object might have another object as a property, which in turn could have a property that's an array of even more objects. In the spaceship object, we want a crew object. This will contain all the crew members who do important work on the craft. Each of those crew members are objects themselves. They have properties like name and degree, and they each have unique methods based on their roles. We can also nest other objects in the spaceship, such as a telescope, or nest details about the spaceship's computers inside a parent nanoelectronics object. Const spaceship, and we could see how deep we could go in here. Let's just do one of them where they say crew here. So we have a spaceship, which is an object, and then it can have telescope, which does have an object inside of it. Now we have crew. So we have crew here, so it would be spaceship.crew, and say we want to see the captain.captain, that'd give us this entire object, then .name would finally give us Sandra. Let's see their explanation. We can chain operators to access nested properties. We'll have to pay attention to which operator makes sense to use in each layer. It can be helpful to pretend you are the computer and evaluate each expression from left to right so that each operation starts to feel a little more manageable. Spaceship.nanoelectronics, square brackets, the string, backup.battery returns lithium. In the preceding code, first, the computer evaluates spaceship.nanoelectronics, which results in an object containing the backup and computer objects. We accessed the backup object by appending backup, and that was in square brackets, and it's a string. The backup object has a battery property accessed with .battery, which returned the value stored there, lithium. Instructions. Create a variable capeFav and assign the captain's favorite food, the element in the 0th index of her favorite foods array, to it. Okay, let's do that first before we keep going here. So we need to get to the captain's favorite food to the first piece of the array. So her favorite food is cookies. So we could keep this in screen here so we could still see it. And after that, we want to have a const capFav. That's going to equal the captain's favorite food. So first we go into spaceship. We're probably going to be able to dot. Let's see, a lot of them are dots. So spaceship.crew.captain. And then we have to go to favorite foods, and that needs to be in square braces because we need to do a string since there's a space. So favorite foods. And then we actually need the first one from the favorite foods. So I'm guessing we're going to put it right here to make this work. So let's run this and see what happens. Nope, that is not working. So the 0th index of the favorite food, oh, let me get this off the screen, meaning that this needs to be outside. So inside, it doesn't help, but outside of the brackets, we'll get to the 0th element. Let's run that. All right, let's move on to number 2. Right now, the passengers property has a value of null. Instead, assign as its value an array of objects. These objects should represent the spaceship's passengers as individual objects. Make at least one passenger object in the array that has at least one key value pair on it. Okay, so spaceship should have a passengers and it's null. Okay, so we're going to assign something to that. So spaceship.passengers, and then we can start assigning. Spaceship, yep, it's all undercase, dot passengers equals, and we want to assign as its value an array of objects. So here's an array, here's an object, comma, here's another object. And in these objects, they want their passengers, so they want people. So we're just gonna go name, Jim, and then name, Jane. And we could keep on making other things, their ages, stuff like that, but we need at least one key value pair, so we're just going to do one each, and we'll run it. Good to go. Number 3, create a variable first passenger and assign the first passenger as its value. The element in the 0th index of the spaceship.passengers array you just made. Make sure to use bracket and dot notation to get the passenger object through nested access. Don't just copy the object into the variable. Let's do what it says with our const first passenger equals spaceship dot, and then it was passengers. And then we want the 0th element, 0. Let's try that out, see if that's what they wanted. That works. Let's move on to the next lesson. Pass by reference. Objects are passed by reference. This means when we pass a variable assigned to an object into a function as an argument, the computer interprets the parameter name as pointing to the space in memory holding that object. As a result, functions which change object properties actually mutate the object permanently, even when the object is assigned to a const variable. Const spaceship equals object with home planet and color. Home planet's Earth, color is silver. Let paint it equal, it takes in an object, and it's a fat arrow function. It returns object.color equal to glorious gold. Paint it spaceship, spaceship.color should return glorious gold. Our function painted permanently changed the color of our spaceship object. However, reassignment of the spaceship variable wouldn't work in the same way. Let spaceship as an object, home planet Earth, color red. Let try reassignment equal object, fat arrow function, object equals, it opens a new object, identified is false, transport type is flying, console.log, object prints identified false, transport type flying. Try reassignment spaceship. The attempt at reassignment does not work. Spaceship still returns home planet Earth, color red. Spaceship equals identified false, transport type flying. Regular reassignment still works. Let's look at what happened with the code example. We declared this spaceship object with let. This allowed us to reassign it to a new object with identified and transport type properties with no problems. When we tried the same thing using a function designed to reassign the object passed into it, the reassignment didn't stick, even though calling console.log on the object produced the expected result. When we tried the same thing using a function designed to reassign the object passed into it, the reassignment didn't stick, even though calling console.log on the object produced the expected result. When we passed spaceship into that function, object became a reference to the memory location of the spaceship object, but not the spaceship variable. This is because the obj parameter of the try reassignment function is a variable in its own right. The body of try reassignment has no knowledge of the spaceship variable at all. When we did the reassignment in the body of try reassignment, the obj variable came to refer to the memory location of the object, identified false transport type flying, while the spaceship variable was completely unchanged from its earlier value. Write a function green energy that has an object as a parameter and sets the object's fuel type property to avocado oil. Okay, so I'm going to fat arrow function, so const green energy equals the fat arrow taking in an object, we'll say obj, and we need to assign the object, and not dot, but square brackets, fuel type. And that will be equal to avocado oil. And let's run that and see if we did it right. We did. Write a function remotely disable that has an object as a parameter and sets or reassigns the object's disabled property to true. Okay, so const remotely disable fat arrow function, and it should also take in an object again. So we'll take in the object, and we will object, and then the property was disabled, so let's just dot disabled equals true. Let's run that. That looks good. Call your two functions with the spaceship object in the code editor, then console.log the spaceship object to confirm those properties were changed/added. So we need to call these two functions. So we need to say green energy, and then we pass in spaceship. And we also need our remotely disable spaceship. And those are both functions like so. And then they want us to console.log spaceship so we can see what happens. And let's give that a go. We can see that the fuel type was changed to avocado oil, and remotely disabled is now true. Great, let's move on to the next lesson. Looping through objects. Loops are programming tools that repeat a block of code until a condition is met. We learned how to iterate through arrays using their numerical indexing, but the key value pairs in an object aren't ordered. JavaScript has given us alternative solution for iterating through objects with the for in syntax. For in will execute a given block of code for each property in an object. Let spaceship and then the entire spaceship value, and we see there's a lot in here, and we want to focus on the for in part of it. So for let crew member in spaceship.crew. The console.log, they are string interpolating crew member, and then string interpolating spaceship.crew, crew member in square brackets .name. So they're going to console.log all of their names. Our for in will iterate through each element of the spaceship.crew object. In each iteration, the variable crew member is set to one of spaceship.crew's keys, enabling us to log a list of crew members' roles and name. Instructions. Using for in, iterate through the spaceship.crew object in the code editor and console.log a list of crew roles and names in the following format: crew member's role, crew member's name. Example, Chief Officer Dan. Okay, so we have spaceship.crew, and then the crew is labeled with their roles. So Captain, Medic, Translator, and they each have names in the object, which they hold their name, degree, and some other stuff to announce function here. So let's get started. Let's let role in spaceship.crew and console.log what we need to do here. So what we'll want to do first is our backtick. So we could do string interpolation, and the first string we want to do string interpolation on is role, because that'll be medic, translator, captain. That'll be the role, and we need our colon, and we need our next piece, which is going to be more than just pulling off of role. We're going to go to spaceship.crew. And then we have to pass in role and .name. So spaceship.crew, and then we'd get medic.name should bring up that. Let's see if we're right. That works, great. Captain Lily, Chief Officer Dan, medic Clementine, and translator Shauna. Using for-in, iterate through the spaceship.crew object in the code editor and console.log a list of the crew's names and degrees in the following format. Crew member name, crew member's degree, i.e. Lily, computer engineering. Okay, we could do that as well. We saw how we get to the name, and we want to do the entire crew. So we have to do it the same way. So we're going to do spaceship.crew again for let role in spaceship.crew and console.log and get our backticks up. And we need the crew member's name. We know how to do that. That's this entire thing here. So just put your $sign, get that in there. That gets to the crew member's name. What do they want after it? They want a colon, a space, and then we could start crew member's degree. So it's going to be the same type of thing, spaceship.crew, then the role, then .degree. Take a look, make sure I did these the same. Yeah, that's looking pretty good. Let's give it a run. Let's go to the next lesson. Review. Way to go. You're well on your way to understanding the mechanics of objects in JavaScript. By building your own objects, you will have a better understanding of how JavaScript's built-in objects work as well. You can also start imagining organizing your code into objects and modeling real-world things in code. Let's review what we learned in this lesson. Objects store collections of key-value pairs. Each key-value pair is a property. When a property is a function, it is known as a method. An object literal is composed of comma-separated key-value pairs surrounded by curly braces. You can access, add, or edit a property within an object by using dot notation or bracket notation. We can add methods to our object literals using key-value syntax with anonymous function expressions as values or by using the new ES6 method syntax. We can navigate complex nested objects by chaining operators. Objects are mutable. We can change their properties even when they're declared with const. Objects are passed by reference. When we make changes to an object passed into a function, those changes are permanent. We can iterate through objects using the for-in syntax. Let's see what's up next. Advanced objects. Advanced objects. Advanced objects introduction. Remember, objects in JavaScript are containers that store data and functionality. In this lesson, we will build upon the fundamentals of creating objects and explore some advanced concepts. So if there are no objections, let's learn more about objects. In this lesson, we will cover these topics. How to use the this keyword, conveying privacy in JavaScript methods, defining getters and setters in objects, creating factory functions, Using destructuring techniques. Instructions. Look over the code in main.js to see examples of the object-related concept covered in this lesson. Then click Next to get started on learning these concepts. Okay, so we see a bunch of objects here. We see an object, a function object here. It's taking in some variables. We see another object here with this in front of it, this underscores in front of name, robot capacity, and so on. And we have set robot capacity, new capacity. Okay, so there's the function here. This looks to be another function here. If type of new capacity is number. Okay, so we're going to learn a little bit about this as well, this get and set here. All right, let's go to the next lesson. The this keyword. Objects are collections of related data and functionality. We store that functionality in methods on our objects. Const goat equals, and it opens up an object with diet type being a string of herbivore and make sound being a console.log of ba. So the make sound is a method within the goat object. In our goat object, we have a makeSound method. We can invoke the makeSound method on goat. It would be like this, goat.makeSound, invoke it, and that will print BAAA. Nice. We have a goat object that can print ba to the console. Everything seems to be working fine. What if we wanted to add a new method to our goat object called .diet that prints the goat's diet type? Const goat, and it opens up an object. Diet type is herbivore. It has the makeSound method, and now we have a diet method which console.logs diet type. And we're doing goat.diet, so we're getting the diet method, and the output will be a reference error. Diet type is not defined. That's strange. Why is diet type not defined even though it's a property of goat? That's because inside the scope of the diet method, we don't automatically have access to other properties of the goat object. Here's where the this keyword comes to the rescue. If we change the diet method to use the this, the diet works. So the const goat object, and we see the difference is in the diet method, we're console.logging this.diet type, and when we invoke that method, the output will be herbivore. The this keyword references the calling object, which provides access to the calling object's properties. In the example above, the calling object is goat, and by using this, we're accessing the goat object itself, and then the diet type property of goat by using property.notation. Let's get comfortable using the this keyword in a method. Instructions. Let's create a new object to practice using this. In main.js, there is an object robot. Add a property of model and assign to it a value of a string with 1E78V2. Add another property, energy level, and assign the value of 100. So we need robot, and there already is an object robot, so we just need to add these properties, which is model, and we know that is that string here. I'm going to just copy it, paste it in, and we also have a property called energy level, and that will be 100. Let's run that. That worked. Let's head down to the next one. Inside the robot object, add a method named provideInfo. Inside the body of provideInfo, return the following string by using interpolation. I am model, and my current energy level is energy level. Replace model and energy level with the calling object's model and energy level property. Remember, to get the access to the calling object's properties inside a method, you have to use the this keyword. So now we need to make a method. So we'll make a method called provideInfo. And inside provideInfo, we need to return the following string. So let's return, and we could just, let me put it in parentheses, and here's the string that we need to return. We'll use backticks for string interpolation, and we I am, and then model has to be the backticks. Open that up, and this dot model. We'll do a space, and my current energy level is another string interpolator here. It'll be this dot energy level. And let's see if this is working. Let's run that. That did work. Now to check .provideInfo has access to the internal properties of robot. Log the result of calling provideInfo method on robot to the console. That's written a little poorly, but it wants us to invoke the .provideInfo method and log it to the console. So outside of this, we will console.log, and then we will invoke the method, which was robot.provideInfo, and invoke it. And let's run that. That looks right. I am, and that's the model number, and my current energy level is 100, which is right there. Perfect. Arrow functions and this. We saw in the previous exercise that for a method, the calling object is the object the method belongs to. If we use the this keyword in a method, then the value of this is the calling object. However, it becomes a bit more complicated when we start using arrow functions for methods. Take a look at the example below. We have the const goat object, and we have a arrow function in there where diet is. And it's console.logging this.diet type, and when we invoke that, it actually prints undefined. In the comment, you can see that goat.diet would log undefined. So what happened? Notice that the .diet method is defined using an arrow function. Arrow functions inherently bind or tie an already defined this value to the function itself that is not the calling object. In the code snippet above, the value of this is the global object, or an object that exists in the global scope, which doesn't have a diet type property and therefore returns undefined. To read more about either arrow functions or the global object, check out the MDN documentation of the global object and arrow functions. The key takeaway from the example above is to avoid using arrow functions when using this in a method. Instructions. Currently, the checkEnergy method is not producing the correct output because it is using arrow function syntax. Refactor or change the method to use a function expression. You can write the function using either longhand or shorthand format. After refactoring the method, notice that checkEnergy has access to the other internal properties of the robot object. So we just need to change the syntax. We see we have checkEnergy, and it's pointing to this anonymous arrow function. We want checkEnergy to be a function, and we don't need an arrow, so now we have a method, and I think that's what they were asking for. Let's run it. That works. Let's move to the next lesson. Privacy. Accessing and updating properties is fundamental in working with objects. However, there are cases in which we don't want other code simply accessing and updating an object's properties. When discussing privacy in objects, we define it as the idea that only certain properties should be mutable or able to change in value. Certain languages have privacy built in for objects, but JavaScript does not have this feature. Rather, JavaScript developers follow naming conventions that signal to other developers how to interact with a property. One common convention is to place an underscore before the name of a property to mean that the property should not be altered. Here's an example of using underscore to prepend a property. Const bank account equals an object, and there's an underscore before the word amount, and it's 1,000. In the example above, the underscore amount is not intended to be directly manipulated. Even so, it is possible to reassign underscore amount. Bank account dot underscore amount equals, and then you could reassign whatever value you would like. In later exercises, we'll cover the use of methods called getters and setters. Both methods are used to respect the intention of properties prepended or began with the underscore. Getters can return the value of internal properties, and setters can safely reassign property values. For now, let's see what happens if we can change properties that don't have setters or getters. Instructions. Below the robot object, reassign the underscore energy level property to high. So below robot, that ends here, we will redefine robot dot underscore energy level equals high. And let's run that. That works. Now take a look at the new recharge method in robot. Recharge will add 30 to underscore energy level. What will happen now that energy level isn't a number? Call recharge on robot to find out. Let's do that here. Robot.recharge, and we will invoke that function. Let's run it. Recharge energy is currently at high 30%. Notice that a funky string is printed to the console. This is known as a side effect of type coercion. No need to worry about what this means for now, but it's important to understand that you can cause unwanted side effects when mutating objects and their properties. And we can move to the next lesson. Getters. Getters are methods that get and return the internal properties of an object, but they can do more than just retrieve the value of a property. Let's take a look at a getter method. We have a const person, and it's an object, and there is a get inside there. So get full name as a function, it opens up, and we have an if statement in there returning this dot first name and this dot last name. And when you print the full name here, it says John Doe, which is the first name and last name. Let me leave this in. Notice that in the getter method above, we use the get keyword followed by a function. We use an if-else condition to check if both first name and last name exist by making sure they both return truthy values, and then return a different value depending on the result. We can access the calling object's internal properties using this. In full name, we're accessing both this dot first name and this dot last name. In the last line, we call full name on person. In general, getter methods do not need to be called with a set of parentheses. Syntactically, it looks like we're accessing a property. Now that we've gone over syntax, let's discuss some notable advantages of using getter methods. Getters can perform an action on the data when getting a property. Getters can return different values using conditionals. In a getter, we can access the properties of the calling object using this. The functionality of our code is easier for the developers to understand. Another thing to keep in mind when using getters and setter methods is that properties cannot share the setter name as the getter-setter function. If we do so, then calling the method will result in an infinite call stack error. One workaround is to add an underscore before the property name like we did in the example above. Great, let's go getter. Instructions. In robot, create a getter method named energy level using the get keyword. Leave function body blank for now. Let's see exactly how they did it. I know we used get and then the function. That's all that's going to happen. It's just the get keyword. So get, and the function they want is called energy level as a function, and all it'll do now is have a blank body. Let's run that and see if we did it properly. We did. Inside the getter method, add an if statement to check if this.energyLevel is a number using the typeOf operator. If that condition is truthy, return my current energy level is energy level. Replace energy level with the value of this.energy level. Make sure you return the string and not logging it to the console. Make sure you are returning the string and not logging it to the console is what they mean there. So we'll start with our if statement in the body here. It wants us to if this.energy level is a number. So they want us to use the typeOf operator, and then this._energy level, camel case, is triple equal to number as a string is what should return from there. So let's take a look if we did that right, and what else is here. If that condition is truthy, okay, so return my current energy level is energy level and replace the energy level. So we want to return a string, and we'll return with backticks, so we could do string interpolation there. My current energy level is, and then we want the energy level interpolated this._energy level. And let's see if that's working. Great, that looks right. And let's move on to the next one. If this.energy level isn't a number, it could be that the energy level property was altered. Let's add a default return statement for when such a scenario arises. Add an else statement that returns system malfunction, cannot retrieve energy level. Okay, so we have our if. The if statement ends here. We write else, and we return. And I'm just going to copy this string right in there. And let's run it. That works. Log the result of calling the getter method energy level on robot to the console. Notice that the method will return a formatted response rather than accessing a property. All right, so when they call the getter, let's make sure there's nothing to it here. Yep, it's just the same as it used to be. It just has get in front of it. It has a keyword in front. So we're just going to do robot.energy level. I'll head back down. Log the result of calling it. So console.log. And then we have robot.energy level. And we need to invoke that. Let's give that a shot. Oh, I see. See, after full name, you don't have to invoke the function on the getter method. Okay, let's get rid of that and run again. That's it. So when it says get, we will not invoke those functions. That's what get will do for us. All right, next lesson. Setters. Along with getter methods, we can also create setter methods, which reassign values of existing properties within an object. Let's see an example of a setter method. We have const person, and it opens an object, and inside of there is set. It's set age. It takes in new age, and in there is an if statement. If new age, if type of new age is triple equal to number. This.age equals new age, so that updates the age. If it's not equal to a number, it's going to console.log. You must assign a number to age. Notice that in the example above, we can perform a check for what value is being assigned to this.age. When we use the setter method, only values that are numbers will reassign this.age. There are different outputs depending on what values are used to reassign this.age. Then to use the setter method. Person.age equals 40. Console.log person._age logs 40. Person.age equals a string saying 40. The console.log will say you must assign a number to age. Setter methods like age do not need to be called with a set of parentheses. Syntactically, it looks like we're reassigning the value of a property. Like getter methods, there are similar advantages to using setter methods that include checking input, performing actions on properties, and displaying a clear intention for how the object is supposed to be used. Nonetheless, even with setter methods, it is still possible to directly reassign properties. For example, in the example above, we can still set ._age directly. Person._age equals a string saying 45. Console.log person._age will print 45. Instructions. Currently, in Robot, there is a getter method for num of sensors, but no setter method. What if we need to add or remove some sensors? Let's fix that problem. Add a setter method named num of sensors using the set keyword. Provide a parameter of num, leave the function body empty for now. All right, so let's start on that. Here's our getter method. Let's get past that. Right here is where we'll do our set method, and it wanted to set num of sensors. The parameter in here is num, and let's run it. Great. There are a couple of things we should do in the setter method. Add a check to see if num is a number using the type of operator. Num should also be greater than or equal to 0. If both conditions are met, reassign this num of sensors to num. Okay, so we have some conditions we need to work with, and we have an add a check to see if num is a number. So we do that first. If type of num triple equals a string undercase number, that will come back as true. Num should also be greater than or equal to 0. Okay, so we're going to do double ampersand, and then num greater than or equal to 0. So if those two things are met in our if statement, we want to reassign this ._num of sensors, and that'll just be set equal to num, and that will update our num of sensors. Let's run that, make sure that's right. It is. Now add an else that logs pass in a number that is greater than or equal to 0 to the console. So we have our if statement that ends right here. We'll say else, and in that block we will return, are we returning or console logging? No, it logs. So console.log. We don't need to do string interpolation here, so just regular quotes is fine. I'm going to copy it in and run that. Great, that's working too. Let's use the num of sensors setter method on robot to assign num of sensors to 100. Okay, so we want to use the setter method. Let's see how they've used it before. We see here a set age. So person.age and then just equal to whatever we want it to be equal to. Okay, let's do that. This would be robot dot num of sensors is equal to 100 is what they want there. Let's run that and see if we did that right. We did. To check that the setter method worked, console.log robot.num of sensors. Okay, so after that, I will console.log robot.num of sensors. And we see we have 100 sensors on that robot now. So we'll go to the next lesson. Factory functions. So far, we've been creating objects individually, but there are times where we want to create many instances of an object quickly. Here's where factory functions come in. A real-world factory manufactures multiple copies of an item quickly and on a massive scale. A factory function is a function that returns an object and can be reused to make multiple object instances. Factory functions can also have parameters, allowing us to customize the object that gets returned. Let's say we wanted to create an object to represent monsters in JavaScript. There are many different types of monsters, and we could go about making each monster individually, but we can also use a factory function to make our lives easier. To achieve this diabolical plan of creating multiple monsters objects, we can use a factory function that has parameters. Const monster equals, and here are the parameters, name, age, energy source, catchphrase. It's a fat arrow function, and then there is the body of it, and it returns an object with the name being name, age, energy source is energy source, and a method called scare that console.logs the catchphrase. In the monster factory function above, it has 4 parameters and returns an object that has the properties name, age, energy source, and the scare method. To make an object that represents a specific monster like a ghost, we can call monster factory with the necessary arguments and assign the return value to a variable. Const ghost equals monster factory, ghoulie 251, ectoplasm, boo. And then ghost.scare, calling that method from ghost, will return boo. Now we have a ghost object as a result of calling monster factory with the needed arguments. With monster factory in place, we don't have to create an object literal every time we need a new monster. Instead, we can invoke the monster factory function with the necessary arguments to take over the world or make a monster for us. Instructions. Instead of making individual robots like we've been doing, let's make a factory function to make robots as we please. Create a factory function named robot factory that has 2 parameters, model and mobile. Let's create a factory function first. So const robot factory, and it's going to take in 2 parameters, that's model and mobile, and then fat arrow function to the body. Make the function return an object. In the object, add a key of model with the value of the model parameter. Add another property that has the key of mobile with the value of the mobile parameter. So we'll start with that. So we're going to return an object, and inside that object, we're going to have a model. The key will be model, and we're going to return the model we're getting as the argument up here, and then mobile, and we'll have the mobile that we're getting as the argument up here. And what's next here? Then add a method named beep without a parameter that will log beep beep to the console. Okay, so we will have a method here. It'll be called beep. It doesn't take a parameter. It just console.logs beep boop. And let's see if we did that all right. That's right, great. Use your factory function by declaring a const variable named tinCan. Assign to tinCan the value of calling robot factory with the first argument of P500 and the second argument of true. Okay, so we will have a const named tinCan, and that's equal to robot factory, and we're going to pass in this right here, that's P500, and then the Boolean value true. And let's run that. That worked. Let's now check what tinCan can do. Call .beep on tinCan. Okay, so under this, tinCan.beep. And let's run that. beep boop is printed to the console. You should see beep boop printed to the console, which means the factory function produced a robot object. Play around with tin can and check for other properties. We sure could do every single one of these. So let's just do one more. Tin can dot model, and I'll console log that. So console dot log tin can model. Run that. We see it's the P500. Let's go to the next lesson. Property value shorthand. ES6 introduced some new shortcuts for assigning properties to variables known as destructuring. In the previous exercise, we created a factory function that helped us create objects. We had to assign each property a key and value, even though the key name was the same as the parameter name we assigned to it. To remind ourselves, here's the truncated version of the factory function. So there's the const monster factory. It takes in name and age, and it returns an object with name being name and age being age. Imagine if we had to include more properties, that process would quickly become tedious. But we can use a destructuring technique called property value shorthand to save ourselves some keystrokes. The example below works exactly like the example above. Const monster factory takes in name and age, and it returns name, age. There's no longer name being name and age being age. Notice that we don't have to repeat ourselves for property assignments. Instructions: use the property value shorthand and refactor the factory function in main.js. Okay, well that should be pretty simple. We need to get this out of here and this out of here. We just have, just like they did, model mobile, just like they had name age. This would still have to do what it's doing, I imagine, so let's run this. There it is. We'll move on to the next lesson. Destructured assignment. We often want to extract key value pairs from objects and save them as variables. Take, for example, the following object. Const vampire equals, and it opens up an object and has a name of Dracula, residence, Transylvania, preferences is an object itself. It has, during the day, it wants to stay inside. During the night, its preference is to satisfy its appetite. If we wanted to extract the residence property as a variable, we could using the following code. Const residence equals vampire.residence. Console.log residence prints Transylvania. However, we can also take advantage of a destructuring technique called destructured assignment to save ourselves some keystrokes. In destructured assignment, we create a variable with the name of the object's key that is wrapped in curly braces and assign to it the object. Take a look at the example below. Const residence, that's in curly braces, equals vampire. Console.log residence, that prints Transylvania. Look back at the vampire objects property in the first code example. Then in the example above, we declare a new variable residence that extracts the value of the residence property of vampire. When we log the value of residence to the console, Transylvania is printed. We can even use destructured assignment to grab nested properties of an object. Const day, and that's within curly braces, equals vampire.preferences, console.log day will print stay inside. Instructions. Use destructured assignment to create a const variable named functionality that extracts the functionality property of robot. If you need a reminder on how to use destructured assignment, review the example in the narrative or check the hint. Okay, so we want a const variable named functionality, so const functionality, that will equal the functionality property of robot. So a robot dot functionality. Oh, we don't need to do that. So we're going to destructure it off of that. So functionality is at the first level, right here. if we were where they were in that last one, we need to go a little further, like vampire dot preferences to get to day because of this. Vampire dot preferences, and then there's day. So what we want is on the first level here. It's robot dot functionality. So we can just destructure it by taking functionality and putting these curly braces around it. Let's run that and see if it works. Yes, it worked. All right, number 2. Since functionality is referencing robot.functionality, we can call the methods available to robot.functionality simply through functionality. Take advantage of this shortcut and call the .beep method on functionality. Okay, functionality has a .beep method, so functionality .beep, and we'll run that. And it says up here, beep boop, which means it worked. Let's move on to the next lesson. Built-in object methods. In the previous exercises, we've been creating instances of objects that have their own methods, but we can also take advantage of built-in methods for objects. For example, we have access to object instance methods like .hasOwnProperty, .valueOf, and many more. Practice your documentation reading skills and check out MDN's object instance documentation. There are also useful object class methods such as object.assign, object.entries, and object.keys, just to name a few. For a comprehensive list, browse MDN's object instance documentation. Let's get acquainted with some of these methods in their documentation. Note, you will see errors as you work through this exercise, but by the end, the errors will be fixed. Instructions. In main.js, there is an object, robot. We'd like to grab the property names, otherwise known as keys, and save the keys in an array which is assigned to robot keys. However, there's something missing in the method call. Find out what we have to include by reading MDN's object.keys documentation. Okay, first let's see exactly where they're saying this. There's an object called robot. We'd like to grab the property names. Okay, so object.keys, that's right here, and something is missing from object.keys. Let's take a look at what that is. Okay, object.keys, and then we have to pass the object in. Okay, let's head back and pass in the object we want, which is called robot, and run that. That works. And like it said, you're going to have a lot of errors in here, but that's what they wanted. Let's go to number 2. Object.entries will also return an array, but the array will contain more arrays that have both the key and value of the properties in an object. Declare a const variable named robot_entries and assign to it the entries of robot by calling object.entries. Find out how to use object.entries on the MDN documentation. Okay, so the next thing we want to do is declare a const named robot_entries. Oh, declare robot_entries below this line. So const robot_entries. All right, so we have that, and we want to set it equal to object.entries. So let's see how object.entries works. Let's see what we have here. This isn't displaying very well, and they put object.entries in a for loop. That's not really how we want to demo this. Let's see if they have more examples. Yeah, here are all the examples. Okay, so they have a const object equal to an object with foo being bar and baz being 42. Console.log object.entries, and then you pass in the object. It makes an array of arrays with the corresponding key value pairs. Okay, so that's what it's going to do if we pass in an object. And we just need to assign it to the entries of robot. So we're going to have robot here. Okay, so object.entries, and we're going to pass in robot and run that. that worked, and we could see that we have these key value pair arrays now being model and sal. So the array at 0 and then at 0 again would be model, and the array at 0, 1 would be sal 1000. Let's go to number 3. Now, what if we want another object that has the properties of robot, but with a few additional properties? Object.assign sounds like a great method to use, but like the previous examples, we should check object.assign documentation at MDN. Declare a const variable named newRobot. NewRobot will be a new object that has all the properties of robot, and the properties in the following object: laser blaster, true; voice recognition, true. Make sure that you are not changing the robot object. Okay, so it wants us to use object.assign. Let's set this up first. And so new robot, that's this. So const new robot equals object.assign. And then let's see what we need to do here in the documentation. Yes, okay, so yeah, this looks like it'll take in 2 different objects. The first object is the object that we're going to assign the second object to, but if they share, say, this B here, it will be overwritten. So this has B4, and the B that's in there was replaced by it. It kept its A1, it replaced its B4, and it added C5. So object.assign, we have our target. So that's where we want to add the new assignment to, and then we need a object actually put in there. Let's do it. So object.assign. The first thing we'll need is robot. And the second thing we need is an object with everything that we want to put in there, which is this. And we could define this somewhere else, but this should work just fine too. And let's just run it, see if we did it right. All right, so the robot object should not be changed, and we saw, yeah, it says that right here. So I missed that. Okay, so it can't be changed. So I no longer want to have robot here because I don't want robot to change. So we're actually morphing this up here. That's what we don't want to be doing. I'm just going to put an object in there. And we will assign robot, comma, and then this object as well to new robot, and in there should be all of that. Let's see if that works. That does work. Okay, great. So the difference was when I put robot here, it was assigning things to robot. We want a new robot with a copy of robot in it, plus these new features. So we gave an empty object here to be filled with robot and this as well. So that worked great. Let's move on to our next lesson. Review. Congratulations on finishing advanced objects. Let's review the concepts covered in this lesson. The object that a method belongs to is called the calling object. The this keyword refers the calling object and can be used to access properties of the calling object. This keyword refers to the calling object. Methods do not automatically have access to other internal properties of the calling object. The value of this depends on where the this is being accessed from. We cannot use arrow functions as methods if we want to access other internal properties. JavaScript objects do not have built-in privacy. Rather, there are conventions to follow to notify other developers about the intent of the code. The usage of an underscore before a property name means that the original developer did not intend for that property to be directly changed. Setters and getter methods allow for more detailed ways of accessing and assigning properties. Factory functions allow us to create object instances quickly and repeatedly. There are different ways to use object destructuring. One way is the property value shorthand, and another is destructured assignment. As with any concept, it is good to learn how to use documentation with objects. You are ready to start leveraging more elegant code for creating and accessing objects in your code. And this lesson is all finished. You could do some extra work here if you'd like, and I'm going to see what is up next. And up next, classes. Introduction to classes. JavaScript is an object-oriented programming OOP language we can use to model real-world items. In this lesson, you will learn how to make classes. Classes are a tool that developers use to quickly produce similar objects. Take, for example, an object representing a dog named Haley. The dog's name, a key, is Haley, a value, and has an age, another key, of 3, another value. We create the Haley object below. Let Haley. So Haley is equaling an object, and the object has name Haley, behavior 0, get name is a get on a method that returns this dot name. Get behavior is a get on a method that returns this dot behavior. Increment behavior is a method with no get or set, anything like that. That's just this dot behavior plus plus. Now imagine you own a dog daycare and want to create a catalog of all the dogs who belong to the daycare. Instead of using the syntax above for every dog that joins the daycare, we can create a dog class that serves as a template for creating new dog objects. For each new dog, you can provide a value for their name. As you can see, classes are a great way to reduce duplicate code and debugging time. After we lay the foundation for classes in the first few exercises, we will introduce inheritance and static methods, two features that will make your code more efficient and meaningful. Instructions. In the next exercise, you will learn about classes in greater detail. Before you do, take a moment to study the class in main.js. Spend some time identifying the similarities and differences between the dog class in main.js and the code we use to create our Haley object in the instructions above. So we have a class, dog, and it looks like it opens up an object, but of course it's opening up a class. There is a constructor in the dog class. The constructor takes name, and this dot name is equal to that name, and this dot behavior is going to be set to 0. There is a getName method in this class that returns this dot name. There's a getBehavior method that returns this dot behavior. There's an increment behavior method that returns, it doesn't return, it just goes to this dot behavior and increments it upwards, this dot behavior plus plus. Let's just click run, and then we could keep moving. Yes, it can. Okay. 2. Copy the class instantiation method call and console.log statements below into main.js. Okay, so we need to copy all of this. Let's just copy it. And below the dog class, so after everything's done, we'll paste this in, and let's run this and see what happens. Okay, so we have a new const. Haley is a new dog, so it inherits everything from here. We're going to console.log haley.name, so we know haley.name is going to be the name that was passed in, which is Haley here, and that's what comes up. Console.log haley.behavior, we know that that is equal to 0, and nothing is passed in for it, so it should be 0. That is 0. The next is haley.increment behavior. That adds 1 to behavior, and it doesn't print it, so let's move on from there. Console.log haley.name, and it prints Haley again. I wonder why that's there twice. And then we'll console.log haley.behavior, and now that's at 1 because we incremented it before we checked the name yet again. And that's how that's working. Let's go to the next lesson. Constructor. In the last exercise, you created a class called dog and used it to produce a dog object. Although you may see similarities between class and object syntax, there is one important method that sets them apart. It's called the constructor method. JavaScript calls the constructor method every time it creates a new instance of a class. Class dog opens up an object, and constructor name, and it just shows us what we had in the last one, where the name is going to be this.name and this.behavior is going to be 0. Dog is the name of our class. By convention, we capitalize and camel case class names. JavaScript will invoke the constructor method every time we create a new instance of our dog class. This constructor method accepts one argument, name. Inside of the constructor method, we use the this keyword. In the context of a class, this refers to an instance of that class. In the dog class, we use this to set the value of the dog instance's name property to the name argument. Under this.name, we created a property called behavior, which will keep track of the number of times the dog misbehaves. The behavior property is always initialized to 0. In the next exercise, you will learn how to create dog instances. Instructions. Create an empty class named surgeon. All right, so class, the word surgeon, and that's capitalized like they said. You should capitalize these, and we just open up that object there. Let's run that. Inside of the surgeon class, create a constructor method that accepts two parameters, name and department. So we need a constructor here, and let's look back at it before we do it so we can see exactly how they did it. So the constructor works just like a method. We're going to pass it name, it's going to set the name, and it's going to initialize behavior as well. I'm not sure ours does that, but that's what a constructor looks like. So let's do that. We will write constructor, and we will give it name. We do need to give it name, and we also need to give it department. And that's it so far, so let's just run that. Inside the surgeon constructor, create name and department properties and set them equal to the input parameters. So here we'd be saying this.name equals name, and this dot, what was it, department, right? Department equals department. And I imagine we comma between them. No, we make them separate statements. So we end them with semicolons. Cool. And let's run that. Great, that works perfectly. This is our surgeon constructor. Let's move to the next lesson. Instance. Now we're ready to create class instances. An instance is an object that contains the property names and methods of a class, but with unique property values. Let's look at our dog class example. Class dog has a constructor that has name, this.name is name, this.behavior initializes to 0. Now, below that is the const Haley equals new dog, capital dog, and it passes in Haley as a string, which creates a new dog instance. So we console.log Haley.name, and that should log the name value saved to Haley, which outputs Haley. Below our dog class, we use the new keyword to create an instance of our dog class. Let's consider the line of code step by step. We create a new variable named Haley that will store an instance of our dog class. We use the new keyword to generate a new instance of the dog class. The new keyword calls the constructor, runs the code inside of it, and then returns the new instance. We pass the Haley string to the dog constructor, which sets the name property to Haley. Finally, we log the value saved to the name key in our Haley object, which logs Haley to the console. Now you know how to create instances. In the next exercise, you will learn how to add getters, setters, and methods. Instructions. Create an instance of the surgeon class. Set the name to curry and department to cardiovascular. Save the instance to a constant variable called surgeon curry. Okay, so we're going to have a const called surgeon curry. It's going to equal the new keyword, the class we're calling it from. So we need a new surgeon, and we want to pass in curry for the name, which is the first piece. And we want to pass in cardiovascular for the department. And that should do it. Save the instance because okay, let's try running that. That did work. Create an instance of the surgeon class, set the name to Durant and department to orthopedics. Save the instance to a constant variable called surgeon Durant. Okay, so now we're going to make surgeon Durant. So const surgeon Durant, that's a new surgeon. And we have to give him the name of Durant and the department of orthopedics. Save the instance. Okay, so let's run that, see if that's working. And that does work. Let's move on to the next lesson. Methods. At this point, we have a dog class that spins up objects with name and behavior properties. Below, we will add getters and a method to bring our class to life. Class method and getter syntax is the same as it is for objects, except you can not include commas between methods. That's something we learned before. These all end instead of commas with semicolons. So we have the class dog and we've seen the constructor. Now we're going to make a get name method. So it's going to be a get on a name method and that returns this.name. And then we'll have a get on a behavior method that returns this.behavior. And we have increment behavior method. There is no get or anything like that, but this.behavior plus plus. It increments it upward by 1 every time that it's called. In the example above, we add getter methods for name and behavior. Notice we also prepend our property names with underscores, name and behavior, which indicates these properties should not be accessed directly. Under the getters, we add a method named increment behavior. When you call increment behavior on a dog instance, it adds 1 to the behavior property. Between each of our methods, we did not include commas. Instructions. In the surgeon constructor, prepend the name and department properties with an underscore. Okay, so this underscore name, this underscore department, and we'll run that. That worked. So inside the constructor, add a property named remaining vacation days and set it equal to 20. Okay, so we have this dot, and it's pretty long. I don't want to make a typo, so I'm just going to copy it over. Remaining vacation days with an underscore in front of it, and it needs to be equal to the number 20. Let's run that. And we really should put our semicolons here as well, but that did work. Under the constructor, create a getter called name that returns the value saved to name. Okay, so under the constructor, here's where the constructor ends, and then we're going to have get name, and that is going to return the value saved in name. So return this dot underscore name. That should work. Let's see. That did work. Great. Under the name getter, create a getter called department that returns the value saved to department. Okay, so we have getter. It's going to be the same thing. So we have to change this to department. And that ought to work too. And I'm going to put in my semicolons just to get this in my memory that these can't have commas, they have semicolons. Run that. Great. Under the department getter, create a getter called remaining vacation days that returns the value saved to remaining vacation days. Okay, so we need a remaining vacation days getter. Let's do that. Instead of department, it's going to be remaining vacation days. Okay, let's try that. That worked. Under the remaining vacation days getter, create a method called takeVacationDays that accepts one argument named days off. Okay, let's do that first. So here's where it ends. And we want to make a get vacation. Oh no, it's called takeVacationDays. There it is. So we have takeVacationDays, and it's not going to have a getter. It says under the getter. So we're just having a method. And inside this method, we're going to subtract days off from the number saved to remaining vacation days. Then we'll set remaining vacation days to the result. Okay, so we have this. It's going to take in days off, and O has to be capitalized. And in the body, we're going to have to take this. So it'll be this dot remaining vacation days equals, and it would be this dot underscore remaining vacation days. Oh, I have two underscores. Minus days off. That looks like it should work. Let's give it a shot. And it does. All right, great. If you can't see this code well, maybe we could open this up for a sec. Okay, so this is what's happening. I know the equals kind of went to the next line, but this dot remaining vacation days is up here in remaining vacation days, and that's where we get it from this. And now we have to set it what it already is minus the amount of days off that were taken. So we're calling it again and making it equal to itself minus the days off that were taken. Let's go to the next lesson. Method calls. Finally, let's use our new methods to access and manipulate data from dog instances. Class dog, and it has the constructor, the getName, getBehavior, and increment behavior, and const Haley is equal to a new dog. In the above example, recreate the dog class, then create an instance and save it to a variable named Haley. The syntax for calling methods and getters on an instance is the same for calling them on an object. Append the instance with a period, then the property or method name. For methods, you must also include opening and closing parentheses. Let's take a moment to create two dog instances and call our .incrementBehavior method on one of them. Okay, so we'll have two dog instances. Let's take a look. There's letNico, and that's a new dog named Nico, and Nico.incrementBehavior, that will add 1 to Nico's behavior instance. Let Bradford equal new dog Bradford, console.log Nico.behavior, that should log 1, console.log Bradford.behavior, that should log 0. In the example above, we create two new dog instances, Nico and Bradford. Because we increment the behavior of our Nico instance but not Bradford, accessing Nico.behavior returns 1 and accessing Bradford.behavior returns 0 in instructions. At the bottom of main.js, use console.log to print the value saved to the name property of the Surgeon Curry object. So we'll console.log the name of Surgeon Curry. Okay, console.log Surgeon Curry dot name. Let's see what happens. Curry is the name. Call takeVacationDays on Surgeon Curry with an input of 3. Okay, so we will say Surgeon Curry dot takeVacationDays and pass in 3 there. All right, let's try that out. That did work. After you call to takeVacationDays, use console.log to print the value saved to the remaining vacation days property of the Sergeant Curry instance. So we want to see the remaining vacation days property now. So we just did the console.log name. We know how to do that. We will console.log again, Surgeon Curry, but not name this time. We want remaining vacation days, which is right here. I'm just going to paste that on in. Let's give that a shot. Nope, that is wrong. Did you call the remaining vacation days value from the search and query instance? I have remaining vacation days with an underscore in front of it. Maybe not the underscore. Let's try that. That's what they wanted. They didn't want the underscore. They actually wanted us to get the remaining vacation days from this get here, remaining vacation days, that returns this dot remaining vacation days. And that's what we're able to console log there at 17. Great, let's go to the next lesson. Inheritance 1. Imagine our doggy daycare is so successful that we decide to expand the business and open a kitty daycare. Before the daycare opens, we need to create a cat class so we can quickly generate cat instances. We know that the properties of our cat class, name, behavior, are similar to the properties in our dog class, though there will be some differences because, of course, cats are not dogs. Let's say that our cat class looks like this. Class cat. There's a constructor with a name and uses litter. This dot underscore name is name, this dot underscore uses litter equals uses litter, this dot underscore behavior equals 0. We have a get name method that returns this dot name, a get uses litter method that returns this dot uses litter, a get behavior method which returns this dot behavior, an increment behavior method which increments this dot behavior up by 1 every time that it's called. In the example above, we create a cat class. It shares a couple properties, name and behavior, and a method, increment behavior, with the dog class from earlier exercises. The cat class also contains one additional property, uses litter. That holds a Boolean value to indicate whether a cat can use their litter box. When multiple classes share properties or methods, they become candidates for inheritance, a tool developers use to decrease the amount of code they need to write. With inheritance, you can create a parent class, also known as a superclass, with properties and methods that multiple child classes, known as subclasses, share. The child classes inherit the properties and methods from their parent class. Let's abstract the shared properties and methods from our cat and dog classes into a parent class called animal, class animal. It has a constructor that takes in name, and this dot name equals the name, this dot behavior will equal 0. We have a get name that returns this dot name, and get behavior that returns this dot behavior, and increment behavior. So in both of these animals, dogs and in cats, they contain all of this. So this could be a superclass for both of them. In the example above, the animal class contains properties and methods that the cat and dog classes share, name, behavior, and increment behavior method. The diagram to the right shows the relationships we want to create between the animal, cat, and dog classes. We have a parent class of animal with properties, name, and behavior, and methods.increment behavior. The child class of dog will take all of the parent's class properties and methods. The child class of cat will take all of the parent class's property and methods, and also add another property called uses litter. Let's go to the next lesson. Inheritance 2. In the last exercise, we created a parent class named animal for two child classes named cat and dog. The animal class below contains the shared properties and methods of cat and dog. And we went through all of that. So the code below shows the cat class that will inherit information from the animals class. So this is the entire cat class, and we did go through that already. To the right in main.js, you will put what you learned to practice by creating a parent class named hospital employee. Instructions. In the next few exercises, you will create two subclasses, doctor and nurse, from the parent class named hospital employee. Below, we have listed the properties and methods you will find in the doctor and nurse classes. Doctor. Properties, name, remaining vacation days, set to 20 inside the constructor. Insurance. Method, take vacation days. Nurse has properties name, remaining vacation days set to 20 inside the constructor, certifications. The methods are take vacation days and add certification. In main.js, create a parent class named hospital employee, add a constructor with name as an argument. Okay, so we need to make a class called hospital employee. And that is going to have a constructor. So constructor with the name as the argument there. And inside constructor, we'll set this dot underscore name equal to name. That looks to be what they want here because the property is underscore name. They didn't ask us to set it though. I'm going to get rid of this for right now. I'll just comment it out. Let's run this and see if it works. Yep, that worked. Inside the constructor, set the instance's name to name and remaining vacation days to 20. Okay, we did the name already. It's right here in this dot name. Let me indent, and then I want to have this dot underscore remaining vacation days. And that equals 20. And I will run that. Great. Under the constructor, create getters for your name and vacation days properties. Inside the getter, return the property's value. Okay, so we will make a get name, and that's a method. And in there, we're returning the property's value, this dot underscore name. And we need remaining vacation days as well. So get remaining vacation days, no underscore in front of it. And we make our method and return this dot remaining vacation days. Let's see if that's all right here. Let's run that. That works. Under the getters, add a method called take vacation days. This method should accept one argument, called days off. Inside the method, subtract days off from remaining vacation days, save the result to remaining vacation days. So we're going to make a take vacation days method. Take vacation days, that's taking in days off. And now we have to change it according to the days off. We have to change the remaining vacation days. So this dot remaining vacation days is going to equal this dot remaining vacation days minus days off. And that ought to work. Let's go ahead and run that. Great, we have that done. Let's move to the next lesson. Inheritance 3. We've abstracted the shared properties and methods of our cat and dog classes into a parent class called animal. And we just saw that, so let's move on to, now that we have these shared properties and methods in the parent animal class, we can extend them to the subclass cat. Class cat extends animal. Constructor takes in name and uses litter, and then calls super with name. This dot uses litter equals uses litter. In the example above, we create a new class named cat that extends the animal class. Let's pay special attention to our new keywords, extends and super. The extends keyword makes the methods of the animal class available inside the cat class. The constructor called when you create a new cat object accepts two arguments, name and uses litter. The super keyword calls the constructor of the parent class. In this case, super name passes the name argument of the cat class to the constructor of the animal class. When the animal constructor runs, it sets this dot underscore name equal to name for new cat instances. Uses litter is a new property that is unique to the cat class, so we set it in the cat constructor. Notice that we call super on the first line of our constructor, then set the useSLitter property on the second line. In a constructor, you must always call the super method before you can use the this keyword. If you do not, JavaScript will throw a reference error. To avoid reference errors, it is best practice to call super on the first line of subclass constructors. Below, we create a new cat instance and call its name with the same syntax as we did with the dog class. Const BryceCat equals new cat, Bryce, and false are passed in as the arguments there. Console.log BryceCat underscore name, BryceCat dot underscore name will output Bryce. In the example above, we create a new instance of the cat class, I imagine. So I'll read that one more time. In the example above, we create a new instance of the cat class named BryceCat. We pass it Bryce and false for our name and useSLitter arguments. When we call console.log BryceCat._name, our program prints Bryce. In the example above, we abandon best practices by calling our _name property directly. In the next exercise, we'll address this by calling an inherited getter method for our name property. Instructions. In this exercise, you will begin to create the nurse class as a child of the hospital employees class. Remember, the nurse class has the following properties and methods. Nurse, properties, _name, remaining vacation days set to 20 inside the constructor, and certifications, _certifications. Methods, .take vacation days and .add certification. Under hospital employee, create an empty class named nurse that extends hospital employee. Okay, so that was class nurse. Extends was the keyword, and then hospital employee. And that's all we have to do there. I think that's all they're asking for so far. Let's just run that. Yes, that's it. Inside the nurse class, create a constructor that accepts 2 arguments. Use the list of properties above to name these arguments. Okay, so they want us to use, we have name, remaining vacation days, and certifications. So we're going to make a constructor. It accepts 2 arguments, so we'll need name and I imagine certification. And then in the body, we shouldn't do anything yet, I think. Let's just, let's run this. Doesn't seem like we should do anything yet. Yep, that works. In the nurse constructor, call the parents constructor method and pass the appropriate values. Okay, so the parent constructor method was called with super, and the value that needs to be passed is only name. That's the only thing that happened in that constructor. Yeah, because this takes a name, and this dot name equals name. I think that would work. Let's see. Yes, it does. Inside of the nurse constructor and under super, set _certifications. Okay, so under super, we want to have this dot _certifications is equal to certifications. Let's run that. That does work. Under the nurse class, create a new instance of nurse and save it to a constant variable named nurse I don't know how to say this. We'll call her nurse O for now. Pass in the following values for each property. And we have a name and we have a certification, and that's an array. Okay, so let's work on that. Const and nurse O is going to equal a new nurse. And the new nurse takes in a name, which is this one right here that I'm having some trouble with, and that needs to be a string. And it also takes in certifications, which is right here, this array. There's our certifications array as the second thing being passed in. And let's run that and see if it works. There we go. Let's move on to the next lesson. Inheritance 4. Now that we know how to create an object that inherits properties from a parent class, let's turn our attention to methods. When we call extends in a class declaration, all of the parent methods are available to the child class. Below, we extended our animal class to a cat subclass. They have a class of animal that has everything animal had in it, and then they have a class of cat that extends animal, has a constructor. In the constructor, super is called with the name, and this dot underscore uses kitty litter is set to uses kitty litter, and they have a const of Bryce cat, a new cat named Bryce, who can't use litter yet. In the example above, our cat class extends animal. As a result, the cat class has access to the animal getters and the increment behavior method. Also, in the code above, we create a cat instance named Bryce cat. Because Bryce cat has access to the name getter, the code below logs Bryce to the console. Console.log brycecat.name. Since the extends keyword brings all of the parents' getters and methods into the child class, brycecat.name accesses the name getter and returns the value saved to the name property. Now consider a more involved example and try to answer the following question. What will the code below log to the console? We have brycecat.incrementBehavior, call.incrementBehavior on cat instance. Then we have console.log brycecat.behavior, log value saved to behavior. The correct answer is 1, but why? The cat class inherits the behavior property, behavior getter, and the increment behavior method from the animal class. When we create the Bryce cat instance, the animal constructor set the behavior property to 0. The first line of the code calls the inherited increment behavior method, which increases the Bryce cat behavior value from 0 to 1. The second line of the code calls the behavior getter and logs the value saved to behavior, which is 1. Instructions. Call.takeVacationDays with an input of 5 on your nurse-o instance. So after everything, I'm going to grab nurse-o and nurse-o.takeVacationDays, and I'll pass in 5. Let's see if that works. Perfect. Under the method call log the value saved to the remaining vacation days property in nurse-o. So we need to console log this one. Console.log and her remaining vacation days. Perfect. We have 15 left after that. Let's move on to the next lesson. Inheritance 5. In addition to the inherited features, child classes can contain their own properties, getters, setters, and methods. Below, we will add a useLitter getter. The syntax for creating getters, setters, and methods is the same as it is in any other class. And they have the cat class extending the animal class, which we've seen several times. It does have a getter in here, get, and then the useLitter method. In the example above, we create a useLitter getter in the cat class that returns the value saved to useLitter. Compare the cat class above to the one we created without inheritance. And we can see this class of cat has everything that was inherited now in it itself here. So we decreased the number of lines required to create the cat class by about half. Yes, it did require an extra class, animal, making the reduction in size of our cat class seem moot. However, the benefits, time saved, readability, efficiency of inheritance grow as the number and size of your subclasses increase. One benefit is that when you need to change a method or property that multiple classes share, you can change the parent class instead of each subclass. Before we move past inheritance, take a moment to see how we would create an additional subclass called dog. Class dog extends animal. constructor, name, super, name. The dog class has access to the same properties, getters, setters, and methods as the dog class we made without inheritance, and is a quarter the size. Now that we've abstracted animal daycare features, it's easy to see how you can extend animal to support other classes like rabbit, bird, or even snake. Instructions. Use the properties and methods below to help you complete the tasks that follow. Nurse has a property name, remaining vacation days, set to 20 inside the constructor, and certifications. Methods, take vacation days, add certification. Under the nurse constructor, add a getter that returns the value saved to the nurse instance's certifications. Okay, so we're going to make a getter under the nurse constructor, which is right here. There's a constructor. A getter starts with get. And we want to get the certification. So we will use the word certifications here, not the underscore though. I'll get rid of that. And so this will be a method that returns, so return this dot underscore certifications. All right, that should work. Let's try it out. Perfect. Add a method called addCertification under the certifications getter. The method should accept one input, new certification. Let's do that first. Add certification is a method that takes in new certification. Inside the method, use the push method to add the new certification value to the nurse's certification array. Okay, so now we'll have the new certification value pushed in there. So we'd have this dot underscore certifications dot push, and we want to push the new certification into there. Yep. Make sure you get it in there. There we go. And I will run that. Let's see. Perfect. At the bottom of main.js, call the .addCertification method on nurse O with a parameter of genetics. Okay. So after everything, we know we have nurse O right here. So nurse O dot, and it was add certification, and what we want to add there is genetics. So capital G, genetics. And let's run that. Log the value saved to the certifications property of nurse O. Okay, in order to log a certification, we have this get certifications right here. So we got to start nurse O up again. And we will do dot certifications, and we could just run that. Oh no, I have an error because I should have logged it and I didn't. All right, little mistake there. So console.log, and let's stick nurse O's certifications in there and try again. There we go. We have trauma, pediatrics, and now genetics. Let's move on to the next lesson. Static methods. Sometimes you will want a class to have methods that aren't available in individual instances, but that you can call directly from the class. Take the date class, for example. You can both create date instances to represent whatever date you want, and call static methods like date.now, which returns the current date, directly from the class. The .now method is static, so you can call it directly from the class, but not from an instance of the class. Let's see how to use the static keyword to create a static method called generateName method in our animal class. It's just going to be called generateName. It's not generateName method. So we have a class of animal and the constructor, of course. Now here we are in the static generateName. So there's a static method right here, and we have a const names equals an array of names. Const random number will equal math.floor, math.random times 5, since there are 1, 2, 3, 4, 5 names, and then you return name, open square brackets, and put that random number inside of there to return one of the 5 names at random. In the example above, we created a static method called .generateName that returns a random name when it's called. Because of the static keyword, we can only access .generateName when appending it to the animal class. We call the generateName method with the following syntax: console.log animal.generateName, and we have to invoke it. You cannot access the generateName method from instances of the animal class for instances of its subclass. See below. Const Tyson equals new animal and the string of Tyson. Tyson.generateName would give you a type error. The example above will result in an error because you cannot call static methods generateName on an instance Tyson. Instructions. Inside of your hospital employee class, create a static method called generatePassword. When it's called, this method should return a random integer between 0 and 10,000. So we want to make a generatePassword method. So the first thing we should do is let's make the method. GeneratePassword, and it needs to be static. So before it, we write static GeneratePassword. And inside of there, it should return a random integer between 0 and 10,000. And we could grab that right from what they did. See here, so math.floor will round down anything that it receives. And inside math.floor is math.random, generating a number between 0 and 1. We multiply that number by 5 here, and then we floor it to make sure we have something between 0 and 4. Since there is 0, 1, 2, 3, and 4. So let's take this random number here, const random number, and we'll put it in here. And we don't need to return names or anything. So I'm not going to even have a const called random number. I'm just going to return a random number. And they want it to be between 0 and 10,000, so it really should be probably 10,000. Do they want it to include 10,000 is really the question now. So I'm just going to make it 10,000 and see what happens. Oh, did I close this properly? I did not. So make sure that that is there. That closes the function, and this closes the class. So let's run it. That works, great. We can move on to the next lesson. Review, classes. Way to go, let's review what you learned. Classes are templates for objects. JavaScript calls a constructor method when we create a new instance of a class. Inheritance is when we create a parent class with properties and methods that we can extend to child classes. We use the extends keyword to create subclasses. The super keyword calls the constructor of a parent class. Static methods are called on the class, but not on instances of classes. In completing this lesson, you've taken one step closer to writing efficient production-level JavaScript. Good luck as you continue to develop your skills and move into intermediate-level concepts. And we have instructions for some extra practice if you'd like to do it, but let's see what's up next. Browser compatibility and transpilation. Introduction. You're probably prompted to update your web browser every few months. Do you know why? A few reasons include addressing security vulnerabilities, adding features, and supporting new HTML, CSS, and JavaScript syntax. The reasons above imply there is a period before a software update is released when there are security vulnerabilities and unsupported language syntax. This lesson focuses on the latter. Specifically, how developers address the gap between the new JavaScript syntax that they use and the JavaScript syntax that the web browser recognizes. This has become a widespread concern for web developers since ECMA International, the organization responsible for standardizing JavaScript, released a new version of it in 2015 called ECMAScript 2015, commonly referred to as ES6. Note, the 6 refers to the version of JavaScript and is not related to the year it was released. The previous version was ES5. Upon release, web developers quickly adopted the new ES6 syntax, as it improved readability and efficiency. However, ES6 was not supported by most web browsers, so developers ran into browser compatibility issues. In this lesson, you will learn about 2 important tools for addressing browser compatibility issues. CanIUse.com, a website that provides data on web browser compatibility for HTML, CSS, and JavaScript features. You will learn how to use it to look up ES6 feature support. Babel, a JavaScript library that you can use to convert new, unsupported JavaScript, ES6, into an older version, ES5, that is recognized by most modern browsers. Let's get started by running ES6 JavaScript on a fake old web browser version. Instructions. Copy the following code into main.js. The code includes 3 features of ES6 syntax: const, let, and ES6 string interpolation. Run the code when you are ready. Look at the errors displayed in our Letscape. Okay, we'll copy all of this and we will paste it right in and press run. There we are, we're working now. Let's move on to the next lesson. CanIUse.com 1. Since ECMA's release of ECMAScript 2015, ES6, software companies have slowly added support for ES6 features and syntax. While most new browser versions support the majority of the ES6 library, there are still a couple sources of compatibility issues. Some users have not updated to the latest ES6 supported web browser version. A few ES6 features, like modules, are still not supported by most web browsers. Because companies add support for ES6 features gradually, it's important for you to know how to look up browser support on feature-by-feature basis. The website CanIUse.com is the best resource for finding browser compatibility information. In CanIUse, you can enter an ES6 feature like let and see the percentage of the browser that recognizes it. You can also see when each major web browser, Chrome, Safari, Edge, added support for the keyword. The video to the right shows you how to get started with CanIUse. So you can go ahead and watch that video to the right. The instructions say, in the video, we will use CanIUse.com to find the percentage of browsers that support the entire ES5 library. Then we will look at the percentage of browsers that support modules, a feature introduced in ES6. So go ahead and play that video back for yourself and then follow me to the next lesson. CanIUse.com 2. Now it's your turn to get some practice with CanIUse.com. In a new tab, open CanIUse.com and complete the task below. Instructions. Look up the percentage of browsers that support JavaScript ES5, save the value as a number to the variable ES5 percentage support. ES5 percentage support, and we need to make that equal to the ES5 support. We see the percentage right here is 98.08. Let's paste that in and run it. Without the percent sign. I didn't mean to copy that. Let's run it. That does it for us. Look up the percentage of browsers that support template literals, a feature that was introduced in ES6. Save the value as a number to the variable ES6 template literals. So we're going to look for this term, template literals. I'm going to copy it, go to CanIUse, put it in there, and let's take a look. Looks like 94.59%. So let's write that in this time. 94.59 and no percentage. We'll run that. Let's go to the next lesson. Why ES6? Before we learn how to set up a JavaScript project that converts ES6 to an older version, it's worth understanding a few of the reasons ECMA made such substantial updates. The version of JavaScript that preceded ES6 is called JavaScript ES5. 3 reasons for the ES5 to ES6 updates are listed below. Readability and economy of code. The new syntax is often easier to understand, more readable, and requires fewer characters to create the same functionality, economy of code. Addresses sources of ES5 bugs. Some ES5 syntax led to common bugs. With ES6, ECMA introduced syntax that mitigates some of the most common pitfalls. A similarity to other programming language. JavaScript ES6 is syntactically more similar to other object-oriented programming languages. This leads to less friction when experienced non-JavaScript developers want to learn JavaScript. Because ES6 addressed the above issues, ECMA knew that adoption by web developers would occur quickly, while web browser support lagged behind. To limit the impact of ES6 browser compatibility issues, ECMA made the new syntax backwards compatible, which means you can map JavaScript ES6 code to ES5. Instructions. In these tasks, you will manually change the code in main.js to ES5 syntax. The let and const keywords were introduced in ES6. Before that, we declared all variables with the var keyword. Change the let and const keyword in main.js to var. Okay, const will be var, let will be var, and let's run it. Oh, we had one more const down here. That's also var. Number 2. The following line of code is written with ES6 string interpolation. In ES5, we used plus signs, plus, to interpolate variables into strings. In main.js, use ES5 string interpolation to set carbonara to the same string as above. Well, let's see what we have here. We're going to plus to this, and plus to this. We also need these spaces as well, but we could do that by closing off these quotes right here. Then we'll add a space, and we'll get rid of what's around pasta, and we will plus 2 pasta. Oh, I'm sorry. I got rid of that space by accident. And here we have meat. So we will plus to that. And give it a space, and then to meat. Then plus to another comma with a space in front of it, comma after, plus, and a sauce made with, finish that out, get this tick away, get that tick away, replace it with a normal quote, and we will have a plus to sauce, and we'll need a space there. We might be missing a space somewhere around here, I'm not exactly sure. I think that might be in the wrong spot. It looks like we might be working properly here. Let's give it a run. That did work. We did our ES6 to ES5 from string interpolation to that plus interpolator. We could go on to the next lesson. Here we go. A transpilation with Babel. In the last exercise, you manually converted ES6 code to ES5. Although manual conversion only took you a few minutes, it is unsustainable as the size of the JavaScript file increases. Because ES6 is predictably backwards compatible, a collection of JavaScript programmers developed a JavaScript library called Babel that transpiles ES6 JavaScript to ES5. Transpilation is the process of converting one programming language to another. In the remaining exercises of this lesson, you will learn how to use Babel to transpile the new, easy-to-write version of JavaScript, ES6, to the old, browser-compatible version of JavaScript, ES5. In the instructions below, you will pass JavaScript ES6 code to Babel, which will transpile it to ES5 and write it to a file in the lib directory. Instructions. In the terminal window, type npm install babel-cli. This installs one of the two required Babel packages. Npm install babel-cli. And now that's installed. In the terminal window, type npm install babel preset env. I'm just going to copy this in, babel-preset-env. That worked as well. Let's do number 3. In the terminal, type npm run build and press enter. Npm run build, enter. You can view the ES5 code in .lib/main.js. You may need to refresh to see the newly created lib directory. All right, let's refresh to get to that directory. Don't quite see that directory here. I would imagine it's kind of in the folder. Oh no, it's right here. Okay. So we have lib. Oh, I see. So here it is. It's going to be var, and here is the interpolation that we did the last time, but it's done for us with Babel. Babel is doing all of this for us. That's what happened there. Let's move on to the next lesson. npm init. In the last exercise, you wrote one command in your terminal to transpile ES6 code to ES5. In the next 5 exercises, you will learn how to set up a JavaScript project that transpiles code when you run npm run build from the root directory of a JavaScript project. The first step is to place your ES6 JavaScript file in a directory called src. From your root directory, the path to the ES6 file is /src/main.js. The initial JavaScript project file structure is project, then src, and then main.js. And they're all within each other. So src is in project, main.js is in src. Before we install Babel, we need to set up our project to use the Node Package Manager. That's npm. Developers use npm to access and manage Node packages. Node packages are directories that contain JavaScript code written by other developers. You can use these packages to reduce duplication of work and avoid bugs. Before we can add Babel to our project directory, we need to run npm init. The npm init command creates a package.json file in the root directory. A package.json file contains information about the current JavaScript project. Some of this information includes metadata. This includes a project title, description, authors, and more. A list of Node packages required for the project. If another developer wants to run your project, npm looks inside package.json and downloads the packages in this list. Key value pairs for command line scripts. You can use npm to run these shorthand scripts to perform some process. In a later exercise, we will add a script that runs Babel and transpiles ES6 to ES5. If you have Node installed on your computer, you can create a package.json file by typing npm init into the terminal. The terminal prompts you to fill in fields for the project's metadata, name, description, etc. You are not required to answer the prompts, though we recommend at minimum you add your own title and description. If you don't want to fill in a field, you can just press enter. NPM will leave these fields with default values or leave them empty when it creates the package.json file. After you run npm init, your directory structure should contain the following files and folders. Project, src is inside of project, main.js is inside of src, and a package.json that's just inside of project. npm adds the package.json file to the same level as the src directory. Instructions. Run ls in the terminal to see the file structure of your current directory. ls, enter. We see we have src in there. Use npm to create a new package.json file. We recommend you set the name and description properties to the following values. Name, learning Babel. Description, use Babel to transpile JavaScript ES6 to ES5. So that was npm init. This utility will walk you through creating a package.json file. It only covers the most common items and tries to guess sensible defaults. See npm help JSON for definitive documentation on these fields and exactly what they do. Use npm install package-save afterwards to install a package and save it as a dependency in the package.json file. Press Shift-C at any time to quit. Name. Learn JavaScript transpilation bct npm init. We want to change the name to Learning Babel. So let's get rid of all of that. Oh, can we? I don't know if we can get rid of all of that. Well, they're getting us down to version and then description. Well, let me try doing this again. Maybe I accidentally pressed enter. npm init. They seem to have the name figured out. Okay, so let's just put the description in. Call it learning. Oh, that's the name. Entry point ES6 test command. They didn't give us one of those. There's no Git repository. Keywords, quite a bit here. This is okay. Yes. And we're good. Okay, so we didn't have to put that name in there to pass this part of it, and we did set up that file. Enter ls to take a look at what happened. We have a package.json now. Okay, great. Let's move on to the next lesson. Install node packages. We use the npm install command to install new node packages locally. The install command creates a folder called node modules and copies the package files to it. The install command also installs all of the dependencies for a given package. To install Babel, we need to npm install two packages, babel-cli and babel-preset-env. However, npm installs over 100 other packages that are dependencies for Babel to run properly. We install Babel with the following two commands, npm install babel-cli, and then -D, npm install babel-preset-env -D, and that's a space between the name, between babel-cli space and then -C. The babel-cli package includes command line Babel tools, and the babel preset env package has the code that maps any JavaScript feature ES6 and above, ES6 plus, to ES5. The -D flag instructs npm to add each package to a property called dev dependencies in package.json. Once the project's dependencies are listed in dev dependencies, other developers can run your project without installing each package separately. Instead, they can simply run npm install. It instructs npm to look inside package.json and download all of the packages listed in dev dependencies. Once you npm install packages, you can find the Babel packages and all their dependencies in the node modules folder. The new directory structure contains the following: We have a project, that's the project folder. Inside of it is node modules, src, and package.json. Inside of node modules is a .bin, and then ... meaning a bunch of other folders. Inside of src is the main.js. The ... in the file structure above is a placeholder for 100 plus packages that npm installed. Instructions. Enter ls into the terminal to view the current directory's file structure. ls, enter. We have package.json and the src. So here we have the project, package.json, and src are in there. We don't seem to have node modules. Use npm with the -d flag to install the Babel command line package and add it to the dev dependencies property in package.json. So that was npm install, and there were two of them. So let's do both of them. Here we are, npm install babel-cli and capital D. And now let's do the other one, npm install babel-preset-env -D. Let's see if we did that properly. Oh, okay, yes, we did everything there. So I didn't read this third one. That's done already, but let's look at it real quick. Use npm with the -d flag to install the Babel preset environment package. That's why it happened. I just did that. I did both of them. And add it to the dev dependencies property in package.json. Enter ls into the terminal to see the file structure of your current directory. Notice the addition of node modules. Let's see that real quick, just ls. And now we have node modules, package.json, and src. You can also see the new folder by clicking on the file navigation button above the text editor. So the folder should be in here. There it is, node modules. Let's go to the next lesson. .babelrc. Now that you've downloaded the Babel packages, you need to specify the version of the source JavaScript code. You can specify the initial JavaScript version inside of a file named .babelrc in your root directory. You can run touch.babelrc to create this file. Your project directory contains the following folders and files. Project has node modules. Inside node modules is bin and 100 other modules. It has src, which contains the main.js. And on the first level again has babelrc, and on the first level again it has package.json. Inside babelrc, you need to define the preset for your source JavaScript file. The preset specifies the version of your initial JavaScript file. Usually you want to transpile JavaScript code from ES6 and later ES6 Plus to ES5. From this point on, we will refer to our source code as ES6 Plus because ECMA introduces new syntax with each new version of JavaScript. To specify that we are transpiling code from an ES6 Plus source, we have to add the following JavaScript object into babelrc. And it is an object that says presets as a string and has a env inside of an array as a string as well. When you run Babel, it looks in .babelrc to determine the version of the initial JavaScript file. In this file, env instructs Babel to transpile any code from version ES6 and later. Instructions. In the root directory, use touch to create a new .babelrc file. So we want to say touch.babelrc. That did work. Open the .babelrc file and add an object that specifies the preset to env. Okay, let's go up here into the babelrc, an object that specifies preset, and that is lowercase. Yes, it is, preset. And it's going to be, no, it's going to be an array, and then make it a string and put env in there if I'm correct. Let's take a quick look. Yep, this looks just about right. Let's run that. Nope, that's wrong. Did you add presets? Oh, no, I didn't add the S. That was a typo. Now it's right. Great, let's move on to the next one. Babel source lib. There's one last step before we can transpile our code. We need to specify a script in package.json that initiates the ES6 Plus to ES5 transpilation. Inside of the package.json file, there is a property named scripts that holds an object for specifying command line shortcuts. It looks like this. And it has scripts in there. It opens up an object and it has tests, which has echo, error, no test specified, and exit 1. I guess exit with exit, error code 1. In the code above, the scripts property contains an object with one property called test. Below the test property, we will add a script that runs Babel like this. So they have their scripts, and after the exit 1 is a build script. And the build script points to Babel src-d lib. In the scripts object above, we add a property called build. The property's value, Babel src-d lib, is a command line method that transpiles ES6 plus code to ES5. Let's consider each argument in the method call. Babel, the Babel command call responsible for transpiling code. src instructs Babel to transpile all JavaScript code inside the src directory. -d instructs Babel to write the transpiled code to a directory. lib, Babel writes the transpiled code to a directory called lib. In the next exercise, we'll run the Babel src-d lib method to transpile our ES6 Plus code. Instructions. In package.json, add a script called build. When run, the build script should use Babel to transpile JavaScript code inside of the src folder and write it to a folder called lib. Don't forget to add a comma after test script. Okay, so we have to go to where test is. That's right here. We'll comma, and now they want a build script, so we will build. And after that, let's see exactly how they did this. They just explained it to us. We know what everything is. So it's build, and the first thing we want to say is Babel, and then the folder, that's the src, and then -d is to write that code into the directory, and lib is where it should be, is actually what it's called. That's the lib, is where it will be written. Let's write that all in here. We'll have Babel src-d lib. I'm going to go down, just check this one more time. src lib. All right, we look good. Let's give it a shot. Great, that is done. Let's move to the next lesson. Build. We're ready to transpile our code. In the last exercise, we wrote the following script in package.json. Build Babel src-d lib. Now we need to call build from the command line to transpile and write ES5 code to a directory called lib. From the command line, we type npm run build. The command above runs the build script in package.json. Babel writes the ES5 code to a file named main.js. It's always the same name as the original file, inside of a folder called lib. The resulting directory structure is, and they explain the directory structure that's already there, except now it has under project an lib, and inside of lib a main.js, just like you have under project an src, and inside of src there's a main.js. Notice the directory contains a new folder named lib, with one file called main.js. The npm run build command will transpile all JavaScript files inside of the src folder. This is helpful as you build larger JavaScript projects. Regardless of the number of JavaScript files, you only need to run one command, npm run build, to transpile all of your code. Instructions. Transpile the ES6 Plus code to lib using the build command. Once you've done this, navigate to the new lib folder and open main.js. Okay, so npm run build was what was said up here. So let's try that out and run it. And we can see the code here. This is the same code from before, so everything should be changed to var, 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 and this should be done with pluses instead of this string interpolation we're doing with the $ and so on. Let's take a look into files. We have src and the main. Oh, I didn't run this yet. There we go. Here we go. And we have files lib and another main. So let's check out this other main. Remember what this looks like. This has var pasta, var meat, var sauce, var carbonara, and you can see the pluses are how we string interpolate in this one. Let's move on to the next lesson. Review. In this lesson, you learned about browser compatibility and transpilation. Let's review the key concepts. ES5, the old JavaScript version that is supported by all modern web browsers. ES6, the newer JavaScript version that is not supported by all modern web browsers. The syntax is more readable, similar to other programming languages, and addresses the source of common bugs in ES5. CanIUse.com, a website you can use to look up HTML, CSS, and JavaScript browser compatibility information. Babel, a JavaScript package that transpiles JavaScript ES6 Plus code to ES5. npm init, a terminal command that creates a package.json file. Package.json, a file that contains information about a JavaScript project. npm install, a command that installs Node packages. Babel-CLI, a Node package that contains command line tools for Babel. Babel-preset-env, a Node package that contains ES6 Plus to ES5 syntax mapping information. .babelrc, a file that specifies the version of the JavaScript source code. Build script, a package.json script that you use to transpile ES6 Plus code to ES5. npm run build, a command that runs the build script and transpiles ES6 Plus code to ES5. For future reference, here is a list of the steps needed to set up a project for transpilation. Initialize your project using npm init and create a directory called src. Install Babel dependencies by running npm install babel-cli-d, npm install babel-presets-env-d. Create a babelrc file inside your project and add the following code inside it. It opens up an object, it adds presets, and then it puts in env into an array. Add the following script to your scripts object in package.json. Build babel src -d lib. Run npm run build whenever you want to transpile your code from your src to lib directories. Instructions. If you want some more practice, take a moment to add JavaScript files and ES6 syntax to the src folder and try transpiling them. Once you feel comfortable with this process, try setting up Babel on your own computer, and you can do that as much as you'd like, but I'd like to see what's up next. Let's take a look. Intermediate JavaScript modules. Hello, modules. JavaScript modules are reusable pieces of code that can be exported from one program and imported for use in another program. Modules are particularly useful for a number of reasons. By separating code with similar logic into files called modules, we can find, fix, and debug code more easily. Reuse and recycle defined logic in different parts of our application. Keep information private and protected from the other modules. And, importantly, prevent pollution of the global namespace and potential naming collisions by cautiously selecting variables and behavior we load into our program, or into a program. In this lesson, we'll cover 2 ways to implement modules in JavaScript: Node.js's module.export and require syntax, as well as the ES6 import/export syntax. Instructions. Once you feel like you have a high-level understanding of modules, proceed to the next exercise. Well, let's proceed to that exercise. Module.exports. We can get started with modules by defining a module in one file and making the module available for use in another file with Node.js module exports syntax. Every JavaScript file run in Node has a local module object with an exports property used to define what should be exported from the file. Below is an example of how to define a module and how to export it using the statement module.exports. In menu.js we write, let menu equal empty object. Menu.specialty equals the string roasted beet burger with mint sauce. Module.exports equals menu. Let's consider what this code means. 1. Let menu equal empty object creates the object that represents the module menu. The statement contains an uppercase variable named menu, which is set equal to an empty object. Menu.specialty is defined as a property of the menu module. We add data to the menu object by setting properties on that object and giving the properties a value. 3. Roasted beet burger with mint sauce is the value stored in the menu.specialty property. Module.exports equals menu exports the menu object as a module. Module is a variable that represents the module, and exports exposes the module as an object. The pattern we use to export modules is thus: 1. Create an object to represent the module. 2. Add properties or methods to the module object. 3. Export the module with module.exports. Let's create our first module. Instructions. Let's begin by implementing the pattern above in an example. In 1-airplane.js, create an object named airplane. Okay, so const airplane equals an empty object and includes that statement. Let's run. Within the same file, add a property to the airplane object named myAirplane and set it equal to starjet. Okay, so we will say airplane.myAirplane equals starjet. And they use double quotes. They are very, very strict. I've really noticed that. So I'm just going to try to do the double quotes with them there. Let's run that. That worked. Export the module. Well, that was the name of this section. It was module.exports equals, and then the airplane, the object that we're exporting. Let's make sure I'm right. Great, let's move on to the next lesson. Require. To make use of the exported module and the behavior we define within it, we import the module into another file. In Node.js, use the require function to import modules. For instance, say we want the module to control the menu's data and behavior, and we want a separate file to handle placing in order. We could create a separate file order.js and import the menu module from menu.js to order.js using require. Require takes a file path argument pointing to the original module file. In order.js, we could write const menu equals require, and it opens up parentheses, and inside of there is a string that is menu.js. Then it says function placeholder, that's a function, and in the function body is console.log, and there's a string of my order is plus the menu.specialty, and when they call place order at the bottom, we don't actually see the result yet, but I'm sure they're about to tell us. We now have the entire behavior of menu available in order.js. Here we notice 1. In order.js, we import the module by creating a const variable called menu and setting it equal to the value of the require function. We can set the name of this variable to anything we like, such as menu items. 2. Require is a JavaScript function that loads a module. Its argument is a file path of the module, ./menu.js with require. The .js extension is optional and will be assumed if it is not included. 3. The placeOrder function then uses the menu module. By calling menu.specialty, we access the property specialty defined in the menu module. Taking a closer look, the pattern to import a module is 1. Import the module with require and assign it to a local variable. 2. Use the module and its properties within a program. Instructions. 1. In 1-missioncontrol.js, use the require function to import the airplane module from 1-airplane.js. Recall that you will need to use the precise name of the file that contains the module. Well, they gave us that there, that's this. I will just copy it. Okay, so we're going to have a const, we'll call it airplane, that will equal require. And inside of require, we're going to do a string, and the string is going to say /1-airplane.js, and I will put a semicolon after, and we'll run that. And that didn't work. It could be because of the quotes. Actually, I could see it's going to be because I didn't put period. It was /. So let's run that. Yeah, that does work. Okay, great. Make sure we put a period before we put the /. 2. In 1-missioncontrol.js, define a function displayAirplane. In the function, log the value of the module and its property to the console. Okay, so we want to make a function called displayAirplane. We'll do a fat arrow one. So displayAirplane equals the fat arrow function. And inside of this fat arrow, we're going to log the console.log, we know that, the property. So we want the property of airplane. I'm guessing the property that we made. Okay, so it would be airplane dot, I think it was my airplane is the property they're probably looking for here. Okay, well, let's check it. Let's see. No, we're getting a problem here. We have a syntax error. Oh, yeah, that's that. That's a fat arrow function now. Perfect. Okay. Call the displayAirplane function in the console. You should see the name of the airplane you defined in the module. Okay, so let's display airplane as a function. That's us calling it there. Can we run that? Starjet, that is the plane that we made. Let's go to the next lesson. Module.exports 2. We can also wrap any collection of data and functions in an object and export the object using module.exports. In menu.js, we could write module.exports equals, it opens an object that has specialty, a string of roasted beet burger with mint sauce, a get specialty that has a function, and the function is returning this .specialty. In the above code, notice 1. Module.exports exposes the current module as an object. Specialty and getSpecialty are properties on the object. Then in order.js, we write const menu equals require, and in that require, there are quotes around a ./menu.js. console.log menu.getSpecialty. Here we can still access the behavior in the menu module. Instructions. In 2-airplane.js, set module.exports equal to an empty object. Okay, module.exports will equal an empty object, and then I will semicolon to close that. That worked. 2. Within the object, create a key called myAirplane and set it to the value CloudJet. Okay. You want a key that is myAirplane, and we'll set it to a value called CloudJet. And that should work. Let's run that. That did work. Again, within module.exports, create another key, display airplane, and set it to an anonymous function. The function should use the this statement to return my airplane. Okay, so we're going to comma to that, comma to the next one. It's going to be display airplane. We're going to set it equal to a function, and we're just going to actually use a regular function here, like so. The function should use the this statement to return. So we're going to return this dot my airplane. Let's see if we did that correctly for them. No, we did not. We have a display airplane. Well, let's take a look at how they did it so we could see if we did anything wrong here. Okay, so they had get specialty, and we did that exactly the same. They did comma to it as well. We have our function, our open, and then our body here. They might just be picking on this. Let's check that. Wow, that's a very, you're not going to have to do these very often. It gets taken care of by like VS Code or something. But yeah, they're very, very strict. Okay, so 4, in 2-missioncontrol.js, use the require function to import the airplane module. Okay, so that's this file here. We're going to const airplane again will equal require. Inside of there, it is a dot slash and then 2-airplane. I'm going to write .js. I know they said that we could not write that if we didn't want to, but it seems like this is crazy strict. So let's try that out. That worked. Okay. 5. In 2-missioncontrol.js, log the result of calling .displayAirplane to the console, noting that it is a method in the airplane object. Okay, so we want to say console.log, then airplane dot, it was display, right? Display airplane. Let's try that out. Let's run it. We have CloudJet up here, and it did pass. Okay, let's go on to the next lesson. Export default. Node.js supports require/modules.export, but as of ES6, JavaScript supports a new, more readable and flexible syntax for exporting modules. These are usually broken down into one of two techniques, default export and named exports. We'll begin with the first syntax, default export. The default export syntax works similarly to the module.export syntax, allowing us to export one module per file. Let's look at an example in menu.js. Let menu equal an empty object. Export default menu. 1. Export default uses the JavaScript export statement to export JavaScript objects, functions, and primitive data types. 2. Menu refers to the name of the menu object, the object that we are setting the properties on within our modules. When using ES6 syntax, we use export default in place of module.exports. Node.js doesn't support export default by default. So module.exports is usually used for Node.js development, and ES6 syntax is used for front-end development. As with most ES6 features, it is common to transpile code since ES6 is not supported by all browsers. Instructions. 1. In airplane.js, let's create an airplane module from scratch, this time exporting the module with export default. Create an object to represent the module called airplane. Okay, so const airplane is going to equal an object, and I'll put the semicolon and run that. Now that we have an object airplane, we can continue by adding data in the form of properties and values to the airplane module. Create an available airplanes variable, I'm going to copy that, and set it equal to an empty array. Be sure that available airplanes is a property of the airplane object. Okay, so here, available airplanes and empty array. And that should be it. Let's just run that, make sure. Great. 3. In the available airplanes array, add 2 array elements that are both of type object. Okay, let's do that first. So we'll put an object here, and then we will comma, and we'll put an object here. The first object should contain a property name with the value arrowjet. Let's do that first. Name arrowjet, and they seem to have single quotes around that one. And then it was fuel capacity, and I'm commenting to that. Fuel capacity, and that will be the value 800. The second object should have the properties name with the value skyjet, so name skyjet, and there's no quotes around this one, so I'm not sure, we'll see. And the fuel capacity, that will be 500. Now, when it comes to single quotes and double quotes, this is my note, not in the video. You can do either one. It's just causing errors with their transpilation or whatever they're doing to kind of grade this. When you're doing this anywhere else, you could do either one, so don't worry too much about that. I don't want to make that into like a JavaScript thing that you're all worried about, so don't worry about that. So I'm just going to see if this passes by running it. Oh, great, that did work. 4. Use export default to export the airplane module. Okay, so export default airplane. Nice work. We added a property that lists the available airplanes to the airplane module. Well, let's run it and see if we did nice work. We did. All right, move on to the next lesson. Import. ES6 module syntax also introduces the import keyword for importing objects. In our order.js example, we import an object like this. Import menu from /menu. 1. The import keyword begins the statement. 2. The keyword menu here specifies the name of the variable to store the default export in. 3. From specifies where to load the module from. 4. /menu is the name of the module to load. When dealing with local files, it specifically refers to the name of the file without the extension of the file. We can then continue using the menu module in the order.js file. Instructions. 1. In missioncontrol.js, we'll use the module airplane to display the fuel capacity for both our airplanes. Use the import keyword to import the airplane module. Okay, so that was import airplane from, and then we find it. So I'm not sure which the last one was. That was 2-airplane. I remember working on 1 and 2. I'm guessing it's just airplane. So let's do that one. get that out of the way, /airplane, and it said that we don't need to do the .js, so let's run it and see what happens. Yep, that works perfectly. 2, define a function, display fuel capacity. Okay, const, and I will copy this. Display fuel capacity and fat arrow function, there you are. Let's run it. Great. Number 3. Within the body of the display fuel capacity function, use for each to iterate over the airplane.availableAirplanes array. The for each should take an anonymous function as a parameter. We'll add more in the next step. All right, well, let's do that. Okay, so airplane.availableAirplanes for each, and should take an anonymous function as a parameter. Okay, so the for each will take an anonymous function as a parameter, and there's an anonymous arrow function. I'm going to hope that's what they mean. Let's give it a shot. That is what they mean. Okay. Pass the anonymous function you created in the last step a parameter of element. Element. Okay, that's your parameter. 5. Within the display fuel capacity function, use console.log to output the element's name and its fuel capacity. The output should look like this. Fuel capacity of plus element name. Okay, I see what they're looking for here. If you want to look at this here, it's saying fuel capacity of, and then it's saying the element's name, and then it's asking us to put the element's fuel capacity. Okay, so we will say, I'm just going to do this with a console.log and backticks. I think the backticks are the way to go. So fuel capacity of, I don't think they actually want the plus there, so I'm just going to $, open and close curly braces, element dot name, and after that they want a element, so another curly braces here. I'll make sure you put those 2 dots in there on the in between. They do want these here. Now here they want element dot fuel capacity. All right, let's give that a shot and see if I wrote that correctly. This is very ugly looking. Let me okay, so it takes the element, we have fat arrow pointing to the function body. All right, this looks a little cleaner, just a little better. Let's run that. There we go. Call the display fuel capacity function. Okay, so display fuel capacity invoked, and let's run that. That's great. So we have fuel capacity of Aerojet is 800. Fuel capacity of Skyjet is 500. And that's what we wrote in on the last lesson. Let's go to the next one. Named exports. ES6 introduced a second common approach to export modules. In addition to export default, named exports allow us to export data through the use of variables. Let's see how this works. In menu.js, we would be sure to give each piece of data a distinct variable name. Let specialty equal empty string. Function is vegetarian is empty, function is low sodium is also empty, export, and then it opens up curly braces, puts in specialty, comma, is vegetarian. 1. Notice that when we use named exports, we are not setting the properties on an object. Each export is stored in its own variable. 2. Specialty is a string object, while is vegetarian and is sodium are objects in the form of functions. Recall that in JavaScript, every function is in fact a function object. 3. Export, curly braces, specialty, comma, is vegetarian, exports objects by their variable names. Notice the keyword export is the prefix. 4. Specialty and is vegetarian are exported, while is low sodium is not exported, since it is not specified in the export syntax. So they're saying is low sodium isn't down here. So it would be exported if it were added to this here, it would be exported. Okay. Remove the statement that sets airplane to an empty object and remove the entire export default line. Okay, so the first one and the last one. We'll run that. 2. Modify the available airplanes array such that it is a variable defined with let and no longer a property on the airplane object. Okay, that was this array here. So we'll get rid of airplane, we'll write let before it, and that's what they asked for. That worked. Number 3. Let's add some more data to the available airplanes array. In the first object, ArrowJet, add a property available staff, and set it equal to an array with the elements, and there's quite a few elements in here: pilots, flight attendants, engineers, medical assistants, and sensor operators. Okay, so let's go to that next. So available staff. And that's going to be an array with all of this stuff in it. Let me just pop them in there like so, take out the end, and I think we're good. Okay. In the second object, Skyjet, I didn't put it in the object. I see what they're asking now. So in ArrowJet's going to have its own available staff, and the second object of Skyjet, they're going to have their own available staff as well. So they'll have a property called available staff, and set it equal to an array with the following elements, and that just has 2. One is pilots, and the second one is flight attendants. And let's run that. That worked. 4. Define a new variable with let named flight requirements and set it equal to an empty object. A new variable. I'm guessing after this. Okay, so let flight requirements equal an empty object. So like so. Let's run that. 5. Within the flight requirements object, add a property required staff and set this equal to 4. Okay, so required staff. It's called 4. Run that. 6. Define a function with the name meets staff requirements that takes available staff and required staff as parameters. Okay, so we'll do a fat arrow function again. Meet staff requirements. Finish our fat arrow function. The parameters in there are available staff and required staff. Let's try that out. Number 7. In the body of the meets staff requirements function, write logic to check if the length of the available staff array is greater than or equal to required staff. The function should contain this logic. If length of available staff is greater than or equal to required staff, return true, else return false. Okay, so if the length of available staff, so available staff dot length is greater than or equal to required staff dot length, we will return true, no, true, else, return false. Let's try that out. We have an error here. Let's see what we did wrong. Return true, return false. Required staff dot. Oh, I put dot length here. And if you see required staff is a number, we don't need dot length. Let's get rid of that. Yeah, okay, required staff is a number. Let's see if that fixes it. Yeah, that does fix it. Great. Let's move on to number 8. Using the export keyword, export the variables available airplanes, flight requirements, and meets staff requirements. So export, then we open up our brackets and we put those in there. We have available airplanes, comma, flight requirements, comma, meets staff requirements. And let's run that. What could the issue be? I'm going to guess they want a semicolon at the end. Let's do that. Okay, again, not something you'll have to do normally when coding in VS Code, but I guess it's a good habit to do your own semicolons, so there's no parsing errors. Let's go to the next one. Named imports. To import objects stored in a variable, we use the import keyword and include the variables in a set of brackets, well, curly brackets. In the order.js file, for example, we could write import, and then they put up their curly braces, specialty, comma, is vegetarian from /menu, then console.log specialty. 1. Here, specialty and is vegetarian are imported. 2. If we did not want to import either of these variables, we could omit them from the import statement. 3. We can then use these objects as in within our code. We can then use these objects within our code, I think is what they're saying. For example, we would use specialty instead of menu.specialty. Okay, yeah, so we are deconstructing from menu there. We're just taking these pieces themselves. So you don't have to say it's from the menu anymore. Like those default ones were coming from, say, airplane. So we had to write airplane.available airplanes like we did right here. Okay, so instructions. 1. Let's remove any reference to airplane in our code since we are no longer exporting this module. Okay, so airplane needs to go. I'll take, let's just take this airplane. We can't have a dot. Is there any more airplanes? I think that's it. Okay. For example, airplane.available airplanes should be modified to available airplanes. Again, you will see a reference error in the console for now, but we will fix that in our next step. Okay, let's run this. Good. Number 2, change the import statement such that it imports the available airplanes, flight requirements, and meets staff requirements. Okay, let's do that. Import our braces there, available airplanes, flight requirements, and meets staff requirements from the airplane. Now modify any instance of the airplane.available airplanes variable so that you can use available airplanes. That's just this one instance. So I think we're good there. I already took that out. We can run it. Great, let's go on to number 3. Define a function. Display staff status. Okay, define a function. We'll do it right here. You know, maybe we should do it under everything. We have a fuel capacity one. How about const display staff status? And that's a function. Let's run that. That works. 4. Within the body of the display staff status function, use the for each to iterate over the available airplanes array. Okay. Specifically, the for each should take a function as a parameter. The function should in turn take element as a parameter. Okay, so we want to use the for each to iterate over available airplanes. Available airplanes dot for each, and we were going to pass it element. Well, we need to pass it a function with element as a parameter. So I'll wrap element, and I will point like so, and there's our body of our function. Let's run that. No, I did that wrong. I'm going to guess that they didn't want it the way I just did it. Let's do this as a actual regular function, like so. Function takes an element, and then there's the body of it. That looks good to me. I'm going to drop a semicolon here. That's not it either. Wow, this one is confusing. What do they want here? Function display, that's what we have. Available airplanes that for each function element. This is the same thing. I'll copy this in. Let's see what we did wrong. Run. No, that's not working either. Maybe they don't want a fat arrow function. Let's assume they don't want a fat arrow function, and write function display staff status. Yeah, I guess they didn't want a fat arrow function, or maybe I was doing something else wrong that I didn't even notice. But this one works, so let's move on to number 5. Within the display staff status function, use console.log to output the element's name. We'll add more in the next step. Okay, so display staff status, we need to get the element's name. So in here, console.log element.name. Let's run that. That one works. 6. Continuing within the display staff status function, modify the console.log statement to output element name plus meets staff requirements plus true or false. So I started to do this all kind of in line, and I know that it was getting ugly, it was hard to read, and I didn't want to make it ugly and hard to read for everyone. So I'm going to do it one more time, but I'm not going to do it in line like I did. I'm going to make a const that is equal to the meets staff requirements, and we're going to pass into there element dot available staff, comma to flight requirements dot required staff. Okay, so that should, well, what I call it, I'll call it Boolean. I'll just call it bool, because it's a Boolean value, either true or false, and that is going to equal either true or false there. So we'll store the answer in this const called bool, and then we will console log all of this. And I'll do this with backticks. So we'll backtick and element dot name, and it goes to meet staff requirements with a space, and then we want our true or false, which we listed as bool, and let's make sure we interpolate that string. Okay, well, let's see if that works for us. Let's run it. And for some reason, we're frozen. Okay, let me You know, I'll copy this little piece of code here at the end. Copy that guy, just in case it's not there anymore. I'll restart it. Okay, I'm glad I copied it. Let's paste it in and run. See what happens. Nope, we fail there. Did you write a console log statement to log the element's name to the console and whether it meets staff requirements? I thought that I did. Let me actually, outside of this, display staff status. And let's call that and actually see what gets printed. Oh, it says I spelled flight requirements wrong. That would definitely be why this is not working. Okay, let me grab this, put it in flight requirements, and run that again. And that did work. Aerojet meets staff requirements, and that, and then either true or false. That is what's coming out here, but they're grading us with a X, so they're saying it's not what's coming out. I'm going to guess that they want us to do it with the plus sign string interpolation, but either should be valid. Let's get their hint again. Console.log element.name, which is the first thing we did right here. Element.name meets staff requirements, and then they wanted to do the meet staff requirements in the plus right there. Okay, so I think you see maybe they didn't like that I did this, but I mean, it sure does work. Let me just try replacing that. I think this looks pretty ugly when we do it this way. Okay, I'll get rid of the bool. Let's see if they allow that. We'll run it again. And it works again, but it says no again. Well, let's copy their exact answer. That's what I'm going to do now and see if that passes, because we're getting to the point where we're getting the required statement there. Let's run that. Did that pass? That passed, and it says exactly the same thing. Okay, let's just say that didn't work for reasons. We'll go down to call the display staff status function. I've been doing that already because we had no idea what was coming out. We didn't know what was wrong, so I've been displaying it already. We just have to run it one more time. There it is, and we can go to the next lesson. Export named exports. Named exports are also distinct in that they can be exported as soon as they are declared by placing the keyword export in front of variable declarations. In menu.js, export let specialty equal empty string. Export function is vegetarian is empty. Function is low sodium is an empty function as well. 1. The export keyword allows us to export objects upon declaration, as shown in export let specialty and export function is vegetarian. 2. We no longer need an export statement at the bottom of our file, since this behavior is handled above. Instructions. 1. Let's add some additional data to our airplane.js file. Continue by adding more data to objects within the available airplanes variable. There you are, you're the entirety of this. So what are we putting in? We're going to the first object, Aerojet, add a property max speed, and its value is 1200. That's Aerojet, it's this one. Okay, so you have your available staff, and we'll comment to a property called the max speed, and they said 1200. It also is getting a property min speed with the value 300. Min speed 300. Great. To the second object, Skyjet, add a property max speed with a value of 800 and a property min speed with a value of 200. Okay, so we're doing another max speed, min speed just right here. after available staff, comma, and max speed, min speed. The max was 800, the min was 200. Let's run that. Great. To the next one, number 2. Within the flight requirements object, add a property required speed range and set this equal to 700. Okay, required speed range is in flight requirements. That's right here. Required speed range 700. And run that. Three, continuing with the same file, add a new function meets speed range requirements that takes 3 arguments: max speed, min speed, and required speed range. Okay, so there's our function. I'll do that after, I'll just do that at the end here after this one. So const read requirements, and let's try an arrow function, see if they allow it. It's going to take 3 arguments: max speed, min speed, and required speed range. Let's run that. All right, that worked. 4. Within the meets speed range requirements function, create a variable range and set it to the difference between max speed and min speed. Okay. So we'll do a const of range, which is equal to max speed minus min speed. And that should just work. Let's run that. No, you create a variable range and set it equal to the difference between max speed and min speed. I made a const named range and set it equal to, oh no, max speed. That's definitely my fault that time. Or maybe it's not. Max speed, min speed. Maybe they want a var. Let's see if that's it. Var. No. Okay. Let's go back to the const and let's change this to function. And it's no longer a fat arrow function. We'll do it like that. And there'll be no more arrow. Let's try that. Okay, let's guess on maybe the semicolon. Let's try that. That's it. Okay. Number 5. In the body of the meets speed range requirements function, create logic to check if the range is greater than the required speed range. The function should contain this logic. If the range is greater than the required speed range, return true, else return false. So we will say if range greater than or equal to required speed range, that will be return true. Then we'll make our else after that. We'll put it in brackets and return false. Let's try that out. Oops, the test returned. Okay, so we did have an error here. It's probably a typo. I see a typo. This can't be 2 of them. And actually, wasn't it just, it's just greater. So it's not greater than or equal to. That was wrong either way. That was going to return poorly either way. Return true, and let's do our semicolons as well. They've been sticklers for semicolons. Let's run it. All right, we got that one. Let's move on to number 6. Use export to export the variables as soon as they are declared, and remove the export statement at the bottom of the file. Okay, export statement at the bottom of the file has 3 things in it. Available airplanes. Where are you? Okay, so export let available airplanes. The next one was Flight requirements. Let's find flight requirements. Export flight requirements. Meets staff requirements. That's this one. Export const meets staff requirements. And then they want to remove this export statement. Let's run that. Did you exports meets speed range requirements? All right, well, let's do that too. Export function meets speed range requirements. There we go. Next. Import named imports. To import variables that are declared, we simply use the original syntax that describes the variable name. In other words, exporting upon declaration does not have an impact on how we import the variables. Import, and then in curly braces, specialty, comma, is vegetarian from menu. Instructions. Add meets speed range requirements to the import statement at the top of the file. Here we go. We'll copy that and comma to it and run. 2. Define a function. Display speed range status. We'll do that at the end. And I'm going to do it as a normal function now. Display speed range status. Like so, and run that. Within the display speed range status function, use the for each method to iterate over each element in the available airplanes array. Again, the for each should take a function as a parameter. This function should take element as a parameter. Okay, so we're going to have a for each. For each, and we're taking in our for each a available airplanes dot for each, and it takes element as a parameter. Let's do it as let's do this as a function as well, like so, and element. Inside there, we're going to iterate over every element in each. And inside there, we're going to do nothing so far. This is just to make this function. Let's just run this. And we have an error here. Did we pass function as a, we pass it as a parameter. Oh, that's interesting. All right, let me move this back a bit. There's a space in element. Let's run that. They're allowing that. Great, that works perfectly. Let's go now to for. Within the display speed range status function, use console.log to output the element's name. Okay, so here, console.log element.name. Let's run that. And did you write console.log statement and the element's name to the console? Yeah, I did. Maybe you have to put my semicolon in. No, I don't think they wanted that semicolon. Let's try a semicolon that ends this as well. Run that. Wow, these semicolons causing issues for people who are taking their first JavaScript course is a very poor way to teach this. It's probably scaring people away. That's not how real programming works. Don't worry about this. I really hope this doesn't make you feel like programming is going to be real tough. It's nothing like this. This is over the top on how poorly this treats your writing. So don't worry much about this. This is teaching us a lot. We're learning all about these different types of imports and stuff like that. So don't give up. Follow along with me. I'll get you through this. I will finish this with you. So just follow along with me. We'll get through this part. And it seems like each one of these parts are written by probably different people. Because some of them respond very well, and this one is incredibly strict. And it's making it so that you have to know where, you have to do it in the syntax that they want it to be in, and, you know, with the semicolons exactly where they should be, where that's usually auto completed for you and done. So please don't make this, don't let this scare you at all. Let's keep going with number 5. Continue within the display speed range status function. Modify the console.log statement to output a statement like this: element name plus meets speed range requirements plus true/false. To do this, we can call the meet speed range requirements method, passing the 3 parameters: element.maxSpeed, element.minSpeed, and flight requirements.requiredSpeedRange. Okay, we can do that, and let's remember to do it in their very, very strict way where they want the plus signs and everything as well. Okay, so we'll console.log, well, it's starting with element.name plus single quote meets speed range requirements and a space there, and then plus the statement that's going to return a true or false for us here. So let's do that: meets speed range requirements. And that should take element and then dot max speed, comma, element dot min speed, comma, and then this entire thing. That's a very long name, and I might typo it, so I pasted it in there. Let's see if we could do this. Run. Nope, that's not it. Let's log this by running it, seeing if we did anything wrong at all. Okay, yeah, we're just console logging the name, so I have a typo in here for sure. Yeah, right here. We'll get rid of that. We'll put it here at the end so that everything's within the console log, and run that. And ours works. The Aerojet meets it, Skyjet. Oh no, here are the range requirements. Yeah, it does work. Did I miss anything? I missed these 2 dots. Okay. Requirements, 2 dots, run. That works. Okay, great. Number 6, call the display speed range status function. I did that already, so we could check our stuff, and there it is. Next lesson. Export as. Named exports also conveniently offer a way to change the name of variables when we export or import them. We can do this with the as keyword. Let's see how this works in our menu.js example. Let specialty equal empty string. Let vegetarian equals a function. Let's just go to the export at the end here. Okay, so export, and they open their curly braces, and they're exporting specialty as chef's specialty. They export is vegetarian as is veg, and is low sodium does not get an as. In the above example, take a look at the export statement at the bottom of the file. Let's just keep that in there. 1. The as keyword allows us to give a variable name an alias as demonstrated in specialty as chef specialty and is vegetarian as is veg. 2. Since we did not give is low sodium an alias, it will maintain its original name. Instructions. 1. Remove the keyword export in front of each variable name since we will no longer need it. Okay, so everywhere it says export. Cool trick for this, press Command D or probably Control D if you're on a PC, and this will pass in all the exports, and just press delete, and then go forward 1, back 1 more, and you should be in good shape there. Let's run that. Okay. 2. Add an export statement that export the available airplane object as aircraft. Okay, they have several of these. Let's do them one at a time. I'm going to head to the bottom, write export, open up my curly braces, and take the first one. available airplane will export as aircraft, all lowercase, aircraft, comma. The next one is flight requirements, okay? And we're gonna do that as flight recs with an S. The meet staff requirements, and that's gonna be meet staff recs, the same type of thing. So as for recs, and meets range requirements, we'll comment to that as meets range rec with an S at the end. Let's see if we did that correctly. Did you export each variable as its alias? Let's see. Available airplanes as aircrafts. Ah, there's an S. There's an S right here. That's probably it. Let's run that. Nope. Now, what could we be doing wrong here? I'm gonna guess it's one of these again. Let's just toss that at the end. And that's it, yet again. All right, let's go to the next lesson. Import as. To import named export aliases with the as keyword, we add the aliased variable in our import statement. Import, curly braces, chef special, comma, is veg, from /menu. In order.js, 1, we import chef's special and is veg from the menu object. 2, here note that we have an option to alias an object that was not previously aliased when exported. For example, the is low sodium object that we exported could be aliased with the as keyword when imported. Import, curly braces, is low sodium as salt-free from menu. Another way of using aliases is to import the entire module as an alias. Import asterisk or star as carte from /menu. Carte.chefspecial, carte.isveg, carte.isLowSodium. 1. This allows us to import an entire module from menu.js as an alias, carte. 2. In this example, whatever name we exported would be available to us as properties of the module. For example, if we exported the aliases chef's special and is veg, these would be available to us. If we did not give an alias to is low sodium, we would call it as defined on the carte module. Instructions. Number 1. Within the body of missioncontrol.js, change each variable to its alias with the exception of the variable in the import statement. In the body, change available airplanes to aircrafts. Okay, where are you? Available airplanes. I'm doing the command D thing again here. Available airplanes are now aircrafts. Flight requirements are now flight recs. Where's that first come in? Okay, so this is the first one. We'll paste over those. Flight recs. Meet staff requirement, meet staff recs. Where's the first one? Okay, right here. Yep, that's the only one in the body. Paste over that one. And meet speed range requirements will be meet speed range recs. So let's find the first one. There looks to be only one. All right, let's run that. We did it. Let's move on to the second question. So now modify the import statement to import the exact thing that we just did. We could have done that at the same time. Okay, so we'll do aircrafts, flight recs, meet staff recs, meet staff recs, meet speed range recs. Okay, and run that. Good, let's move on to the next lesson. Combining export statements. We can also use named exports and default exports together. In menu.js, they have let specialty equal, and that's all the same. Let's go to exports. So export opens up a curly brace, specialty as chef special, is vegetarian as is veg, and they close that curly brace. Now export default is gluten-free. Now there's a default export and an export of all these named things as well that are being renamed with the as keyword. Here we use the keyword export to export the named exports at the bottom of the file. Meanwhile, we export the isGlutenFree variable using the export default syntax. This would also work if we exported most of the variables as declared and exported others with the export default syntax. And it seems to be the same exact thing, except they're doing now the single exports in line. So export let menu equal empty object, and so on. Here we use the export keyword to export the variables upon declaration, and again export the isGlutenFree variable using the export default syntax. While it's better to avoid combining two methods of exporting, it is useful on occasion. For example, if you suspect developers may only be interested in importing a specific function and won't need to import the entire default export. Instructions. 1. In airplane.js, use the export keyword to export available airplanes, flight requirements, and meets staff requirements as soon as they are declared. Okay, we're going to export you here. Export flight requirements is exported. Meets staff requirements, they want that exported. And meets staff requirements, that's the meet speed range requirements. I think that's all three. Okay, let's run that. 2. Use export default to export meets speed range requirements. Okay, so at the end, I can't imagine they want this. I'm just going to comment this out in case they want this here. Okay, export default meets speed. Let me copy this. Requirements, and I'm going to put a semicolon at the end of that. We'll run it. Great, let's move on to the next lesson. Combining import statements. We can import the collection of objects and functions with the same data. We can use the import keyword to import both types of variables as such. Import, curly braces, specialty is vegetarian is sodium from /menu, import gluten-free from .menu. Instructions. 1. Remove the import statement at the top of missioncontrol.js. Once you have removed import, change each variable to its original, unaliased name within the rest of the file. Okay, so we're going to now redo what we just did. Now, everywhere it says aircrafts, paste that in. Everywhere it says flight recs, we'll paste that in. Everywhere it says meet staff recs, all the copies, paste that in. And everywhere it says meet speed recs, paste that in, and let's run it. No. I commented out the statement, so it shouldn't be working. I'm just going to remove it. Who knows if they want this to be on the first line? Let's run it. Okay, they wanted it just removed. At the top of the file, we'll now import all variables from the module. Use import to import available airplanes, flight requirements, and meets staff requirements between a set of curly braces. Import, get the curly braces out, and I know I have, no, I didn't have that one. Okay, so we'll take these first two, paste them in there, and this last one. from, and I think this was /airplane. Pretty sure. Let's go ahead and run that. Oh, I didn't do the second part of it. Import meets speed requirements. Okay. I'll put that here, and then we will import meet speed requirements from /airplane and semicolon as well, and run. Great, that worked, and we'll move on to the next lesson. Review. We just learned how to use JavaScript modules. Let's review what we learned. Modules in Node.js are reusable pieces of code that can be exported from one program and imported for use in another program. Module.exports exports the module for use in another program. Require imports the module for use in the current program. ES6 introduced a more flexible, easier syntax to export modules. Default exports use export default to export JavaScript objects, functions, and primitive data types. Named exports use the export keyword to export data in variables. Named exports can be aliased with the as keyword. Import is a keyword that imports any object, function, or data. Let's see what's up next. JavaScript promises. Introduction. In web development, asynchronous programming is notorious for being a challenging topic. An asynchronous operation is one that allows the computer to move on to other tasks while waiting for the asynchronous operation to complete. Asynchronous programming means that time-consuming operations don't have to bring everything else in our programs to a halt. There are countless examples of asynchronicity in our everyday lives. Cleaning our house, for example, involves asynchronous operations such as a dishwasher washing our dishes or a washing machine washing our clothes. While we wait on the completion of those operations, we're free to do other chores. Similarly, web development makes use of asynchronous operations. Operations like making a network request or querying a database can be time-consuming, but JavaScript allows us to execute other tasks while awaiting their completion. This lesson will teach you how modern JavaScript handles asynchronicity using the promise object, introduced with ES6. Let's get started. What is a promise? Promises are objects that represent the eventual outcome of an asynchronous operation. A promise object can be in one of three states. One would be pending, the initial state. The operation has not yet completed. Another would be fulfilled. The operation has completed successfully, and the promise now has a resolved value. For example, a request promise might resolve with a JSON object as its value. And a third one is rejected. The operation has failed and the promise has a reason for the failure. This reason is usually an error of some kind. We refer to a promise as settled if it is no longer pending. It is either fulfilled or rejected. Let's think of a dishwasher as having the states of a promise. It would have a pending state. The dishwasher is running but has not completed the washing cycle. A fulfilled state. The dishwasher has completed the washing cycle and is full of clean dishes. The rejected state. The dishwasher encountered a problem. It didn't receive soap and returns unclean dishes. If our dishwashing promise is fulfilled, we'll be able to perform related tasks, such as unloading the clean dishes from the dishwasher. If it's rejected, we can take alternative steps, such as running it again with soap or washing the dishes by hand. All promises eventually settle, enabling us to write logic for what to do if the promise fulfills or if it rejects. instructions. Observe the diagram on the right. Here we illustrate the different possible states of a dishwashing promise. And it is just showing exactly what it said. The error for no soap, and that's the rejected, and the resolve is the clean dishes one. Let's move on to the next lesson. Constructing a promise object. Let's construct a promise. To create a new promise object, we use the new keyword and the promise constructor method. Const executor function equals resolve, reject, fat arrow function to a body, but there's nothing in it yet. And then there's const my first promise equals new promise, and it passes in the executor function. The promise constructor method takes a function parameter called the executor function, which runs automatically when the constructor is called. The executor function generally starts an asynchronous operation and dictates how the promise should be settled. The executor function has two function parameters, usually referred to as the resolve and reject functions. The resolve and reject functions aren't defined by the programmer. When the promise constructor runs, JavaScript will pass its own resolve and reject functions into the executor function. Resolve is a function with one argument. Under the hood, if invoked, resolve will change the promise's status from pending to fulfilled, and the promise's resolved value will be set to the argument passed into resolve. Reject is a function that takes a reason or error as an argument. Under the hood, if invoked, reject will change the promise's status from pending to rejected, and the promise's rejection reason will be set to the argument passed into reject. Let's look at an example executor function in a promise constructor. Const executor function equals resolve reject fat arrow function. It opens up a conditional with an if. The if has some condition in it, and in its body it says resolve, and in the resolve parentheses there is I resolved. There's an else to this as well, and it has a reject. And in the reject parentheses, it says I rejected. At the end, const my first promise equals new promise with the executor function put into the promise. Let's break down what's happening above. We declare a variable, my first promise. My first promise is constructed using new promise, which is the promise constructor method. Executor function is passed to the constructor and has two functions as parameters, resolve and reject. If some condition evaluates to true, we invoke resolve with the string I resolved. If not, we invoke reject with the string I rejected. In our example, my first promise resolves or rejects based on a simple condition, but in practice, promises settle based on the result of asynchronous operations. For example, a database request may fulfill with the data from a query or reject with an error thrown. In this exercise, we'll construct promises and resolve synchronously to more easily understand how they work. Instructions. 1. You'll be writing your code in the code editor, but we won't be running it until the final step. To check your code for a step, you can press the check work button. And we can see that in the bottom right here. We're going to create a promise representing ordering sunglasses from an online store. First, create this function, myExecutor. Later on, you'll pass this function into the promise constructor. MyExecutor should have two parameters, resolve and reject. Okay, so let's make a const called myExecutor, and it takes resolve, the full word, right? Yes, resolve, comma, reject. Then we'll do our fat arrow and open this up. Check if the sunglasses property on the inventory object has a value greater than 0. Okay, so if inventory.sunglasses, all undercase, and is greater than 0. Okay, so if they have any inventory of sunglasses, if it does, my executor should invoke resolve with the string sunglasses order processed. Okay, I'll copy that string. And then we want to write resolve and open up that and put that string in there. And the next one is, if it does not, my executor should invoke reject with the string that item is sold out. So let's grab that. Else reject. Oh, I already had the quotes. There we go. That item is sold out. When you're ready, press the check work button. Okay, check work. That worked. Great. We'll go to the next one. Create a function. Order sunglasses. This function should have no parameters. It should return a new promise constructed by passing your myExecutor function into the promise constructor. All right, so they want a function. Let's do another fat arrow function. So const order sunglasses is the name of it. That will equal, just invoke it with nothing in there. They said pass no parameters, and it needs to return a new promise, and then we need to pass into the myExecutor. I keep on calling that executor. Executor. Here we go. And let's see if that's what they wanted with check work here. That's it. Create a variable order promise assigned to the returned value of your order sunglasses function. Okay, so we will make a const order promise, and that is going to equal order sunglasses invoked. I think that's what they're asking for there. Let's try checking that work. That worked. Okay. Number 4, at the bottom of your app.js file, log order promise to the console. Console.log, and we just need to put that in there. Let's check the work. Great. In this exercise and throughout the lesson, we'll provide you with a bash terminal to execute your code. To run the app.js program, you'll type node app.js in the terminal and hit enter or return. You'll be able to see the output of the program in the terminal. Let's try it. Type node app.js in the terminal and hit enter. Node app.js, enter. I see a promise, and inside the object is sunglasses order processed. If you'd like, you can see an alternate output by changing the sunglasses property in the inventory object to 0 and executing app.js from the terminal again. When you're ready to move on, press check work. Okay, let's do that last one, and we wanted sunglasses to now be 0, and then check work again. Okay, we look good there. Let's move on to the next lesson. The node setTimeout function. Knowing how to construct a promise is useful, but most of the time, knowing how to consume or use promises will be key. Rather than constructing promises, you'll be handling promise objects returned to you as the result of an asynchronous operation. These promises will start off pending but settle eventually. Moving forward, we'll be simulating this by providing you with functions that return promises, which settle after some time. To accomplish this, we'll be using setTimeout. setTimeout is a Node API, parentheses, a comparable API is provided by web browsers, that uses callback functions to schedule tasks to be performed after a delay. setTimeout has 2 parameters, a callback function and a delay in milliseconds. Const delayed hello equals an empty fat arrow function, and the body of it has a console.log saying, hi, this is an asynchronous greeting, and a setTimeout below it taking in delayed hello and 2,000 milliseconds. Here we invoke setTimeout with the callback function delayedHello and 2000. In at least 2 seconds, delayedHello will be invoked. But why is it at least 2 seconds and not exactly 2 seconds? This delay is performed asynchronously. The rest of our program won't stop executing during the delay. Asynchronous JavaScript uses something called the event loop. After 2 seconds, delayedHello is added to a line of code waiting to be run. Before it can run, any synchronous code from the program will run. Next, any code in front of it in the line will run. This means it might be more than 2 seconds before delayedHello is actually executed. Let's look at how we'll be using setTimeout to construct asynchronous promises. Const return promise function equals a fat arrow function, and in the body there is return new promise. Resolve reject are the arguments. It's a fat arrow again. In the body of that is setTimeout. The resolve is I resolved, and there is 1000 milliseconds passed into that. Then we have const prom equals return promise function. In the example code, we invoke return promise function, which returned a promise. We assign that promise to the variable prom. Similar to asynchronous promises you may encounter in production, prom will initially have a status of pending. Let's explore setTimeout a bit more. Instructions. 1. Create a function using STO. Your using STO function should have no parameters. Inside the function body, it should print a string to the console. This can be any string you want, as long as it's not either this is the first line of synchronous code or this is the last line of synchronous code. Check your work to move on to the next step. Okay. So we're supposed to write our code below this, it says, and we need to create a function using STO. And here's our fat arrow function. And the body just needs to console.log anything we want. I'm going to write async code here. So I imagine this is where we'll do our async code. Let's check that out. No, that's wrong. Oh, that's ST and O are all capital, so that's on me. There we go. Number 2. Now let's invoke the setTimeout function. Remember, setTimeout has 2 parameters. Invoke setTimeout with your using STO function as the first argument and a number between 0 and 3000 as the second argument. So we'll use that setTimeout. And let's see exactly how it works. Okay, I'm doing this improperly because we already have the function. I didn't think of that. Okay, so we already have the function here. We just need to pass them in. So using STO, and we know that we can't invoke it, and then we'll comma with 1000, and that's going to be what I think we have to do here. Let's check that out. Yep, that's it. 3. Take a moment to predict the output of this program. Whenever you're ready, type node app.js in the terminal and hit enter. See if the program's output in the terminal lines up with what you expected. Well, I expect this to be the last piece that is executed because it has 1000 milliseconds, so it's going to wait here. And yeah, that's going to be my guess. Let's check the work. Oh, I didn't run the node.js command. So that was node app.js. This is the first line of code in app.js. This is the last line of code in app.js. So it didn't run at all, but then again, it wasn't called anywhere. So it shouldn't really run. Okay, let's go to the next lesson. Consuming promises. The initial state of an asynchronous promise is pending, but we have a guarantee that it will settle. How do we tell the computer what should happen then? Promise objects come with an aptly named .then method. It allows us to say, I have a promise, when it settles, then here's what I want to happen. In the case of our dishwasher promise, the dishwasher will run then. If our promise rejects, this means we have dirty dishes, and we'll add soap and run the dishwasher again. If our promise fulfills, this means we have clean dishes, and we'll put the dishes away. .then is a higher order function. It takes two callback functions as arguments. We refer to these callbacks as handlers. When the promise settles, the appropriate handler will be invoked with that settled value. The first handler, sometimes called onFulfilled, is a success handler, and it should contain the logic for the promise resolving. The second handler, sometimes called onRejected, is a failure handler, and it should contain the logic for the promise rejecting. We can invoke .then with one, both, or neither handler. This allows for flexibility, but it can also make it for tricky debugging. If the appropriate handler is not provided, instead of throwing an error, .then will just return a promise with the same settled value as the promise it was called on. One important feature of .then is that it always returns a promise. We'll return to this in more detail in a later exercise and explore why that's so important. And we can move on to the next lesson. To handle a successful promise or a promise that resolved, we invoke .then on the promise, passing in a success handler callback function. Const prom equals new promise. Resolve and reject are the arguments. We fat arrow to resolve containing yay. Const handle success equals resolved value as an argument. We fat arrow to console.log resolved value. Prom.then handle success prints yay. Let's break down what's happening in the example code. Prom is a promise which will resolve to yay. We define a function, handleSuccess, which prints the argument passed to it. We invoke proms.then function, passing in our handleSuccess function. Since prom resolves, handleSuccess is invoked with prom's resolve value, yay, so yay is logged to the console. With typical promise consumption, we won't know whether a promise will resolve or reject, so we'll need to provide the logic for either case. We can pass both an onFulfilled and onRejected callback to .then. Let prom equal new promise, resolve and reject are the arguments. The fat arrow function points to let num equal math.random. If num is less than 0.5, resolve with yay, else reject with oh no. Const handleSuccess equals resolved value, and that prints out resolved value. Const handle failure equals rejection reason, and that prints out rejection reason. Prom.then handleSuccess, handle failure. Let's break down what's happening in the example code. Prom is a promise, which will randomly either resolve with yay or reject with oh no. We pass two handler functions to .then. The first will be invoked with yay if the promise resolves, and the second will be invoked with oh no if the promise rejects. Let's write some onFulfilled and onRejected functions. Instructions. 1. Take a look at the provided code. We require, in a function, check inventory. It builds on the logic of the order sunglasses function you wrote in a previous exercise. Check inventory takes in an array representing an order and returns a promise. If every item in the order is in stock, that promise resolves with the value, thank you, your order was successful. Otherwise, the promise rejects with the value, we're sorry, your order could not be completed because some items are sold out. We used setTimeout to ensure that the check inventory promise settles asynchronously. If you'd like, look at the library.js file to see how it works. Press check work when you're ready to move on. We could look at that library file real quick. That's this right here. Oh, okay, so the check inventory is going to take an order. It's going to build a promise, and it has a set time out right here. It's going to let inStock equal order.every, so it'll go through every order and compare them. And then if in stock, resolve thank you, your order was successful, or else reject it with the rejected statement and wait 1 second for this to happen. Then module.exports, check inventory, and that's what we're bringing in. Okay, great. Let's check work. Write a function handle success. You'll use this function later on as your success handler. Handle success should have one parameter representing a resolved value. Inside the body of handle success, log the parameter to the console. Okay, so we're going to have a cons called handle success. And there was one parameter in here. It'll just be res, it'll represent the resolved value. And inside the body, we need to console.log the parameter res. Let's check that work. That looks good. On to number 3. Write a function handle failure. You'll use this function later on as your failure handler. Handle failure should have one parameter representing a rejection reason. Inside the body of handle failure, log the parameter to the console. Okay, so we'll have a const named handle failure, and that will have, we could call it rej for reject, and console.log rj. Check that work. Good, let's go to number 4. Invoke check inventory with order. This will return a promise. Attach a .then function to this. Pass into .then the 2 handlers you wrote as callback functions. Okay, we need to invoke check inventory. So check inventory. We're going to invoke that with order. That's right up here. Okay, so we invoke with order passed in here, and then we want to chain a .then to that. And inside our .then, we will put our handle success, comma, handle failure. And let's see if we did that properly. Check work. Oh, you know, I'm doing this slightly improperly. We should do the check inventory like so. And then the .then should come after this. Okay, so that's what we're waiting for there. Okay, that was a mistake. Let's check the work. Yes, that's right. Type node app.js in the terminal and hit enter. Node app.js. Thank you, your order was successful. Let's check that work. We are good to move on to the next lesson. Using catch with promises. One way to write cleaner code is to follow a principle called separation of concerns. Separation of concerns means organizing code into distinct sections, each handling a specific task. It enables us to quickly navigate our code and know where to look if something isn't working. Remember, .then will return a promise with the same settled value as the promise it was called on, if no appropriate handler was provided. This implementation allows us to separate our resolved logic from our rejected logic. Instead of passing both handlers into one .then, we can chain a second .then with a failure handler to the first .then, with a success handler, and both cases will be handled. Let's see that in action because that was a difficult sentence there. Okay, so it has prom.then, resolved value, and a fat hour function that console.logs resolved value. And after that, there's another .then. It takes null, comma, rejection reason. and that fat arrow functions to a console.log of rejection reason. Okay. Since JavaScript doesn't mind whitespace, we follow a common convention of putting each part of this chain in a new line to make it easier to read. To create even more readable code, we can use a different promise function, .catch. The .catch function takes only one argument, onRejected. In the case of a rejected promise, this failure handler will be invoked with the reason for rejection. Using .catch accomplishes the same thing as using a .then with only a failure handler. Let's look at an example using .catch. Prom.then resolved value, a fat arrow function to console.log resolved value. After that is a .catch. Rejection reason, fat arrow function, console.log the rejection reason. Let's break down what's happening in the example code. Prom is a promise which randomly either resolves with yay or rejects with oh no. We pass a success handler to .then and a failure handler to .catch. If the promise resolves, .then's success handler will be invoked with yay. If the promise rejects, .then will return a promise with the same rejection reason as the original promise, and .catch's failure handler will be invoked with that rejection reason. Let's practice writing .catch functions. 1. We're going to refactor the functionality of the previous exercise, but this time we'll use .catch. First, invoke the checkInventory function with the order. Remember, this function will return a promise. We'll write your code below here. So they want us to invoke checkInventory and put in order. And that looks like that's all they want us to do so far. Let's just do that. Okay. 2, add a .then to the returned promise, pass in the success handler, handle success. Okay, so we want a .then and then handle success. And we could check that work. Great. Add a .catch to the returned promise. Pass in the failure handler, handle failure. Okay, so .catch handle failure. And let's check that work. That works. Number 4. We set our inventory of sunglasses to 0, so the order shouldn't go through. Let's make sure our code has the expected results. Type node app.js in the terminal and hit enter. So node app.js, enter. We're sorry, your order could not be completed because some items were sold out. Let's check that work. We are good to go on to the next lesson. Chaining multiple promises. One common pattern we'll see with asynchronous programming is multiple operations which depend on each other to execute or that must be executed in a certain order. We might make one request to a database and use the data returned to us to make another request and so on. Let's illustrate this with another cleaning example, washing clothes. We take our dirty clothes and put them in the washing machine. If the clothes are cleaned, then we'll want to put them in the dryer. After the dryer runs, if the clothes are dry, then we can fold them and put them away. This process of chaining promises together is called composition. Promises are designed with composition in mind. Here's a simple promise chain in code. Okay, here is the promise chain. First promise function, .then, first resolve val and a fat arrow function, return. Second promise function is invoked and inside of there is first resolved val. Now after all of this is .then, second resolved val, a fat arrow, and console.log second resolve val. Let's break down what's happening in the example. We invoke a function, first promise function, which returns a promise. We invoke .then with an anonymous function as the success handler. Inside the success handler, we return a new promise, the result of invoking a second function, secondPromise function, with the first promise's resolved value. We invoke a second .then to handle the logic for the second promise settling. Inside that .then, we have a success handler, which will log the second promise's resolved value to the console. In order for our chain to work properly, we had to return the promise secondPromise function first resolve val. This ensured that the return value of the first .then was our second promise rather than the default return of a new promise with the same settled value as the initial. Let's write some promise chains. Instructions. Take a look at the provided code. We require in 3 functions: check inventory, process payment, ship order. These functions each return a promise. Check inventory expects an order argument and returns a promise. If there are enough items in stock to fill the order, the promise will resolve to an array. The first element in the resolved value array will be the same order, and the second element will be the total cost of the order as a number. Process payment expects an array argument with the order as the first element and the purchase total as the second. This function returns a promise. If there is a large enough balance on the gift card associated with the order, it will resolve to an array. The first element in the resolved value array will be the same order, and the second element will be a tracking number. Ship order expects an array argument with the order as the first element and a tracking number as the second. It returns a promise which resolves to a string confirming the order has shipped. If you'd like, look at the library.js file to see how these functions work. Press check work when you're ready to move on to the next checkpoint. Okay, let's check work 2. We set up a promise chain, but it's missing a couple important lines of code to make it function properly. We invoked check inventory with order and chained a .then function to it. This .then has an anonymous function as its success handler, but it's missing a return statement. The success handler should return a process payment promise. All right, let's do our return here. So return, and it was process payment. And let's try that out. I see we need to pass in that value. So that process payment, what was that? Okay, it expects an array argument with the order as the first element, and and this returns the same order, and the second element will be the total cost, and that's what it wants as the second thing, I imagine. Okay, so we're going to pass in just the resolved value array right into here. That's what they're asking for, I'm pretty sure. Let's take a look. Yep, that does that. Let's move on to number 3. We have a second .then function on the chain. This .then also has an anonymous function as its success handler and is missing a return statement. The success handler should return a ship order promise. Okay, so this is the second .then. We want to return a ship order. Now, ship order is most likely going to take in this resolved value array. So we could push that right in there and give that a shot. That works. Type node app.js in the terminal and hit enter. Node app.js, enter. All of the items are in stock. The total cost of the order is $35.97. The payment processed with gift card, generating shipping label. The order has been shipped. The tracking number is 727157. Let's check the work and move on to the next lesson. Avoiding common mistakes. Promise composition allows for much more readable code than the nested callback syntax that preceded it. However, it can still be easy to make mistakes. In this exercise, we'll go over 2 common mistakes with promise composition. Mistake 1, nesting promises instead of chaining them. Returns first promise dot then first resolve. Okay, what they're trying to show is that we're putting dot then, and this is getting bigger and bigger. Let's break down what's happening above here. Okay. We invoke returns first promise, which returns a promise. We invoke dot then with a success handler. Inside the success handler, we invoke returns second value with first resolve val, which will return a new promise. We invoke a second dot then to handle the logic for the second promise settling all inside the first dot then. Inside that second dot then, we have a success handler which will log the second promise's resolve value to the console. Instead of having a clean chain of promises, we've nested the logic for one inside the logic of the other. Imagine if we were handling 5 or 10 promises. Mistake 2, forgetting to return a promise. Let's break down what's happening in this example where we have the console.log here. Okay. We invoke returns first promise, which returns a promise. Then we invoke .then with a success handler. Inside the success handler, we create our second promise, but we forget to return it. We invoke a second .then. It's supposed to handle the logic for the second promise. But since we didn't return, this .then is invoked on a promise with the same settled value as the original promise. Since forgetting to return our promise won't throw an error, this can be a really tricky thing to debug. Instructions. The code in app.js works correctly, but it doesn't follow best practices. Type node app.js in the terminal and hit enter so you can see what the program outputs. Node app.js, enter. And this is exactly what we saw last time. And I guess we could just press check work to move on. Okay. 2, refactor or rewrite the code to avoid the 2 common mistakes, nesting and forgetting to return properly. So this one doesn't really return in any place. These are just, it's the nesting that it's doing that's letting everything happen. So, all right, let's work on it. Where does this end? This ends at the end where it really should be ending right here. And we need to return this right here. So this next dot then should be pinned onto the end of this. So that dot then is over, and this dot then should start. Now this next one, we're going to need to return this again. Return. And we have the pointing function. This ends at the end. That's not what we want. We want to wrap everything that we did up to the dot then. And take out that dot then as well. And then this would come here. And I don't think we need to return the console log, so that one should work pretty much properly. And it's closed right there. And now these guys do nothing. All right, let me see if I understood that correctly. It's kind of hard to look at without like a nice prettier extension or something to make it look nice for you. But let's see if that works. Yeah, that's what they wanted. Okay, great. We refactored that to look a little better looking for sure. 3, type node app.js in the terminal and hit enter. Make sure your program is still working as expected. Okay, node app.js. Yes, that is working as expected. Let's check that work and go to the next lesson. Using promise.all. When done correctly, promise composition is a great way to handle situations where asynchronous operations depend on each other or execution order matters. What if we're dealing with multiple promises, but we don't care about the order? Let's think in terms of cleaning again. For us to consider our house clean, we need our clothes to dry, our trash bins emptied, and the dishwasher to run. We need all of these tasks to complete, but not in any particular order. Furthermore, since they're all getting done asynchronously, they should really all be happening at the same time. To maximize efficiency, we should use concurrency, multiple asynchronous operations happening together. With promises, we can do this with the function promise.all. Promise.all accepts an array of promises as its argument and returns a single promise. That single promise will settle in one of two ways. If every promise in the argument array resolves, the single promise returned from promise.all will resolve with an array containing the resolve value from each promise in the argument array. If any promise from the argument array rejects, the single promise returned from promise.all will immediately reject with the reason that promise rejected. This behavior is sometimes referred to as failing fast. Let's look at the code example. Let my promises equal promise.all, and inside of promise.all, there is an array. The array contains returns prom1 invoked, returns prom2 invoked, returns prom3 invoked, and the array ends and the function closes. My promises.then array of values, fat arrow function console.log array of values, .catch rejection reason, fat arrow function console.log rejection reason. Let's break down what's happening. We declare my promises assigned to invoking promise.all. We invoke promise.all with an array of 3 promises, the returned values from functions. We invoke .then with a success handler which will print the array of resolved values if each promise resolves successfully. We invoke .catch with a failure handler which will print the first rejection message if any promise rejects. Instructions. 1. Our business is doing so well that we're running low on inventory. We want to reach out to some distributors to see if they have the items we need. We only want to make one restocking order, so we'll only want to place the order if all of the items are available. Take a look at the provided code. We require in one function, check availability. Check availability expects 2 string arguments, an item and a distributor. It returns a promise. The function simulates checking that the given distributor has the given item. 80% of the time, it will resolve the promise with the item, and 20% of the time, it will reject the promise with an error message, stating that the item isn't available. We also provided 2 functions that will serve as success and failure handlers. If you'd like, look at the library.js file to see how these functions work. Press check work when you're ready to move on to the next checkpoint. All right, let's check work, see what we have to do here. 2. Create 3 variables, each assigned to a separate promise. Check sunglasses should be assigned the value returned by invoking check availability with sunglasses as its first argument and favorite supply co as its second argument. Okay, so let's do that. I have a const called check sunglasses. That's going to equal check availability. Wow. And we will invoke that with 2 different strings. One will be sunglasses, and now the next one will be, this is favorite supply co. Just going to copy that in. I don't want to typo anything about it. Favorite supply co. Okay. The next is check pants. Okay. So const check pants equals check availability again, just with different strings. Okay. So let's pop this in here. We have check availability, and the strings are going to be pants and favorite supply co again. Okay, so same company there. Now we need one more, and it's called check bags. I'm just going to take it right from here. Check bags, and it should have bags and favorite supply co again. Okay, so it's going to be favorite supply co each time. Great, let's check that work. That's good. 3. Invoke promise.all with an array containing check sunglasses, check pants, and check bags. Okay, so we saw that like promise.all, and then inside there we saw an array, and it had each one of these in there. So you'd have check sunglasses, then you'd comma to check pants, and then you'd comma to check bags, and if I remember correctly, they're all invoked in here. So invoke them all, and let's check that work. Nope, that's not it. It's likely a syntax error. I'm going to guess that it's not typo or anything. It's just probably not invoked. Check work. Yep, that's it. Don't invoke these in promise.all. Number 4, chain a .then to the promise returned from promise.all. You should pass in onFulfill to serve as the success handler. Okay, so right here we write .then, and inside of here, onFulfill is what we want to pass in as the success handler. So that should be enough. Let's check the work. 5, add a catch to the chain. You should pass in onReject to serve as the failure handler. Okay, so that should be a .catch onReject. That works. Number 6, type node app.js in the terminal and hit enter to execute your program. And we could see checking availabilities everywhere. Sunglasses are in stock, pants are in stock. Oh no, bags are unavailable at this time. Let's check that work and go to the next lesson. Review. Awesome job. Promises are a difficult concept even for experienced developers, so pat yourself on the back. You've learned a ton about asynchronous JavaScript and promises. Let's review. Promises are JavaScript objects that represent the eventual result of an asynchronous operation. Promises can be in one of 3 states: pending, resolved, or rejected. A promise is settled if it is either resolved or rejected. We construct a promise by using the new keyword and passing an executor function to the promise constructor method. setTimeout is a node function which delays the execution of a callback function using the event loop. We use .then with a success handler callback containing the logic for what should happen if a promise resolves. We use .catch with a failure handler callback containing the logic for what should happen if a promise rejects. Promise composition enables us to write complex asynchronous code that's still readable. We do this by chaining multiple .thens and .catches. To use promise composition correctly, we have to remember to return promises constructed within a .then. We should chain multiple promises rather than nesting them. To take advantage of concurrency, we can use promise.all. Let's see what's up next. Async await. Async await. Introduction. Often in web development, we need to handle asynchronous actions, actions we can wait on while moving to other tasks. We make requests to networks, databases, or any number of similar operations. JavaScript is non-blocking. Instead of stopping the execution of code while it waits, JavaScript uses an event loop, which allows it to efficiently execute other tasks while it awaits the completion of these asynchronous actions. Originally, JavaScript used callback functions to handle asynchronous actions. The problem with callbacks is that they encourage complexly nested code, which quickly becomes difficult to read, debug, and scale. With ES6, JavaScript integrated native promises, which allow us to write significantly more readable code. JavaScript is continually improving, and ES8 provides a new syntax for handling our asynchronous actions, async await. The async await syntax allows us to write asynchronous code that reads similarly to traditional synchronous imperative programs. The async await syntax is syntactic sugar. It doesn't introduce new functionality into the language, but rather introduces a new syntax for using promises and generators. Both of these were already built into the language. Despite this, async await powerfully improves the readability and scalability of our code. Let's learn how to use it. Instructions. 1. In this lesson, you'll be given a code editor to write your code and a bash terminal to execute your code. To execute your program, you'll type node app.js in the terminal and hit enter or return. You'll press the check work button to submit your code for evaluation. Check out the code we provided. It shows 3 ways to accomplish the same task: reading and printing from 2 files in a specified order. The first version uses callback functions. The second version uses native promise syntax. The third version uses async await. Let's take a quick look at this. They're importing the file system. Permissified file read is a different file they're requiring here as well. Here we use the file system read file and callback functions. Okay, file system read file. And then it will have error data, and then there's the callback function. Okay, I see what it's doing. It hands the read file method what it wants, and then it passes it this callback here with there can be an error or the data comes, and then it uses either if error throw error, and if not let first sentence equal that data that came back. And then it's going to file system.read file, another file, which has another callback, error data, and let second sentence, and then console log those 2 sentences. Here's the native promises with our promisified version of read file. They have promisified read file, and in the .then, this is exactly how we did it in the last lessons here. So .then, we'd hand pretty much anything we wanted to call it. We're going to call it data. First sentence will equal the data, and then it's going to return the promisified read file and read the second file, do another .then, and the second sentence, and then console log those 2 together. Here we use the permissified read file again, but instead of using the native promise .then syntax, we declare and invoke an async await function. Async function read files. Let first sentence equal await permissified file. Okay, and it passes in the file and the file type. And then let second sentence await permissified file read. And that's your second file and your second file type, which is the same. Then console.log both of them. And this looks absolutely the cleanest. So this is what we'll be learning today. Don't worry about understanding the async await syntax. That's what you'll learn in this session. If you haven't already, type node app.js in the terminal and press enter, then press check work. Node app.js enter. It does the same thing, all of them, and check work. We can go on to the next lesson. The async keyword. The async keyword is used to write functions that handle asynchronous actions. We wrap our asynchronous logic inside a function prepended with the async keyword. Then we invoke that function. Async function myfunc, and then the function body inside here, and then you can invoke myfunc as so. We'll be using async function declarations throughout this lesson, but we can also create async function expressions. Const myfunc equals async, and then it opens and closes parentheses because this is an arrow function and it points to an empty body. Then they invoke myfunc. Async functions always return a promise. This means we can use both traditional promise syntax like .then and .catch with our async functions. An async function will return in one of three ways. If there's nothing returned from the function, it will return a promise with a resolved value of undefined. If there's a non-promise value returned from that function, it will return a promise resolved to that value. If a promise is returned from the function, it will simply return that promise. We have async function 5 promise, and that function's body returns the number 5. Now below that is 5 promise invoked .then resolved value, and an arrow function console.log resolved value will print the number 5. In the example above, even though we returned 5 inside the function body, what's actually returned when we invoke 5 promise is a promise with a resolved value of 5. Let's write an async function. Instructions. 1. We provided a function with constructor which takes in a number. If a number is 0, it returns a promise that resolves to the string 0. If the number is not 0, it returns a promise that resolves to the string not 0. Take a moment to understand this function and the code that follows. When you're ready to run it, type node app.js in the terminal and press enter. So we see here that this is going to take in a number, and if the number triple equals 0, resolve has 0 attached to it, else resolve has not 0 attached to it here. So that's what our promise is doing. We have the resolve reject, and we have no way for this to be rejected inside of here. And with constructor, passes in 0, then it will take the resolve value in a arrow function in console.log with constructor, and what was in there, the number 0, returned a promise which resolved to, and then the resolve value, which in that case should be 0. Node app.js in here and enter. Constructor with constructor 0 returned a promise which resolved to 0. That worked as we thought it would. Let's move on to number 2. Write an async function with async, which reproduces the functionality of with constructor. Though your function will return a promise, it should not construct the promise using the new keyword. Instead, it should rely on the fact that an async function automatically returns a promise. When you're ready, check your work to move on to the next step. So they want us to do this right here. They want us to do this, the with constructor, and they want us to reproduce the functionality of with constructor. Okay, so we'd say async function with async. It's going to take in a number as an argument, num, and yeah, I think we just have to return it according to this here. If a promise is returned from the function, it will simply return that promise. Okay. Let's do that. So we need our if statement here just the same. So if num triple equals 0, return 0. We really shouldn't need to do it like that. Let's see if they say no to this. That should work perfectly. Return 0, else return not 0. Return not 0. All right, let's check that. That's working. Great. 3. Now test your code. Uncomment the test code we wrote at the bottom of app.js. Oh, right over here. Okay, uncomment this. Oh, you know what? We got to just delete this part and this part. Okay. In the terminal, type node app.js and press enter to execute the code. Node app.js, enter. And we can see, yeah, there we are. Our with async should do the same work right here. So with async, 100 returned a promise which resolved to not 0. Perfect. Let's move on to, oh, we didn't check it. Let me check it. Okay, now we can move on to the next lesson. The await operator. In the last exercise, we covered the async keyword. By itself, it doesn't do much. Async functions are almost always used with the additional keyword, await, inside the function body. The await keyword can only be used inside an async function. Await is an operator. It returns the resolved value of a promise. Since promises resolve in an indeterminate amount of time, await halts, or pauses, the execution of our async function until a given promise is resolved. In most situations, we're dealing with promises that were returned from functions. Generally, these functions are through a library, and in this lesson, we'll be providing them. We can await the resolution of the promise it returns inside an async function. In the example below, myPromise is a function that returns a promise which will resolve to the string I am resolved now. Async function. Async func example. Inside of the asynchronous function example is a body that has let resolved value equal await myPromise as a function. Console.log resolved value. Async func example invoked prints I am resolved now. Within our async function, async func example, we use await to halt our execution until myPromise is resolved and assigns its resolved value to the variable resolved value. Then we log resolved value to the console. We're able to handle the logic for a promise in a way that reads like synchronous code. Instructions. 1. In the provided code, we've required in the function brainstorm dinner. This function expects no arguments and returns a new promise with a resolved value of a string representing a meal. You can look at the code for this function by navigating to the library.js file. Look at the native promise dinner function. That's right here. Take a moment to understand this function and predict its expected outcome. In the next step, you'll be recreating its functionality using async await rather than native promises. It's not necessary to execute the native promise dinner function, but if you'd like to, check out the hint for some guidance. You press check work when you're ready to move to the next step. Okay, so they want us to look at that and predict what it'll do here. We have the brainstorm dinner, native promise dinner, brainstorm dinner dot then. It's going to have a meal and console log. I'm going to make the meal for dinner. So it should just have a meal passed into here. Let's check the work. Oh, that actually just moves us to, oh, I see. They said check this hint here, and oh, they're just asking us to run the app. Okay, so we'll invoke this under it, and then we'll run it so we can actually see what comes out. Here we are, and then node app.js. I have decided what's for dinner. Should I make a salad? Okay, I'm going to make beans for dinner. That's what he's going to do. Okay, that's what we expected, and everything else that came out here came from this other library, the brainstorm dinner. Okay, let's go to number 2. Fill in the body of the announce dinner function so that it has the same functionality as native promise dinner. It should wait for the promise returned from brainstorm dinner to resolve, and then log a string to the console in the same format as did native promise dinner. You'll need to use the await operator inside your function. When you're ready, check your work and move on to the next step. So we need to do what is happening here. So what I would like to do there is let's make a const called meal, and that will equal await brainstorm dinner and invoke it. So that's what meal will equal. And then we could just go ahead and take theirs right here, console.log after that. And that should work. Let's check our work. That works. Let's go to number 3. At the bottom of app.js, beneath the function declaration, invoke the announce dinner function. Okay, so we're going to invoke this right at the bottom. Check our work. That's there. In the terminal, type node app.js and press enter to execute your code. Node app.js. All right, we are going to make beans again. A lot of beans for dinner. And we should check our work and we can move on to the next lesson. Writing async functions. We've seen that the await keyword halts the execution of an async function until a promise is no longer pending. Don't forget the await keyword. It may seem obvious, but this can be a tricky mistake to catch because our function will still run. It just won't have the desired result. We're going to explore this using the following function, which returns a promise that resolves to "yay, I resolved" after 1 second. Let my promise equal a fat arrow function, return new promise resolve reject, and inside the function body of the new promise is a set time out. A resolve inside of the set time out is set to "yay, I resolved," and it resolves in 1,000 milliseconds or 1 second. Now we'll write 2 async functions which invoke my promise. Async function no wait, and that let value equal my promise console.log value. The other async function yes wait lets value equal await my promise, and then console logs that value. No wait is going to print a promise, and it'll be pending. Yes wait will print yay, I resolved. In the first async function, no wait, we left off the await keyword before my promise. In the second, yes wait, we included it. The no wait function logs promise pending to the console. Without the await keyword, the function execution wasn't paused. The console.log on the following line was executed before the promise had resolved. Remember that the await operator returns the resolved value of a promise. When used properly in yes await, the variable value was assigned the resolved value of the my promise, whereas in no wait, value was assigned the promise object itself. Instructions. 1. Take a look at the provided code. We required in the shop for beans function from library.js, which returns a promise with a resolved value of a string representing a type of bean, e.g. kidney. Next, we declared the getBeans function. Let's summarize its intended functionality. Log. 1. Heading to the store to buy beans, to the console. Capture the resolved value of the promise returned when we invoke shop for beans. The promise returned from shop for beans prints a string in the format 2. I bought the resolved type of beans because they were on sale. Finally, the function prints a string in the format 3. Great. I'm making the bean type beans for dinner tonight, to the console. Execute app.js in the terminal to see if getBeans is working as intended. So we've been doing that with node app.js, and it is, well, that one's not working, and that one is. And it seems the second one happened after the third one here. So let's take a look. We could actually do check work so we could see what they say about this. Okay. Get beans is logging 3. Great. I'm making object promise beans for dinner tonight to the console. Take a moment to understand why this is happening, and then refactor get beans so that it works as intended. Check your work when you're ready to move on to the next step. Okay, so we want to put async here in front of the function, and we're going to await this second value. And let's check the work, see if that's right. That is right. To test the code is now functioning properly, execute app.js in the terminal again. So let's do that again. That is working properly. And if you saw what just happened, like it just appeared on the screen, if you just press the up key, that's going to go through the last few things that you typed into your console in most consoles. So that's what happened there. Let's just check the work here. We're good to go to the next lesson. Handling dependent promises. The true beauty of async await is when we have a series of asynchronous actions which depend on one another. For example, we may make a network request based on a query to a database. In that case, we would need to wait to make the network request until we had the results from the database. With native promise syntax, we use a chain of .then functions, making sure to return correctly each one. Function native promise version, and this is exactly what we did in the last lesson when we talked about .then. Let's break down what's happening in native promise version function. Within our function, we use two functions which return promises, returns first promise and returns second promise. We invoke returns first promise to ensure that the first promise resolves by using .then. In our callback of our first .then, we log the resolved value of the first promise first value and then return second promise first value. We use another .then to print the second promise's resolved value to the console. Here's how we'd write an async function to accomplish the same thing. Async function, async await version, invoked as a function, and the function body says, let first value equal await returns first promise invoked, console.log first value. Let second value await equals await, return second promise, and inside of there is the first value, and then after that, console.log second value. Let's break down what's happening in our async await version function. We mark our function as async. Inside our function, we create a variable first value assigned await returns first promise. This means first value is assigned the resolved value of the awaited promise. Next, we log first value to the console. Then we create a variable second value assigned to await returns second promise with first value inside of the invocation. Therefore, second value is assigned this promise's resolved value. Finally, we log second value to the console. Though using the async await syntax can save us some typing, the length reduction isn't the main point. Given the two versions of the function, the async await version more closely resembles synchronous code, which helps developers maintain and debug their code. The async await syntax also makes it easier to store and refer to resolved values from promises further back in our chain, which is a much more difficult task with native promise syntax. Let's create some async functions with multiple await statements. Instructions. Take a look at the provided code. We require in 3 functions: shop for beans, soak the beans, and cook the beans. These functions each return a promise. Shop for beans expects no arguments and returns a promise which will resolve to a string of a bean type. Soak the beans expects a bean type string as an argument and returns a promise which resolves to a boolean indicating whether or not the beans are softened. Cook the beans expects a Boolean as an argument, and if that value is true, returns a promise which will resolve to a string announcing that dinner is ready. If you'd like, look at the library.js file to see how these functions work. Press check work to move to the next step. Let's move to that next step so we can start working on this async behavior. 2. In the following checkpoints, you'll create an async function that handles the 3 dependent promises we just walked through. It will simulate shopping for, soaking, and then cooking the beans. To get started, declare an async function, makeBeans. You can leave the function body blank for now. Check your work to move on to the next step. All right, let's make our async function makeBeans. And it's going to take in, oh, we could leave it blank, it says. Okay, let's check our work. Number 3, inside your function, declare a variable type assigned to the resolved value of shop for beans. This must be accomplished in one statement. Okay, so we'll do a const called type, and that equals await shop for beans, invoked like so, and let's check work. Great. Number 4. Next, inside your function, declare a variable isSoft, assigned to the resolved value of soak the beans. Don't forget, the soak the beans function expects an argument. Make sure to pass the expected value into soak the beans. Soak the beans wanted to know what type of bean. So we're going to put the type in there. So yeah, this will all be in order. So const, and they want us to call it isSoft will equal await, and then soak the beans. Inside of there, we're going to pass in type. And check that work. Perfect. Let's go to number 5. Next, inside your function, declare a variable, dinner, assigned to the resolved of cook the beans. Don't forget, the cook the beans function also expects an argument. Make sure to pass the expected value into cooked the beans. So a new const called dinner equals await, and this is called cook the beans, and inside of there it's going to have the isSoft passed in. At least that's what I think. Did they tell us anything different? It expects a Boolean value argument about if it's soft. Okay. So yeah, that should work. Let's check the work. Cool. Number 6. Next, inside your function, log your dinner variable to the console. Okay. Console.log dinner. Check work. Beneath your function declaration, invoke the makeBeans function. Okay. makeBeans invoked. Check work. Let's see your async function in action. In the terminal, type node app.js and press enter to execute the code. All right, it looks like it worked because dinner is served after all of that. Let's check that work and we can move on to the next lesson. Handling errors. When .catch is used with a long promise chain, there is no indication of where in the chain the error was thrown. This can make debugging challenging. With async await, we can use try-catch statements for error handling. By using this syntax, not only are we able to handle errors in the same way we do with synchronous code, but we can also catch both synchronous and asynchronous errors. This makes for easier debugging. They have an async function called using try-catch, and inside there is a try block inside of the body of the async function. The try block has let resolved function equal await async function, and inside async function, thing that will fail. Let second function equal await second async function, and inside of there is the resolve value, and there is a catch after the try block closes. The catch takes in an error, ERR, it opens a block, and it console.logs that error. At the end, it invokes using try catch. Remember, since async functions return promises, we can still use native promises.catch with an async function. And now we have an async function using promise catch. Inside of there is let resolve value equal await async function, thing that will fail. Under that, let rejected promise equal using promise catch invoked. And then after that, rejected promise.catch, reject value, arrow function, console.log reject value. This is sometimes used in the global scope to catch final errors in complex code. Instructions. 1. For convenience, we've been working with a lot of promises that never reject, but this isn't very realistic. This time, we've required in a function, cookbeansouffle, which returns a promise that resolves or rejects randomly. When it resolves, the promise resolves with a value of bean souffle, and when it rejects with a value of dinner is ruined. If you're interested, you can see how the function works by looking in the library.js file. Press check work when you're ready to move to the next step. Okay, well, let's move to the next step and work with this. Declare an async function, host dinner party. Inside your function, create a try-catch statement. The catch statement should specify an identifier error. You can leave both the try and catch blocks empty. So we want to make a host dinner party, so async function, and we are going to do a try. That's our try. Then we'll have our catch, which takes in error, and we could leave the body empty. I think that's everything that it said there. Let's just check that. Oh, I didn't name the function. Async function host dinner party. Going too fast. Let's check the work there. Perfect. Number 3. Inside your try block, log a string in the following format. Resolved value of cook bean souffle promise is served, i.e. bean souffle is served. Make sure to await the cook bean souffle promise. For more guidance, check out the hint. Okay, so this is in the try block, and we want to, about const res for resolve equals await cook bean souffle, and we can invoke it. And now we have to make this here. All right, let me just take this down. Console dot, this is a console log, right? Yeah, log a string, console.log. And I'm going to try to do it with backticks here. So this whole resolved thing here gets replaced. And it gets replaced with, so we'll put the $sign so we can do our string interpolation, res, which is the result of awaiting cook bean souffle. Let's give that a shot and see if we were right. That's right. Number 4, let's fill in the catch block. First, log the error to the console, and then log the string ordering a pizza to the console. Okay, so just console.log error. And then after that, we can console.log a string that says ordering a pizza with an exclamation point at the end. And let's check that. Okay, great. Number 5. Awesome. Beneath your function declaration, invoke host dinner party. Okay, host dinner party is invoked, check work. Number 6, let's see your function in action. In the terminal, type node app.js and press enter. To run the code, if you keep executing app.js, you'll see the result of the promise resolving or rejecting. Okay, so node app.js, and we could run that code. And dinner was ruined that time, and if you just press up and enter again, yeah, there we go, the bean souffle was served. So we saw both results, we can check that work, and move on to the next lesson. Handling independent promises. Remember that await halts the execution of our async function. This allows us to conveniently write synchronous style code to handle dependent promises. But what if our async function contains multiple promises which are not dependent on the result of one another to execute? Now we have async function waiting right over here. It has a first value and a second value, and they both equal await a first async and a second async. Then they console.log the first value, second value. Now they have async function concurrent. Now it has a const of first promise and a const of second promise set equal to first async thing and second async thing, both invoked. Console.log await first promise, comma, await second promise. In the waiting function, we pause our function until the first promise resolves. Then we construct the second promise. Once that resolves, we print both resolved values to the console. In our concurrent function, both promises are constructed without using await. We then await each of their resolutions to print them to the console. With our concurrent function, both promises' asynchronous operations can be run simultaneously. If possible, we want to get started on each asynchronous operation as soon as possible. Within our async functions, we should still take advantage of concurrency, the ability to perform asynchronous actions at the same time. Note, if we have multiple truly independent promises that we would like to execute fully in parallel, we must use individual .then functions and avoid halting our execution with await. Instructions. 1. Take a look at the provided code. We require in 4 functions: cook beans, steam broccoli, cook rice, and bake chicken. These functions each return a promise, which will resolve to a string representing a part of a meal. If you'd like, look at the library.js file to see how these functions work. Press check work when you're ready to move on. All right, let's give this a shot. Number 2. Declare in async function serve dinner. Create 4 variables. Let's do that function first. So async function was called serve dinner. Create 4 variables. So the first is a const called vegetable promise, which should be assigned the return value of steamed broccoli. Okay, so this is vegetable promise that will equal steam broccoli. And we're going to want to await that. Starch promise, which should be assigned the return value of cook rice. Okay. All right, let's see. Const starch promise will equal the return value of cook rice. Protein promise, which should be assigned the return value of baked chicken. Const protein promise equals await bake chicken. Actually, I don't think I should be doing these awaits since we're going to do them all together at the end. These variables should be assigned the promise objects themselves, not their resolved values. And that's exactly what I was just saying. I'm going to get rid of these 3 awaits. And let's check that work. No, that's not it. Oh no, I didn't do the last one. Okay, and side promise, which should be assigned the return value of cook beans. Okay, const side promise equals cook beans invoked. Now let's check the work. There we go. Number 3. Next, console.log a string in the following format. Dinner is served. We're having resolved value of vegetable promise, resolved value of the starch promise, resolved value of the protein promise, and resolved value of the side promise. Example, dinner is served. We're having broccoli, rice, chicken, and beans. You'll need to await each promise, but there are a few different ways you can accomplish the desired functionality. Check out the hint if you want some guidance. So we just saw this done in an array. Let's take a look. So what they did was await each one of them. Did they log them? Do they want them logged? Yes, okay. So we will console.log, and then we will await everything that we need to. So I'll put in my backticks, and the string is going to say dinner is served, period. We're having, and now we need the resolved promises. Await, and we'll await first the vegetable promise. Comma, and then we'll await the starch promise. Oh, I got the comma outside of that. Make a new one. Await starch promise. We will comma again. Make a new string interpolator right here, and it'll be protein promise next. Await protein promise. One more comma, the word end. And then we'll open up another one of these, and we need to do the side promise. Await side promise. Check that work. Okay, now we have dinner is served. We're having vegetable promise. That's await vegetable promise. I did that. And there's a comma. Await starch promise. That looks to be exactly the same. And there's a comma. And it was at the right spot, okay. A space, and then we await protein promise and await side promise. Man, I forgot to put a period right here at the end. I think that's what did it. Let's check that work. Yeah, that was it. Those are painful sometimes where you just miss one thing. I could have been looking at that for quite a while. Number 4, awesome. Let's see your function in action. Beneath your function declaration, invoke serve dinner. Serve dinner. And we will invoke it, check my work, and then we need to, in the terminal, type node app.js and press enter to run the code. And it does work. Let's check that work. We passed, and we can move on to the next lesson. Await promise.all. Another way to take advantage of concurrency when we have multiple promises which can be executed simultaneously is to await a promise.all. We can pass an array of promises as the argument to promise.all, and it will return a single promise. This promise will resolve when all of the promises in the argument array have resolved. This promise's resolve value will be an array containing the resolved values of each promise from an argument array. Async function, async prom all. That opens up its body and has a const result array equals await promise.all. Promise.all opens up, and it has an array that contains async task 1 invoked, async task 2 invoked, these are with commas in between them, by the way, async task 3 invoked, and async task 4 invoked. Now they do a for loop. For let I equal 0, I is less than result array.length I++, console.log result array I. In our above example, we await the resolution of a promise.all. This promise.all was invoked with an argument array containing 4 promises, returned from required in functions. Next, we loop through our result array and log each item to the console. The first element in result array is the resolved value of the async task1 promise. The second is the value of the async task2 promise, and so on. Promise.all allows us to take advantage of asynchronicity. Each of the 4 asynchronous tasks can process concurrently. Promise.all also has the benefit of failing fast, meaning it won't wait for the rest of the asynchronous actions to complete once any one has rejected. As soon as the first promise in the array rejects, the promise returned from promise.all will reject with that reason. As it was when working with native promises, promise.all is a good choice if multiple asynchronous tasks are all required, but none must wait for any other before executing. Instructions. In this exercise, we require in the same 4 functions as in the last exercise: cook beans, steam broccoli, cook rice, and bake chicken. These functions each return a promise which will resolve to a string representing a part of a meal. You can check them out in the library.js file. Press check work to move to the next step. Let's see what we need to do here. Number 2. You're going to create a very similar function to the serve dinner function you created in the last exercise. This time you'll use promise.all. Create an async function, serve dinner again. Let's do that first. So it was async function, serve dinner again. And in the body of that, inside your function, declare a variable food array and assign it the resolved value of the promise returned from promise.all. Okay, so let's make a let food array equal await promise.all. Inside there, we're going to open up an array. And remember that promise.all takes in an array of promises. So we're going to pass in all of these promises. Pass in an array containing the steamed broccoli, cooked rice, baked beans, and cooked beans. So steamed broccoli, and invoke it, comma, to cook rice, and invoke it, comma, to bake chicken. Invoke that, and finally, the last one's just cook beans. Cook beans, and invoke that one. I will do the semicolon here just to clear that. I think we did that properly. Let's check that work. Yeah, that's right. Great. Move on to number 3. Next, console.log a string in the following format. Dinner is served. We're having first item in food array, second item in food array, third item in food array, and fourth item in food array. Example, dinner is served. We're having broccoli, rice, chicken, and beans. There are a few different ways you can accomplish the desired functionality. Check out the hint if you want some guidance. Okay, so now we know we have an array that contains everything here: broccoli, cooked rice, baked chicken, and beans. And they just want the items in the array from first to fourth. And they want it to come out like this string. Okay. I'm guessing they want it inside the function, of course. Console.log. And the first thing we'll write is we're having. You know what, let's do the backticks way. That is a nice way of doing it. Backticks, then we're having And actually, before that, I didn't write dinner is served yet, so dinner is served. Yeah, dinner is served, period. We're having broccoli, comma, okay, so we're having, and then we will space, we'll do our string interpolating right here for the first element in the food array. So food array at 0, because these are 0 indexed. And then we'll comma, we want the second element, so we'll do the same thing again, 2 more times it looks like. Food array at 1, comma again, the third element, okay, so same thing one more time. Food array at 2, and we comma, we write end, then we'll open up another one and do our last food array piece. Food array at 3. And let's see if we did that right. We'll check that work. And what did I do wrong? I probably didn't put a period. Yes, I didn't put a period at the end. A habit of mine. Okay, I'm gonna look up here to see if I did anything wrong. Oh boy, I actually just saw it. Okay, you probably saw this and already corrected it. Food array, that's gotta be it, I'm guessing. Yeah, that was it. Just a little typo there. Number 4. Okay, great. Now let's see your function in action. Beneath your function declaration, invoke serve dinner again. Serve dinner again, invoked. Check the work. In the terminal, type node app.js and press enter to run the code. Node app.js, enter. Dinner is served. We're having broccoli, rice, chicken, and beans. And check that work. Let's move on to the next lesson. Review. Awesome work. Getting the hang of the async await syntax. Let's review what you've learned. Async await is syntactic sugar built on native JavaScript promises and generators. We declare an async function with the keyword async. Inside an async function, we use the await operator to pause execution of our function until an asynchronous action completes and the awaited promise is no longer pending. Await returns the resolved value of the awaited promise. We can write multiple await statements to produce code that reads like synchronous code. We use try-catch statements within our async functions for error handling. We should still take advantage of concurrency by writing async functions that allow asynchronous actions to happen in concurrently whenever possible. They mean concurrency. So they're saying take advantage of concurrency so that async actions will all happen at the same time. Great, let's see what's up next. Request 1. Introduction to requests. Have you ever wondered what happens after you click a submit button on a web page? For instance, if you are submitting information, where does the information go? How is the information processed? The answer to the previous questions revolves around HTTP requests. There are many types of HTTP requests. The 4 most commonly used types of HTTP requests are GET, POST, PUT, and DELETE. In this lesson, we'll cover GET and POST requests. If you want to learn more about the different HTTP requests, we recommend the following documentation: the Mozilla Developer Network HTTP methods. With a GET request, we're retrieving or getting information from some source, usually a website. For a POST request, we're posting information to a source that will process the information and send it back. In this lesson, we will explain how to make GET and POST requests by using JavaScript's XHR object. We'll also incorporate query strings into our requests. We'll use the DataMuse API for GET requests and the Rebrandly URL shortener API for POST requests. To complete the exercise on POST, make sure you create a Rebrandly API key by following the instructions in the article below. Codecademy articles Rebrandly URL shortener API. Okay. Instructions. Click on the button on the main page to see what the code in main.js does. Let's see that first. And it's bringing something back. It's a name, username, phone. So this looks like a user of our website here. You'll see JSON being displayed on the page. JSON, JavaScript object notation, will be the format in which our data is sent to us. That button you click produced a GET request. That's right, you've just made a GET request. Go to the next exercise to learn more about requests. Let's move on to the next lesson. We'll grab our API in just a bit. I already clicked on it and looked at the process, and I want to go ahead and show you how to do that when we need it. HTTP requests. One of JavaScript's greatest assets is its non-blocking properties, or that it is an asynchronous language. Websites like newspaper websites take advantage of these non-blocking properties to provide a better user experience. Generally, a site's code is written so that users don't have to wait for a giant image to load before being allowed to read the actual article. Rather, that text is rendered first, and then the image can load in the background. JavaScript uses an event loop to handle asynchronous function calls. When a program is run, function calls are made and added to the stack. The functions that make requests that need to wait for servers to respond then get sent to a separate queue. Once the stack has cleared, then the functions in the queue are executed. Web developers use the event loop to create a smooth browsing experience by deciding when to call functions and how to handle asynchronous events. We'll be exploring one system of technologies called asynchronous JavaScript and XML, or AJAX. To read more about the event loop, read the MDN documentation for the event loop. Instructions. 1. To get a glimpse of how the event loop works, take a look at the code in the code editor. We'll be using setTimeout, which will pass a function call to the queue. The first argument is a callback, and the second argument is the number of milliseconds the program must wait before the callback can be run. The other console.log calls are run from the stack. I guess we'll just press run here. Okay, first message, second message. This message will always be run last. So right here, to set timeout, that message is always run last because it's set to come back in 2.5 seconds. Interesting, right? What if we change the 2500 in set timeout to be 0? Essentially, the callback doesn't need to wait before it can be called. Do you think that this change will affect the order? Let's do that for them. So now that's 0, run it, and this message will always run last. Let's go to the next lesson. Asynchronous JavaScript and XML, AJAX, enables requests to be made after the initial page load. Initially, AJAX was used only for XML formatted data. Now it can be used to make requests that have many different formats. MDN documentation, extensible markup language, XML. Similarly, the XML HTTP request, XHR API, named for XML, can be used to make many kinds of requests and supports other forms of data. Remember, we use GET to retrieve data from a source. Take a look at the boilerplate code in the diagram to see how to make an XHR GET request. We'll construct this template from scratch in a different exercise and walk through what each step does. So here is our XML HTTP request GET. Const XHR equals new XML HTTP request invoked. That creates a new request object. That imagine it says creates new object. Const URL equals an HTTP to some endpoint. xhr.responseType equals JSON as a string. xhr.onReadyStateChange is a fat arrow function, and inside the body is an if statement that says xhr.readystate triple equal to xml http request.done. In the body of the if is the code to execute with response, and then that xhr.onReadyStateChange function closes. xhr.open takes get, comma, URL. xhr.send invoked. Instructions move on to the next exercise when you're ready. Let's move on to the next lesson. XHR get requests 2. We are going to construct XHR get request boilerplate code step by step until we have written a complete get request. Feel free to refer to the XHR get diagram at any point while completing this exercise. XHR get diagram. Instructions. First, we need to create the XML HTTP request object using the new operator. Save this object in a const called XHR. Okay, const XHR equals new XML H and then TTP, then capital R in request. Note, while the code will work regardless of how you name your variables, it is a common practice to name this object XHR. All right, let's run this first one. Looks good. Number 2. Next, save the following URL to a const called URL. Let's make that const first. Make sure the URL is wrapped in quotes so that it's a string. Okay, so we want to put this in, and we want it wrapped in quotes as a string. Let's run that. Number 3. Set the response type property of the XHR object to equal JSON as a string. JSON is JavaScript object notation, which is how the response is going to be formatted. Okay, so we're going to say xhr.response type, and that will equal JSON as a string. JSON. Let's run that. Great, we'll go to number 4. Set the xhr.onReadyStateChange event handler equal to an anonymous arrow function. Leave the function empty. Okay, so xhr.onReadyStateChange, and this is not camel case at all. And they want us to set this equal to an empty function, okay? Let's see if that's what they wanted. That is it. Number 5. In the code block of the function you created in the previous step, add this conditional statement. If, we could copy this right in. Okay, so this is the if statement. We saw this in the diagram. If xhr.readystate is triple equal to xml http request.done, and then we do what we want to do inside of this function. So we'll paste that into the body of that function. The purpose of this conditional statement checks to see if the request has finished. Let's run that. Number 6. In the code block of the conditional statement, return the response property of XHR. We will return the response property of XHR, xhr.response, like so. And let's see if that's right. There we go. Number 7, below the function you created in the previous 2 steps, call the .open method on the XHR object and pass it get and URL as arguments. Okay, let's do that. And where is this going to happen? Below the function we created. So imagine below this one. No, it should be below this one. All right, let's try that right here. So xhr.open, and we're putting in there a string of get, and we will comma to the URL that we made right up here. .open creates a new request, and the arguments passed in determine the type and URL of the request. Let's try this out, see if we did it right. Perfect. Let's go down to number 8. On the following line, call the .send method on the XHR object. Do not pass it any arguments. Okay. XHR.send and invoke that. And we will press run. That's working. Nice work. You've written the boilerplate code for an AJAX GET request using an XML HTTP request object. Let's go to the next lesson. XHR GET requests 3. By this point, you have an idea of how to write the boilerplate code for an AJAX request using an XHR object. In this exercise, you will incorporate that boilerplate code to make a GET request to the DataMuse API to search for words that rhyme. DataMuse API documentation. Instructions. 1. At the top of main.js, create a const named URL and save to it the following URL as a string. HTTP, okay, so that's the DataMuse URL. We'll make a const URL will equal, and then we will get the DataMuse URL, and remember to make it a string. You'll be using this URL to direct your request. Let's run that. That's good. Number 2. Underneath const URL, create another const named query params and assign it to rel_ri equal. rel_ri equal is the start of a parameter for the query string. This parameter will narrow your search to words that rhyme. Okay, so we will make a new const. It's called query params. It's going to equal rel_rhy equals, and that's supposed to give us words that rhyme. And we'll run that. Oh, I spelled const wrong. That's definitely not going to work. Here we go. Cool. Number 3. In the function getSuggestions, create a const named wordQuery and assign it to be inputField.value. InputField.value grabs what is in the input field and assigns it to the variable wordQuery. You'll be working in getSuggestions for the rest of the exercise. All right, we'll go to getSuggestions right here, and we want to make a const named wordQuery. Assign it to inputField.value. Let's try that out here. And it works. Great. Let's go to number 4. Now create another const named endpoint and assign equal to a string that concatenates URL, query params, and word query. Endpoint will store the value of the entire URL and query string. Okay, so inside of here, we're going to make a const called endpoint. Const endpoint. It equals a concatenation, so let's use our backticks for that. We will say $ and open and close curly braces. The first thing I'll put in there is the first thing they asked for, which was URL. And we'll do the same thing again. Query params. And one more time. Word query. And let's run that, see if we did it right. That works. Let's go to number 5. You can now start on the XML HTTP request object. Declare a const named XHR and use the new operator to create the XML HTTP request object. Okay, const XHR is going to equal a new XML HTTP request. Okay, let's run that. Number 6, set the response type of XHR to JSON. Okay, so XHR.response type, camel case, equals a string with JSON in an all undercase. When data is sent back, it will be in JSON format. We'll run that. Great. Number 7, assign an anonymous arrow function to the onReadyStateChange event handler of XHR. Okay. XHR.onReadyStateChange, and there's no capitals in that. And here we go with our anonymous function. Let's run that. Number 8, include the following code inside the code block of the anonymous arrow function you just created. And then it's the if xhr.readystate. It's exactly what we did last time, except it says render raw response, and it's going to take in the xhr.response, and I imagine that has something to do with what gets on the screen here. So I'm just going to copy this in. It's our entire if statement there. The render raw response helper function can be viewed at public and then helper functions.js. Let's take a look and see what it does. We have nothing rendered yet. Number 9, below the anonymous arrow function you just created, but still inside of getSuggestions, call the .open method on the XHR object and pass it get and endpoint as respective arguments. Let's do that first because there's quite a bit more to read here, but they just gave us something we need to get done. So outside of the onReadyStateChange, after that will be xhr.open, and in there they wanted us to put get all capital and as a string, and the next thing they wanted was endpoint, and that's what we constructed before by concatenating the URL query params and word query. This method call will create a new request using the 2 arguments. Get sets the method and URL sets the destination. Underneath .open, call the .send method on XHR and pass it no arguments. The .send method will send the request to the server. Okay, xhr.send, and we'll invoke it. Then run your code. Okay, we'll run it. It's working. Type in a word in the input field and click the submit button. If all went well, the response field in the browser will display the raw response from the API. So type in a word. Let's do enter. There we are. We see this says these are words are objects here, and they actually have scores with how much they rhyme, I guess. They have a num syllables, they have a score, and they have the word. Cool, very cool. Let's go down to number 10. Now delete render raw response xhr.response and replace it with render response xhr.response and run your code again. Okay, I'm just going to copy this so I don't make any typos. So that was on render raw response. Where was that? Right here. Oh, I actually only need the word. Okay. And run your code. Let's run our code. And then we'll do the same thing here just to see what it looks like. There you go. Yeah, so they're just taking the words and they're, I guess, probably weighted. Whoever has the highest score is most likely on top. That's what I'm going to guess because this isn't in ABC order. Then type a word into the input field and click the submit button. Yeah, okay, we did that. Great, now it looks nice and formatted. Well, okay, let's go to the next lesson. XHR GET request 4. In the previous exercise, you made a GET request to the DataMuse API to find words that rhyme. In this exercise, we will create a request to set a topic and find adjectives that describe the input word using query strings. A query string contains additional information to be sent with a request. The DataMuse API allows us to retrieve more specific data with query strings attached to the request URL. Wiki query string. A query string is separated from the URL using a question mark character. After a question mark, you can then create a parameter, which is a key value pair joined by an equal sign. Examine the example below. HTTP, and let's get to where the question mark is. Okay, so after .com/words question mark key equals value. If you want to add an additional parameter, you will have to use the question mark character to separate your parameters, like so. And now we have .com/words question mark key equals value, and another key equals another value. Let's incorporate this into our code. Instructions. 1. Let's do something else besides finding words that rhyme. Have const query params store the value rel_jjb equals. This will search for words that describe another word. All right, so query params are up here, and we're going to change it to this. Run the code, then type in a word and click the submit button on the page. Okay, let's run it. That's right. We'll go with enter again. Oh, did we need to type in a topic too? All right, let's just see the enter one. Control, prompt, click, shift, hit, alt, select. Okay, those are words related to enter. 2. Since we want to retrieve more specific results, we should create another parameter. Create another const additional params underneath query params and assign it and topics equal. All right, const, and it was additional params, and that's going to be equaled to end topics. So that's the ampersand and then topics, and then the equal sign. Reminder, the ampersand character at the start of the string is used to separate our parameters. The equal character will join the key topics to a value. Let's run this. Looks good. Number 3. Now, if you were wondering why there's a second input field, that's exactly what we're going to hook up now. The word typed in here will be the value portion of our second parameter. The second parameter will filter the response using the word typed into the second input field. In the next step, we'll incorporate this parameter in our query string. In the code block of getSuggestions under word query, declare a const topic query and assign it to the value of the topic field. Okay, so we want, it was under word query. Okay, so here, const topic query, and that needs to be the response of the input field. No, the topic field. Okay, good, because that's the input field. So topic field dot value. Let's see if that's right. Great. Number 4. In getSuggestions, change the value of endpoint to a concatenated string of URL, query params, word query, additional params, and topic query. Okay, so that's our endpoint right here. URL, query params, word query, and the next is going to be topic query. Okay, so $, open close, put topic query inside of there. Run the code and enter a word and a topic and click submit. Did you set const endpoint equal to a concatenated string? First it's URL, then it's query params, then it's word query. Oh, I didn't put additional params. That's my fault. Okay, additional params. That goes in between here. Now we'll run that. Okay, and we want to type in a word. We'll do enter again, and the topic is doors, and we'll submit that. Rear, handle, input, stop, control, touch, line. Okay, our request will have returned a response of adjectives that are related to a topic. Feel free to play around with variables and parameters to get more word suggestions. All right, we can go to the next lesson. Let's go. XHR post requests 1. Reminder: if you haven't already signed up for an API key from Rebrandly, please read this Rebrandly signup guide. Okay, so you can go to this Rebrandly signup guide now. Where you need to go is a Rebrandly site to create a new account. I already have an account, so I'll go to the Rebrandly site, but they will load me right in. Now, when you create a new account, you'll come to here, and I have several different links here that I've tested out, and I'm going to make a new link when we get to it, and I'll show you how to do it in here when we do get to it. I can get rid of this for now. So yeah, just sign up for your account, and we will work with it in just a moment. Great. By this point, you've signed up for an API key, and you know the essence of making a GET request. We will be making a POST request using the Rebrandly API. The major difference between a GET request and a POST request is that a POST request requires additional information to be sent through the request. This additional information is sent in the body of the POST request. We'll walk through the code from the diagram and construct our own POST request in the next lesson. Instructions. Move on to the next exercise when you're ready. Go to that next exercise now. XHR post request 2. We are going to reconstruct the code from the previous exercise step by step until we have written a complete AJAX post request. Feel free to refer to the XHR post diagram at any point while completing this exercise. Instructions: create a new XML HTTP request object using the new operator and save it in a const called XHR. Okay, so let's get that started. Const was XHR equals new XML HTTP request. The XML HTTP request object is used in JavaScript to interact with servers. Let's run that, see if we're right. We are. Number 2. Next, save the following URL to a const called URL. Make sure the URL is wrapped in quotes so that it is a string. So HTTP, okay, so this is the URL they want us to wrap in quotes and assign to a const called URL. The URL will direct the request to the correct server. So const URL equals this as a string, and we can run. Create a new const called data and save this line of code to it. It's a JSON stringify ID 200. Okay, so let's make a const called data will equal that. JSON.stringify will convert a value to a JSON string. By converting the value to a string, we can then send the data to a server. All right, let's run that, see if we're right. There we go. Number 4, set the response type property of the XHR object to be JSON. So, oh, not const, sorry about that. XHR.response type. That's going to equal a string with JSON in it. And let's run that. Perfect. Number 5. Set the XHR.onReadyStateChange event handler equal to an anonymous arrow function. Leave the function empty until the next step. Okay. I'm going to just copy that from myself. XHR.onReadyStateChange is an anonymous arrow function. And .onReadyStateChange will contain the event handler that will be called when XHR's state changes. So let's run that. Number 6. In the code block of the function you created in the previous step, add a conditional statement that checks to see if the ready state of XHR is equal to XML HTTP request .done. Okay, so we're going to write that whole conditional out. If the ready state of XHR dot ready state, camel case, triple equal to this is capital, XML HTTP request, R is capital, dot done, all capital for done. And it doesn't say to do anything in the body of that if, so we'll just run that. Great. Number 7. In the code block of the conditional statement, return the response property of XHR. The response property will contain the data that we're getting back from the post request. Okay, so return XHR.response. And we could run that. Great. Number 8. Below the function you created in the previous 2 steps, call the .open method on the XHR object and pass it post and URL as arguments. And we were doing get before, so this is where we're going to pass post. So below the function we just created, which ends right there, it's going to be xhr.open, and we're going to hand it all capitals for a string of post and the URL that we made up here. .open creates a new request, and the arguments passed in determine what type of request is being made and where it's being made to. So let's run that. Great. Number 9. On the following line, call the .send method on the XHR object and pass data as an argument. Okay. XHR.send, and we're passing data. .send will send the request to the server. Nice work. You've written the boilerplate code for an AJAX post request using an XML HTTP request object. Let's run that, make sure it's right. It is, and we can move on to the next lesson. XHR post request 3. Reminder, if you haven't already signed up for an API key from Rebrandly, please read this article. We're going to get our API key now, so just go to your Rebrandly dashboard, head over to the little icon that's you, and go to API keys. And you can generate yourself an API key. In this exercise, you'll be making a post request to the Rebrandly API to shorten a URL. Get ready, you're now going to incorporate the previous lesson's boilerplate code into making an actual post request. If you reset the exercise at any point, you will have to paste your API key again at the top. Instructions. 1. Copy your Rebrandly API key and assign it to the const API key at the top of your code. All right, I'm going to put mine in here. I will delete this immediately so nothing funny happens with it, but that's where your API key should go, and it looks like it should be going as a string, I'm imagining, because they didn't say to get rid of the string portion. Let me see. Yeah, I imagine it's a string. Let's try that out. We'll run it. Number 2. Within the code block of shorten URL, create a const called URL2shorten and save input field.value to it. Okay, so we're gonna have a const called URL2shorten inside shorten URL. Where are you? Right here. Const URL2shorten is going to equal input field.value. Note, for the remainder of this exercise's instructions, we will be working inside the code block of shorten URL. All right, let's run that then. Nope, I did that wrong. Declare a const URL2shorten. Spelled input field wrong. That's most likely the issue. Good. Number 3. Create a const called data and save the following code to it. Okay, a const called data inside of shorten URL. That's going to equal this JSON stringify. We're including this information because the API expects to see an object with a key destination that has a value of a URL. Let's run that. Great, let's go to number 4. Create a new XML HTTP request object using the new operator and save it to a const called XHR. Okay. Const XHR is going to equal XML HTTP request. And we have to use the new operator like that. Then we could cut it off and run. Number 5, set the response type property of the XHR object to be JSON. Okay, xhr.response type equals JSON. Let's run that. We got it. Let's go to number 6. Save an empty anonymous arrow function to the onReadyStateChange event handler of the XHR object. This function will not take in any parameters. Okay. XHR.onReadyStateChange and just a fat arrow function. Inside the anonymous function's code block, include the following code inside of its code block. That's a funny sentence, but we can just grab this and paste it in. The render raw response function can be viewed at public/helper functions. All right, let's run this, see if we did that properly. We did. Number 7. Below the anonymous function you just created, call the .open method on XHR and pass it post and URL as respective arguments. So below that function, which ends right here, I'm sorry. I'm thinking of something called Axios. XHR.open, and inside of there, post, comma, URL. Let's run that. That's right, number 8. To access the Rebrandly API, we need a header with 2 key value pairs. In the header, you must include values for content type and an API key. To set the header, we have to include the following code below our .open method. xhr.set_request header, and instead of there we actually pass content type, comma, application JSON as a string, and then we do the same set request header on the XHR object again with API key as a string and API key. That's actually what we wrote at the top here. This here being passed in as well. So let's get started on that. That's going to be all of this. So we're actually going to just paste it in. We could see there's our content type and we're saying application JSON. We could also see we said we're going to set our API key and then we give the value of the API key that we saved up on top. So let's run that, see if it's right. Perfect. Number 9. On XHR, call the .send method and pass it data as the argument. Okay. XHR.send with data as the argument. Let's run that. Number 10. Enter this URL into the input field and click the shorten button on the web page. Okay, there's a big URL here. We're going to copy it. We're going to paste it in. We're going to hit the shorten button. And we have a whole bunch of JSON that came back there. Notice the object that came back. Now replace render raw response with render response. Let's do that. Now render raw response, where were you? Right here. Render response. We will run it, which passes, and then we want to paste that URL in again. Okay. Your shortened URL is rebrandly.ly, and there is the shortened URL. Great, let's move to the next lesson. Review requests 1. You've done an amazing job navigating through making XHR GET and POST requests. Take some time to review the core concepts before moving on to the next lesson. 1. JavaScript is the language of the web because of its asynchronous capabilities. AJAX, which stands for Asynchronous JavaScript and XML, is a set of tools that are used together to take advantage of JavaScript's asynchronous capabilities. 2. There are many HTTP request methods, two of which are get and post. Get requests only request information from other sources. Post methods can introduce new information to other sources in addition to requesting it. Get requests can be written using an XML HTTP request object and vanilla JavaScript. Post requests can be written using an XML HTTP object and vanilla JavaScript. Writing get and post requests with XHR objects and vanilla JavaScript requires constructing the XHR object using new, setting the response type, creating a function that will handle the response object, and opening and sending the request. To add a query string to a URL endpoint, you can use ? and include a parameter. To provide additional parameters, use an ampersand, and then include a key value pair joined by an equal sign. Determining how to correctly write the request and how to properly implement them requires carefully reading the documentation of the API with which you're working. Instructions. Play around with the browser and code to make get and post request. If you're going to make post request, make sure you assign API key your rebrandly API key and run the code. If you want to challenge yourself, and you can go ahead and try to do a little bit more here if you'd like to have some more fun with these types of requests. There's a fetch API built into JavaScript now that's more modern than this, and I imagine that's what's next. Actually, let's see what's up next. It's request 2. And yep, there is our await fetch. So we're going to learn fetch next, and that's going to come in extra handy. It's one of the tools that's built into JavaScript now. Request 2, Introduction to Request with ES6. In the previous lesson, we spent a lot of time dealing with asynchronous data. Remember AJAX, asynchronous JavaScript, and XML? Many of our web page interactions rely on asynchronous events, so managing these events is essential to good web development. To make asynchronous event handling easier, promises were introduced in JavaScript in ES6. Mozilla Development Network Promises, a link. A promise is an object that handles asynchronous data. A promise has 3 states. Pending, when a promise is created or waiting for data. Fulfilled, the asynchronous operation was handled successfully. Rejected, the asynchronous operation was unsuccessful. The great thing about promises is that once a promise is fulfilled or rejected, you can chain an additional method to the original promise. In this lesson, we will explain how to use fetch, which uses promises to handle requests. Then we will simplify requests using async and await. We'll use the Datamuse API for GET requests and rebrandly URL shortener API for POST requests. For you to complete the lesson on POST, make sure you create a rebrandly API key by following the instructions in the article below. And we did that last time. I'll make myself another one for this one, but you should know how to do it, and there are directions in this article. Instructions. Click the button on the web page to see what the code in main.js does. Notice the usage of fetch, async, and await. Okay, that's this. We have an ID coming back. This looks to be a user of our website, maybe. They have a name, username, and so on. We'll also be working with JSON, so study the structure of the response on the web page. Go to the next exercise to learn more about requests. Let's go to the next one. Fetch, get request 1. The first type of request we're going to tackle are GET requests using fetch, MDN fetch API. The fetch function creates a request object that contains relevant information that an API needs, sends that request object to the API endpoint provided. returns a promise that ultimately resolves to a response object, which contains the status of the promise with information the API sent back. In the next exercise, we'll go over the boilerplate code for using fetch and walk through what each step does, instructions. Move on to the next exercise when you're ready. Here's a fetch get, it's fetch, and then we invoke it, and inside the invocation, we put in the web address we're going to, .then, and then they're calling a response. I'm sure you could call this anything you want. And there it says if response.ok, return response.json. Otherwise, throw a new error, request failed. And then we comment after that, network error, and that is the error. And then .json response, more code to execute right there. Let's see this slowly in the next one. Fetch get request 2. We are going to reconstruct the boilerplate code necessary to create a GET request using the fetch function step by step. Feel free to refer to the fetch get diagram at any point while completing this exercise. Fetch get diagram. Instructions. 1. First call the fetch function and pass it the URL as a string. So fetch, we'll open it up. Here is the URL. And we need to make it a string. Great. The first argument determines the endpoint of the request. And now we'll press run. Number 2. Chain a .then method to the end of the fetch function and pass it the success callback arrow function as its first argument. The success callback function takes one parameter, response. Okay, we'll chain a .then here, so .then, and it wants us to have one parameter called response. And we'll just add the body there. .then will fire only after the promise status of fetch has been resolved. Let's see if we did that right, see if they want it that way. Yep, that's perfect. Number 3, inside of the response callback function, check the OK property of response inside of a conditional statement. In the code block of the conditional statement, return response.json. Okay, so here we're going to say we want an if statement. If response dot, it said okay, okay. And you could set this equal to true, but true is a falsy value, a truthy value when we're talking truthy falsy. So if this exists, it will run this part of the code if there is an okay. But we will just for this triple equal it to true as well. And we'll just return response.json and invoke that. Let's see if that's all right. That's working. Number 4. Below the curly braces of the conditional statement, create a new error with this code. Throw new error, request failed. Your code will throw this error when response.ok is falsy. So right after this part, we want to throw new error, request failed. Let's try that out. There we go. Number 5, add a second argument to .then. It will be an arrow function that will handle our failures. Separate the first callback function from the second with a comma. The second callback function takes a parameter, network error. So we're saying within this .then, we want to add a second, not response here, but network error. So that would be outside of this, but inside of this. So let's comma to that. We're going to call it network error and point to an empty function for right now. In the code block of the second callback function, log network error.message. So console.log a network error.message. If we could not reach the endpoint at all because maybe the server is down, then we would get this network error. Let's run that and see if this is done properly. That's right. Okay, great. Let's go to number 6. Chain another .then method to the end of the first .then method. Pass the new .then method a callback function that takes JSON response as its parameter and return JSON response. So now we're going to .then after this .then. So here, right at the end, we will .then open up, and it's going to be called JSON response. And we want to return JSON response. And let's run that. Great, we can move on to the next lesson. Fetch GET request 3. In the previous exercise, you wrote the boilerplate code for a GET request using fetch and .then. In this exercise, you're going to use that code and manipulate it to access the Datamuse API and render information in the browser. Datamuse API. If the request is successful, you will get back an array of words that sound like the word you typed into the input field. You may get some errors as you complete each step. This is because sometimes we've split a single step into one or more steps to make it easier to follow. By the end, you should be receiving no errors. Instructions. Number 1. At the top of main.js, create a const called URL. Assign URL the following URL as a string. Okay, so that's going to be at the top. We'll make a const called URL. And as a string, that is assigned. Let's run that. Great. Number 2. Below URL, create another const and call it query params. Assign it a value of, and there's a question mark, SL equals. Query params will be the start of your query string and will narrow your search to words that sound like your word. Okay, so we will make a const called query params. And I'm just going to copy this here and get it right. Const query params, capital P. It's going to equal this as a string. Perfect. Let's run that. That works. Number 3. Inside the getSuggestions function, create a const called wordQuery and assign it input field.value. We got to find get suggestions, and then we want a const called wordQuery. Const wordQuery equals input field dot value. You'll need wordQuery to store the value of what's being typed into the input field. You will be working inside getSuggestions for the remainder of the exercise. Let's run that. Const wordQuery, did I do that wrong? Oh, yep, that's not the right letter. Perfect. Number 4. Now it's time to add a query string to the URL with all the necessary parameters. Create another const called endpoint. Assign it value of a string that is URL, query params, and wordQuery concatenated in that order. Okay, so we'll make a const called endpoint, all undercase. That's going to equal string concatenation here. So let me put up my backticks real quick. The first one was endpoint. No, we made the const endpoint there. So the first one is URL. Let's make another one. That is query params. And one more. That is wordQuery. And let's see how that goes. Number 5. Call the fetch function and pass in endpoint as an argument. For this API to work within the provided browser, add cache, no cache as the second argument. So we should still be inside of here. So what we'll do is fetch. And inside of fetch, we want the URL as the first thing. And then our second argument was this right here. So this object, this must be like an options object here. So we have that set up. I think that's right. Let's run it. Oh, there's something wrong. Did you call fetch with endpoint? Oh, I put URL. We just made endpoint, and I'm using URL. All right, good. Let's see if that works. That is it. Okay, great. Number 6. Chain a .then method to the fetch function. Pass it a success arrow callback function as an argument. The callback function should take response as its single parameter. Okay, so we'll do a .then after our fetch. .then, and then we wanted response, and that should be our entire arrow callback function there. Let's see if that's working for us. Perfect. Number 7. Inside the success callback function, create a conditional statement that checks if the OK property of the response object evaluates to a truthy value. If so, call the function render.json response and pass in response as an argument. Then run your code. Okay, that was a lot of words, so we're going to go through this a little slowly here. So we had the response. Now we need to check the OK value of the response. Okay, we did this last time. So this will be if response dot OK. And I'm not going to do the triple equals true here because this should work the way it is, and if it doesn't, we'll change it later. Now, if that's true, I want to, let me copy this, render JSON response, and I'm going to pass in the response. Then run your code. Okay, let me run it. Then type in a word and click the submit button to view the JSON that came back. The status of the promise returned from fetch will be resolved. The code for render JSON response can be viewed at public/helper functions. That's right in your folder here if you want to take a look. So we'll enter a word. Last time we did enter. Let's do it again. Cool. And they have a type. They say cores. The URL is the API data muse, redirect false, status 200, OK is true, status text is OK. Yeah, so when we wrote response.OK, what we're getting is true, which is a truthy value, which means this would mean true here. So if true, and if it did not come back OK, I imagine it would either be undefined or false. Let's move on to number 8. Delete render JSON response and replace it with return response.json, and then invoke the .json. Okay, we'll get rid of that and then return response.json and then invoke that. By returning response.json, the next function that is .then chained to it will receive a promise with JSON data. So let's run that, see if that's right. Good. Number 9. Below the conditions code block, add this code to raise an exception if the request failed. Throw new error, request failed. Okay, we will copy that, and that's after our if. We'll do a new error with request failed. Let's run that. Number 10. Separate the success callback function and the error callback function with a comma. The error callback function will also be an arrow function that takes one parameter, network error. In the code block of the arrow function, log network error.message to the console. And so now we'll separate, we have response here, and then we want our network error. So this would end here. That's not what we want. We want to, right before where it ends, comma, we'll write network error. And we'll do a fat arrow inside there. Log, so console.log network error.message. And let's run that, see if that's right. Perfect. And we can move on to the next lesson. Fetch get requests for. Great job making it this far. In the previous exercise, you created the query URL, called the fetch function, and passed it the query URL and a settings object. Then you chained a .then method and passed it two functions as arguments. One to handle the promise if it resolves, and one to handle network errors if the promise is rejected. In this exercise, you'll now take the information that was returned with the promise and manipulate the web page. Instructions. Number 1. At the end of the .then method, chain another .then method. Pass .then an anonymous arrow callback function that takes JSON response as its single parameter. Okay, let's find our first .then. That's you right here. And you open up right here. So here the .then is over. We'll chain another .then. And inside of there, we're taking JSON response. That's our parameter. And we will point to just in an empty body for right now and run that. That works. Number 2. Inside the callback function, call the function render raw response and pass in JSON response as an argument. Run the code. All right, inside of here, we're going to write render raw response. And inside of here, we're going to paste this right in, JSON response, and run the code. In the input field, you can type in a word and click the submit button. Okay, let's type in a word, enter, submit. If all went well, you should see an array of words that the DataMuse API responded with. You can view the purpose of render raw response at public/helperfunctions.js. Now we see that we have words, they have scores, numbers of syllables, and the words themselves. That's what's coming back in the JSON here. It's an array of objects. Number 3, time to clean up that response a bit. Delete render raw response and passed in JSON response and replace it with render response passed in JSON response. Run your code, try the web page again with another word. So we're just changing this, paste that in and run. And let's use that same word, enter. Here we are. We can see now we just have the words. Perfect. Let's go to the next lesson. Fetch post requests. 1. In the previous exercise, you successfully wrote a GET request using the Fetch API and handled promises to get word suggestions from DataMuse. Give yourself a pat on the back, or 2, to treat yourself. Now you're going to learn how to use Fetch to construct post requests. Take a look at the diagram to the right. It has the boilerplate code for a post request using Fetch. Notice that the initial call takes 2 arguments, an endpoint and an object that contains information needed for the post request. The rest of the request is identical to the GET request. So it's going to take 2 arguments right here. Under Fetch, we have our API there, what we're trying to hit, the method, which says post, and a body, json.stringify, some object that we pass in. So that's the big change here. Let's move on to the next lesson. Fetch post requests 2. We are going to reconstruct the code from the previous exercise step by step until we have written a complete post request using Fetch and .then. Feel free to refer to the Fetch Post diagram at any point while completing this exercise. Fetch Post diagram. Instructions. Number 1. Call the Fetch function. Pass it the URL below as a string as its first argument, and pass it an empty object as its second argument. All right, let's do this first. We had fetch. It wants the URL, and then we're going to comma to an empty object. So I'm going to grab this URL. It has to be a string, remember? We're calling fetch and providing an endpoint. In the next step, we'll fill in the empty object with the necessary information. Okay, let's run this. Number 2. The settings object you pass to the fetch function will contain 2 properties: method with a value of post and body with a value of json.stringify and object ID 200. The second argument determines that this request is a post request and what information will be sent to the API. Okay, so let's do that now. In here, we need 2 things: a method that's going to be post as a string, and then we will comma to the body. And inside the body, we will have json.stringify. And inside that, we will make an object with ID, a string of 200. Let's see if that's all right there. We'll just run this. That's perfect. Number 3. Chain a .then method to the fetch function and pass it the success callback function as its first parameter. Pass in response as an argument for the callback function. Leave the code block of the callback function empty for now. Okay, I'm going to move this down. Hopefully this causes no problems for their compiler. Then, with this much on the screen, I'm going to increase the text just a little for you guys. I think that'll be helpful. Maybe around there. This might be too big. Yeah, let's do it right here. In the .then. Okay, so we're going to pass in response. And we can leave the body empty for now. Let's run that. Okay, number 4. Inside the callback function's code block, check the OK property of the response object inside of a conditional statement. In the code block of the conditional statement, return response.json. When returned, this information will be passed on to the next .then callback function. Okay, so inside of here, we're going to return response.json and invoke that. Let's run that. Nope, I did that wrong. Oh, I didn't do the conditional yet. Okay, if response.ok, and we have to just wrap that return. That should do it. Let's run that. Okay. Number 5. Below the curly braces of the conditional statement, create a new error with this code. Throw new error request failed. Okay, so after the conditional is done, so right here, we will throw an error. This error will be raised if we get back some status error. Let's run that. Great. Number 6. Create the failure callback function. This function takes a single parameter, network error. Separate the first callback function from the second with a comma. This function is still inside of the .then method. In the code block of the function you just made, log network error.message to the console. Okay, so we have to comma to this, so that's the end of it, meaning that this closes the response block here. So we will comma now to network error. And let's do a function like so, and console.log, it was network error dot message. Let's run that. Perfect. Number 7. Chain another .then method to the end of the first .then method. In the new .then method, create an arrow callback function that takes JSON response as its parameter. Okay, let's do that first here. Now this is the end of the full .then here. So another .then. It's going to take in a JSON response. Then in the code block, return JSON response. So return JSON JSON response. The purpose of this step is to view the JSON that was returned from the previous .then. Let's run that. Looks good. We could go to the next lesson. If you don't have the Rebrandly API key, it's time to get it now. We could see this article right here and go to the Rebrandly site. Log yourself in. Here I am logged in. I'm going to make myself a new API key. API keys. You don't have any API keys. Generate a new one. Now I'm copying my key and I'm back in. Okay, fetch, post request 3. In the previous exercise, you created the boilerplate code for making a post request using fetch and .then. In this exercise, you're going to update that boilerplate code to allow you to shorten a URL using the Rebrandly URL shortener API. They have a link to the Rebrandly API. If you haven't created a Rebrandly API key, that's what we just did. If you reset the exercise at any point, you will have to paste in your API key again at the top. Instructions. 1. Assign API key your Rebrandly API key as a string. If you do not assign the correct key, you will not see the proper results in the steps afterward. Okay, so right here, we're going to take this, get rid of it, and paste in that key that we just got. Do not use this key. I will delete it after this video. Just make your own key. Let's run that. There we go, number 2. Inside the code block of shorten URL, create a const named URL to shorten and assign it input field.value. URL to shorten will keep the value of what is being typed into the input field. Please note, you will be working inside shorten URL for the remainder of this exercise. So we're inside of here, this shorten URL. We need a const URL to shorten. Assign it to input field dot value, and that should do it. Let's just run that. That's it, number 3. Underneath URL to shorten, create another const named data and assign it to the result of calling the method json.stringify with destination URL to shorten as an argument. All right, so we'll have our const data, and that will be equal to json.stringify. Open that up with this inside of it. So I'm just copying the object into it. Okay, let's go ahead and run that. The reason for creating data is to prepare the information needed to send in the body. Number 4. Below data, call the fetch function, pass it URL as its first argument, and an empty object as its second argument. Okay, so under this, we're going to call fetch. The first argument is URL. The second argument is an empty object. And let's run that. Okay, number 5. Now it's time to add some properties to the empty object that you just created. Create a property with the key method and the value post as a string, all capitals. Okay, so we want a method of post as a string, all capital, and run. Number 6. In the same object, create another property. The key of this property is headers, and the value will be another object. Assign headers the value of another object listed below. Okay, so I'm going to copy this, but the key will be headers. So we will comma headers, and then we will paste that object as the headers. Let's run that. Great, number 7. In that same object that has the properties method and headers, add another property, The key is named body, and the value will be data. Okay, so inside of the method and headers, add another property. So after the object, that closes here, we will comma to yet another property, and we're going to call it body, and the value will be data. Okay, yeah, we made that data right up here with the JSON stringify, and that is the body that we're passing in. Setting up this information now will make chaining .then in the next exercise much easier. So let's run that and see if we did it right. We did. We can move on to the next exercise. Fetch post request 4. In the previous exercise, you've positioned yourself to make the post request by providing the endpoint and the object containing all the necessary information. In this exercise, you'll handle the response. The request returns a promise, which will either be resolved or rejected. If the promise resolves, you can use that information and the OK status. Let's implement that knowledge into your code. If you reset the exercise at any point, you will have to paste your API key again at the top. Instructions. Chain a .then method to the end of the fetch function you wrote in the previous exercise. As its first argument, pass it an arrow function as a callback that takes response as its single parameter. So after we do our fetch, which starts here and ends here, we write .then. We're going to have response, a fat arrow, and pointing to a body that is empty right now, and run that. Number 2. Inside the block of the function you made in step 1, use a conditional statement to check the value of the OK property of response. If it evaluates to a truthy value, call render JSON response and pass in response. Run the code. Okay, so we will do that if statement, if response.ok, then we do this. And in there we pass in response. Let's run that. Now, if you post a URL, you should see the object that was sent back. Render JSON response is a helper function found in public/helper functions. Okay, let's go to number 3. Great, now that you see the raw response object, let me see. Did they give us anything to put in there? Let's shorten this URL. There we go. We ever type cores, or URL is now that, redirect false, and OK if true. That's what we need. So number 3. Great. Now that you see the raw object, you will need to pass the JSON to the next.then. Delete render JSON response with response passed in, and replace it with return response.json invoked. So that's down here, and we want to get rid of it. Right, return response.json invoked. Run that. 4. Below the curly braces of the conditional statement, throw a new error in case response.ok is falsy. Okay. So after this, after the if, throw new error, and they wanted to say this inside of their request failed. We should be able to run that. Oh, I made a mistake. There we go. That should work. And that didn't work either. Let me just replace these quotes. Yeah, these quotes are weird ones, I guess. And run that. That's what I get for trying to save time by copying and pasting. Number 5. Outside of the code block from the first callback function you wrote, add another arrow callback function that takes network error as a single parameter. Console.log the network error.message inside of the callback function you just wrote. All right, so we're going to do that comma again. So after fetch, we're going to have our dot then right here. So before that ends, we will comma, and we're passing network error in this anonymous function. So network error and console.log network error dot message. Let's see if we did that right. Great. We can go on to the next lesson. Fetch. Post request 5. You're almost done with the post request you started a few lessons back. In fact, this time you'll add another .then to the chain to finally make the information available to your web page. If you reset the exercise at any point, you will have to paste your API key again at the top. Instructions. 1. Chain a .then method to the end of the original .then method. That's all the way down. Where's our first .then? Right here. So right here, .then. And I guess that's it. Let's run that. That's it. Number 2. Pass in an anonymous arrow function as an argument for .then. This callback function will take JSON response as its single parameter. Okay, so in this .then, JSON response, and empty body right now. Inside the callback function, call render raw response and pass in JSON response. Okay, we'll copy that and pass in JSON response. And let's run that. Okay, put in any URL in the text field and then click the shorten button on the web page. Make sure to include the entire link, including the HTTP or HTTPS. So we should be able to copy this. It should give us the entire link. Yeah, it has that right there, so we can just click shorten, and we get quite a bit of JSON here. Number of clicks, status active, is public, the shortened URL right here, and so on. Let's go to number 3. Delete render raw response, JSON response. In its place, call render response and pass in JSON response. And then they want us to run the code again. So I'll just paste that over, run the code one more time, put a URL into the text field again, and then click the shorten button on the web page. Notice the difference. Here we go. Take paste here, and click shorten. Yep, and that's a big difference. That's just the URL without any more information there. The render response helper function can be viewed at public/helperfunctions.js. Let's move on to the next lesson. Async GET requests 1. Let's take a minute to appreciate what you've accomplished so far. Used fetch to make GET and POST request. Check the status of the response coming back. Catch errors that might possibly arise. Taking successful responses and rendering it on the web page. That is fantastic. It's the basis of how the internet works. In the following exercises, we're going to take what you've learned about chaining promises and make it simpler using functionality introduced in ES8, async and wait. You read that right. You did the hard part already. Now it's time to make it easier. The structure for this request will also be slightly different. Notice the new keywords, async and wait, as well as the try and catch statements. We'll be going over how to write the boilerplate code for async GET request in the next lesson. And here we see an async GET request. Async function get data. Now it has a try block inside of it and a catch block as well. So the function in the try block has a const and response is equaling await the fetch call. If the response is okay, so if that returns true, const JSON response equals await response.json, and then after that we'll execute some code with the JSON response. Under that, throw new error request failed, we have a catch for error, and it will console.log the error. Let's go to the next lesson. Async GET request 2. We are going to walk through and recreate the boilerplate code necessary to create a GET request using the async and await. Here are some of the key points to keep in mind as we walk through the code. Using an async function that will return a promise. Await can only be used in an async function. Await allows a program to run while waiting for a promise to resolve. In a try-catch statement, code in the try block will be run, and in the event of an exception/error, the code in the catch statement will be run. Feel free to refer to the async await get diagram at any point while completing this exercise. Async/await get diagram. Instructions. 1. In main.js, create an arrow function using the async keyword and save it to a const getData. The async keyword will ensure that the function returns a promise. Check the hint for syntax help. Okay, so an arrow function like this will be const getData and async before the arguments passed in, and then we'll pass our arrow, and that should do it. Let's go ahead and run that. Cool. Number 2. In the code block for getData, we should add a try statement with an empty code block. Okay, let's do that. Try, empty code block. Below the tried statement's code block, add a catch error statement. Okay, so under this one, catch error, and then the block there. The code in the try block will send a request and handle the response. The catch statement will then take care of an error if it's thrown. Check the hint for syntax help. Let's run that and see if it's right. Perfect. Number 3. Inside the catch code block, log error to the console. Since this exercise is an example, we're using console.log to view the error. Generally, developers create a more sophisticated way of handling the error, like redirecting their users to another page, but logging is fine for us at this moment. Inside the code block, they want us to log the error, so console.log error. Let's run that. Perfect. Number 4. Now we have to consider what to do inside of the code block of the try statement. We should start by using the await keyword before calling fetch. Pass in the following URL as a string to the function as its first argument. All right, so inside of try, we are going to await fetch, and this is its first argument as a string. We'll have to save the returned promise in a variable called response using the const keyword. Response will save the responsive endpoint once that information has been sent back. Check the hint for the syntax. Let's make that variable, so we want a const response to be equal to awaiting that fetch call. Let's run that. Great. Number 5. Under response, create a conditional statement that checks if the OK property of the response object evaluates to a truthy value. Under response, we would say if response.OK and open up our block. Let's run that. Number 6. Inside the code block of the conditional statement, await the resolution of calling the .json method on response. Save the returned object to a variable called JSON response using the keyword const. Okay, so in here, const JSON response equals await response .json invoked. Let's try that out. Oh, I didn't read this last piece here, sorry. Since .json is an asynchronous method, we have to await until the promise status is resolved. Then we store the value to know what data the JSON holds. And we ran it, it worked. Number 7. Return JSON response directly below the code you wrote in the previous step. All right, directly below this, return JSON response. Normally, we'd want to use the information from JSON response in a different manner. In this exercise, we're practicing how to write the boilerplate code. Let's run that. Perfect. Number 8. Below the conditional statement, throw a new error. The message the error should raise is request failed. So after the if, throw new error, and inside of there is request failed. An exclamation point. And failed is not capital. Okay, let's run that. Perfect. Let's go to the next lesson. Async get request 3. In the previous exercise, we created the boilerplate code for making a GET request using async and await. In this exercise, you're going to build on previously created boilerplate code to get nouns that describe the inputted word from the DataMuse API. DataMuse API documentation. Instructions. 1. Under the comment AJAX function, create a new arrow function called getSuggestions using the async keyword. You'll be coding inside the arrow function of const getSuggestions for the remainder of this exercise. AJAX function code goes here. Now that's a const called getSuggestions, and that's an async arrow function. Let's run that. Cool. Number 2. Inside the code block of the async arrow function, create a const variable named wordQuery and assign it input field.value. Okay, so inside of here, we're going to make a const called wordQuery equal to input field.value. Let's run that. Number 3. Create another const called endpoints. Assign it value of a string that is URL, query params, and word query concatenated in that order. Okay, so we'll make another const. Endpoint. That will equal, we'll do some concatenation, so I have my backticks. And the first thing is URL. The second one is query params, and the third one, word query. Let's run that. Number 4. Add a try statement with an empty code block. Outside the code block for try, add a catch error statement with a code block that logs error to the console. Okay, so we need a try statement with an empty code block. Try, there's our empty code block. Now we'll have a catch. It will take an error, and it will console.log the error. All right, let's give that a run. Number 5. Inside the try code block, using const, create a variable named response and assign it to await the result of calling fetch with endpoint as the first argument. Okay, let's do that first. We have a const response equals fetch, and the first argument is endpoint. For this API to work within the provided browser, add cache, no cache as the second argument. And I will just copy that one in right after the endpoint, comma, to that. Let's run that. Nope, I must have done that wrong. We had a const response equal, oh, I didn't write await. Await fetch. Perfect. Okay, let's run that. Here we go. Number 6. Below the variable response from the previous step, create a conditional statement that checks if the OK property of the response evaluates to a truthy value. Okay, let's do that. So right here, after we passed all that in, we were going to go to if response dot OK. Inside the code block of the conditional statement, await response.json and save it to a variable called JSON response using the const keyword. Okay, so let's do that now. That's right here. Const JSON response equals await response.json and invoke it. I'm try to just get that on one line for us. That's what we're doing right here. And run that. Great, let's go to number 7. Call the function render raw response and pass in JSON response, then run the code. Okay, render raw response. That will be right under here. And we'll pass in JSON response. And we'll run the code. In the response field, type in a word and click the submit button on the web page. You should now see an array of objects that contain nouns that describe the word you typed in. You can view the purpose of the render raw response helper function at public/helperfunctions.js. So here we need to enter a word, and we've been using enter, submit, and we see the same thing we saw last time. It's an array of objects. Number 8. Now that you can see the body of response, you should clean it up to display on the web page. Delete render raw response JSON response and replace it with render response JSON response and run the code. Then type another word and click submit. So we'll just paste that in there, run the code. We will type in enter again. We will click submit. And there we are. Now it's kind of in order. Great, now you have an organized list of words and you finish your get request. You can view the purpose of render response function at public/helperfunctions. Let's move on to the next lesson. Async post request 1. Now that you've made an async get request, let's start on getting you familiar with async post requests. As with the other get and post requests that you've been making, an async post request requires more information. Take a look at the diagram. We still have the same structure of using try and catch as before, but in the fetch call, we now have to include an additional argument that contains more information like method and body. We'll be explaining the whys and hows of the boilerplate code for async post request in the next lesson. So it is exactly the same, except it seems that we are putting a method and a body. So that's the big change, is the same thing we did last time when we did this without async await. We added a method and a body to the fetch call. Let's go to the next lesson. Async post request 2. Now we're going to piece together a post request using async and await. Feel free to refer to the async await diagram below at any point while completing this exercise. Async await post diagram. Instructions. 1. At the top of main.js, create an async arrow function and save it to a const getData. The async keyword will ensure that the function returns a promise. Okay, so an async arrow function, const getData, points to async here, and then where we pass in everything, and the arrow, and we'll open it up. Let's run that. 2. In the code block for getData, we should add a try statement with an empty code block. That's the first thing we'll do. Try empty code block. In case things go wrong, we need some code to handle that. Below the try code block, add a catch statement and pass in error as an argument. Okay, catch error. Then in the catch statement code block, log error to the console. Console.log error. And let's run that. Number 3. We now have to consider what we want to do inside of the try code block. Since we are making a post request, we should start by using the await keyword before calling the fetch function. We will have to save the returned promise in a variable called response using the const keyword. Let's do that. Const response equals await fetch. And I think that is it. There's nothing to put inside the fetch yet. So yeah, let's run that. Number 4. In the fetch call we just made, pass the following URL to the function as a string for the first argument. Then, as our second argument, let's pass in an empty object for now. Okay, let's take this as a string. And run that. There's our string, there's our empty object. Let's get to number 5. Let's now fill in the request options in our second argument. First, add the method property, and the value is post. Okay, let's do that first. So right in here, method post. Then we have to include a body property, and the value is json.stringify. Okay, so let's do body, and then we'll do our json.stringify with our object. We could paste that right in there. Remember to separate the properties with the comma, which is what I did right here. That's the comma separating the properties. Let's run that. Oh, I did completely wrong. Post as a capital and a string. Okay, run that. Number 6. After the code block of response, we should create an if statement that checks the OK property of the response object. Okay. If response.OK, and that's its block. Inside the code block of the conditional statement, await the resolution of calling the .json method on response. Save the returned object to a variable called JSON response using the keyword const. Const JSON response is going to equal await, and it'll be response.json invoked. Let's run that. Great. Number 7. Now that we have what we want, we should return JSON response directly below the code written in the previous step. Okay, let's do that directly below the code in the previous step. So right here, return JSON response. Like with previous boilerplate exercises, we're practicing writing code. Normally, we would want to do more beyond this step of returning JSON response. Let's run that. That worked. Number 8. Below the if conditional, throw a new error with the message request failed. Okay. Below the if. So right here, throw new error request failed exclamation point, and run that. Nice work. Didn't that feel very similar to making a GET request? Yes, it did. Next. Async post request 3. Since you've created the boilerplate code for a post request, the next step is to incorporate that experience and logic into making a real request. In this exercise, you'll need to retrieve your rebrandly API key to access the rebrandly API. Rebrandly API keys. If you reset the exercise at any point, you will have to paste in your API key again at the top. I'm going to grab my key again. I'll copy it and paste it in at the top here. So where it says your API key, get rid of that, paste in your API key. And that's actually the first instruction. At the top of main.js, assign API key to your rebrandly API key. We could run that. Number 2. Under the comment Ajax functions, create a new arrow function and assign it to a const shorten URL using the async keyword. So under the Ajax function, code goes here. We'll make a const shorten URL, and it's a fat arrow function, and it needs to be async, so we will say async before the arguments, and run that. Number 3. Inside the code block of the arrow function of shorten URL, create 2 consts. One named URL to shorten, and assign it input field dot value. Let's do that first. Const URL to shorten equals input field dot value. The other is named data, and assign it the value of calling json.stringify and passing in an object destination URL to shorten. So a const called data that equals json.stringify, and inside of there I'm going to paste in this object and run that. Please note, we will be working inside shorten URL for the remainder of this exercise. Number 4. Add a try statement and leave the code block empty for now. After the try code block, create a catch statement and pass in error. In the code block of catch error, log error to the console. So we need to do a try catch in shorten URL. After we made these const, we will try, and there's our code block, and we will catch an error, and they want us to log it to the console, so console.log that error. Let's run that. Great. Number 5. Inside the try block using const, create a variable named response and assign it to await the value of calling fetch. Okay. So in try const response equals await fetch. We'll run that. Number 6. In the fetch call, pass in URL as the first argument and an empty object as the second argument. In that empty object you just created, it will have the following 3 properties: method with a value of post, body with a value of data, headers with a value of the object below. And we can see that object here, it has a content type of application JSON and an API key of API key. Okay, so in our fetch over here, let's add in that URL, and then we will comma, get this object ready, open it up. Method was a string of post. Then we will comma to the next thing, which is body with a value of data, which we made right above this. And finally, headers. And that's this entire object, which I'm just going to copy in. There we go. And let's run that. Oh, I keep on doing this with post. Post has to be all capital. There we go. Number 7. Below the variable response from the previous step, create a conditional statement that checks if the OK property of response evaluates to a truthy value. Okay, so below response, after we make this entire call, which starts with this fetch and then it ends here, so right around here, well, we're still in the try block. Yes, we are. Great. This isn't really pretty the way they have this going because of how little of the page it takes up, so I'm sorry if this is a little ugly. But we need to make a statement if response.ok, and that's it. So let's run that. Number 8. Inside the code block of the conditional statement, await response.json and save it to a variable called JSON response using the const keyword. All right, so if response OK, const JSON response will equal response.json invoked. And let's run that. Const JSON response. What did I spell wrong? Equals response.json. Oh, didn't await it again. Await That's something definitely to remember when you do this response.json. You need to await that. This is an asynchronous bit of code here. So you'll get nothing back. You'll just get a promise back if you don't await it, and that's why that turned out red there. Number 9. Call the function render raw response and pass in a JSON response, then run the code. Okay, let's call that function. That'll be after that. And we want to pass in JSON response and run the code. In the response field, you can paste in a URL and click the shorten button. I'll take this one, paste it in, click shorten, and we can see that object that we've seen several times. You should now see an object containing all the information the rebrandly API sent back. You can view the purpose of the render raw response helper function at public/helper functions. Number 10. Now it's time to clean up the response sent back. Delete render raw response taking in JSON response and replace it with render response taking in JSON response. Run the code, then paste your URL and click the shorten button. Okay, so we need to put that in here. Now it's just render response. We need to run our code, and then we could put the URL in again. So here we go. Paste it in and shorten. And you can see it looks a lot better now, and we're just getting the URL back without any more of the data that was sent back from the API. Notice the formatted response. Great job using rebrandly to shorten your URL. You can view the purpose of the render raw response helper function at public/helper functions. And let's go to the next lesson. Review request 2. Let's recap on the concepts covered in the previous exercises. 1. Get and post requests can be created a variety of ways. 2. Use AJAX to asynchronously request data from APIs. Fetch and async await are new functionalities developed in ES6, promises, and ES8, respectively. 3. Promises are a new type of JavaScript object that represents data that will eventually be returned from a request. 4. Fetch is a web API that can be used to create requests. Fetch will return promises. 5. We can chain .then methods to handle promises returned by fetch. 6. The .json method converts a returned promise to a JSON object. 7. Async is a keyword that is used to create functions that will return promises. 8. Await is a keyword that is used to tell a program to continue moving through the message queue while a promise resolves. 9. Await can only be used within functions declared with async. Instructions. Congratulations on learning all about AJAX, request using fetch, async, and await. These concepts are fundamental and will help you develop more robust web apps. Play around with browser and code to make get and post requests. If you're going to make post request, make sure you assign API key your rebrandly API key and run the code. If you want to challenge yourself, rewrite the request from scratch. Replace the helper methods with your own code. Use different APIs to make get/post requests using async await. And that should do it for us. We'll see what it says is up next. And what it says is up next is congrats, we completed the course. For everyone who went through the entire course, you are a rare breed and you know a lot about JavaScript right now. Please check out my other videos, subscribe, like the videos, and come back for more content as I usually cover more advanced topics and real-world applications. You could code along with me to make some real-world applications now right on YouTube. Great job on this, and I can't wait to see you on the next video. Have a good one.